Hi everybody, my name is Gary Reway from Ether Security Lab, and I will be the instructor of this course. I'm a full-time penetration tester, and I also try to put my experience in courses like this. This particular course is about how to do security assessment of web applications and services. I will show you all the necessary techniques, tools, and technologies what you will need to do a web security assessment. Although we are talking about hacking techniques here, I will show you everything from a perspective of an ethical hacker who is paid by the application owner to do a security assessment of his application. So we will go all white hat. In this course, I will use a similar methodology as the one we use at work when we test web applications. We will go through each security aspect of an application. I will explain vulnerabilities and how to exploit them. The course is fully hands-on, so I will expect you to try everything yourself in your own test environment, which we will set up in the next section. I really encourage you to try everything yourself, because only by watching these videos you won't learn too much. Hacking is a really practical thing, so the only way to really learn it is through practice. So do it.
Do it! Just do it!
There are a few things that you shouldn't expect from this course. As I said earlier, we absolutely follow the ethical way. So I won't help you doing anything illegal. We will talk about general web security problems and vulnerabilities through example applications. So we are not going to hack Facebook or anything like that. But the techniques learned here can be applied to any web applications in the future. I also have to tell you that this is not a complete course. Many instructors say things like complete guide to ethical hacking or something like that, which is, I understand the marketing value of this, but it's a lie. In IT, and especially in security, there's no such thing as completeness. There are new programming languages or algorithms or frameworks coming out every day. It's just physically not possible that somebody teaches you everything. So instead of that, I rather tried to make a course which covers everything that you need to do a web security assessment, but it is far from complete. Hacking and security is all about learning new things and Googling a lot. But that's why most people like it, because they can always experience new things and always learn about new techniques and new tools and whatever. So try to enjoy that, but you need to embrace this idea that you will have to learn all the time. So if you don't understand something, then try to Google it. Try to figure it out yourself. Of course, I'm always there to help, but figuring out yourself is the best way to really understand it, and it is really essential to this profession. All right, that's about it for now. So see you in the next lecture. Bye.
If you're tired of starting over, stop giving up.
Hi. So this is going to be a really quick lecture. It's only about the necessary disclaimer I have to tell you to be covered. So there are a few things which you need to know before you dive into hacking. In this course, we are going to do ethical hacking because computer hacking is considered illegal in most countries. So before doing any hacking activity, I recommend you to get informed about the regulations of your own country. Also, only hack your own systems or with the written consent of the application owner. During the course, we will set up a test environment, which is considered to be your own system, so you can work with that. This course serves only educational purposes, so I cannot take responsibility for any of your actions. Some of the example applications are open source software, and I deliberately built in vulnerabilities, so they are not necessarily insecure. But of course, as always, there might be other vulnerabilities which we don't know about. And the most important, you are doing everything in this course on your own responsibility. All right, that was all seriousness for today. Hacking will be fun now, so see you in the next lecture. Bye. Hi, as I said, we'll learn how professional security assessment works. So in this lecture, I will describe you the process of a security assessment. An assessment can be split into three different phases. First is the planning phase, then the testing phase, and at the end is the reporting phase. This course is about the testing phase, although I will talk a little bit about the other two, but we won't really go into details in those. So let's start from the beginning with the planning phase. I consider the planning phase from the first contact with your customer until when the testing is started. So the customer comes to you and tells you that, hey, I would like this application to be tested. And then you decide that you will do that. The goals of the planning phase are the following. So first of all, you will decide the scope of the assessment. Basically, you will have to check out the application, see how big it is, and how long are you gonna test it. Of course, the length of the assessment also depends on the budget of the customer, so you have to work together to find a time frame which works for both of you. Then the customer prepares a test system for you, hopefully not the productive system, because that's a pain in the ass. And then he does backups and notifies all third parties that there's going to be a test on that system. Otherwise, there will be a lot of surprised and pissed people around you. Then the customer gives you the credentials for the system. We usually work with 2 different users per user role, including administrators. Now, a lot of customers ask, why do we need administrator access? Because then it's not really hacking when you already have administrator access to the system. But the thing is that having administrative access to a system really speeds up the testing. If you think about it, you as an ethical hacker, you only have a few weeks to find vulnerabilities in this application. A real attacker has basically unlimited time to test the application and to find vulnerabilities. So it's really difficult to compete with that. That's why we really need full access to the system to make the whole testing efficient. So if your customer asks why administrative access, it's because of efficiency. After the planning phase comes the testing phase. Obviously, the testing phase is where the real testing begins. So you should attack the application only in this time frame. Otherwise, it can be considered illegal. But the most important thing is that the fun happens here. In this phase, you will do more or less the following activities. First, you do the discovery of the application. Basically, you click through the application, do some scanning with various tools. The only goal is to get to know the application. Then you do some information gathering, like Googling on the internet, checking what kind of technologies the application uses, and whether there are public vulnerabilities already in the internet. And then you will try to find vulnerabilities in the application. That is the focus of this course. And at the end, you will do some exploitation. Basically, you need to create proof of concept attacks for each vulnerability that you found, what you can use to prove the customer that the vulnerabilities are real problems, and you need to show what a real attacker would be able to do with that problem. Now, after the testing phase comes the reporting phase. I have to be honest with you, everybody hates reporting. But from a business perspective, that's basically the most important part of your work. The reason is that the customer only sees your report. So if the quality of your report is bad, then it doesn't matter how good job you did and how awesome hacks and exploits you found, the customer will think that the quality of your work was bad. So although reporting is not really fun, but I really recommend you to focus on writing quality reports and giving enough time for you to make that happen. Normally, you will write a report where you detail all the findings that you found and how an attacker can exploit it. Also, we usually do a presentation for the customer where we walk through all the findings and explain how that works. In the rest of the course, we'll talk about the testing phase and a little bit about the reporting at the end. Thanks for watching now. And in the next section, we are going to start building our test environment. So see you there. Bye. Hello. In this section, we are going to set up our test environment. I provide the example applications on a virtual machine, what you can download from etherlab.net/WHT, so web hacking target. Clever, right? Then we are going to use Kali Linux as our testing operating system. So web application testing is pretty much operating system independent. So you could use any operating system what you want. For instance, at work, we are mostly using Windows, but I choose Kali because it's free and I wanted to provide you an environment which we can share so we both work on the same environment. And also we are going to use a few tools which are pre-installed on Kali so we don't have to install it ourselves. And of course, if you don't really know Kali, then this is a really good time to get started with it. At the end, I will quickly show you the Burp suite, but if you're not familiar with Burp suite, then I have a separate free course which focuses only on this tool, so I really recommend you to check that out. You can find it on my website. So this is what's going to happen in this section, so I will see you in the next lecture. Bye. Hi, in this lecture we are going to set up the target machine, which contains all the web applications we are going to hack during this course. Basically, to follow along in this course and do all the exercises, you only need this machine and the Kali Linux, which we are going to install in the next lecture. So hopefully you have already downloaded the file which I shared in the previous lecture. If not, then you can download it from this URL. And when it's finished, you will get a zip file. So first of all, just unzip it, and then you will get this folder, which is basically the virtual machine. So I created this virtual machine with VMware Fusion, but I also tested it with VMware Workstation and VirtualBox. So whatever virtualization software you use, it should be working. Of course, because I created with a VMware product, it will be much easier to install it in another VMware product, but I will also show how you can do that in VirtualBox. If you haven't used any virtualization software before, I recommend you to use VirtualBox because it's free. But I won't really go into details how to use this software. I'm hoping that you already know that. So if you're using a VMware product, just copy this folder to the folder where you're keeping all your virtual machines. And when you did that, then just double click the ether webhacking target.vmx file, and then it will open in VMware, and then you can say take ownership, and then it boots immediately. And this is the console of the virtual machine. And here you can see the three applications we're going to use. The IP address will be different for you because it prints here the IP address which is configured on your machine automatically, and you can open these URLs in the browser to test it. So I can just go to here and let's say (203VE), and this is the Voice of the Emperor, for instance, one of the applications we are going to hack. Also, to log into this virtual machine, I will show you that in a moment. You can use the user ether and the password for ether. You could log in from here on the console, but you can also log in with SSH. If you're using Linux or Mac, then you can do it from the terminal. So SSH, ether is the user, and then the IP address, which will be probably different for you, and then the password, as it says here, for Ether, and then you're in. I will recommend you in various lectures to do an exercise. Most of the exercise is finding the problem which we are exploited in that lecture, or fixing these problems. So to do that, you will have to go to the source code of these applications. So you can find that under /var www.html, and you can change to root user to actually be able to change the code with sudo bash and then for ether and then your root. Here you have all the two applications. So you can just go in, for instance, to VE, then you can find the source code of that application here, if you want to do the exercises, which I really recommend. Also, I recommend you that when you install the machine to make a snapshot, because if anything goes wrong, you can always revert back to that snapshot and then you get a clean system. So if everything works for you, then you can just come to virtual machine and say snapshot, take a snapshot, and call it like fresh install or something. All right, I will just turn it off now and show you how you can install the same machine in VirtualBox. Then in VirtualBox, you actually have to create a new machine. You cannot just import the one you downloaded. What you need to do is create a new machine and use the virtual disk of the downloaded machine in this new machine. So you can do that by coming here and creating new, and then call it either web hacking target, and it's a Linux, Ubuntu 64-bit. That's fine. At hard disk, you should say that do not add new virtual hard disk, and create. And then here you can right click and say show in Finder. It should take you to the folder where this virtual machine is. For me, that's under my home folder and then VirtualBox VMs and then the name of the virtual machine. And then what you need to do is go to the place where you have the downloaded machine and take all the .vmdk files. That's the virtual machine disk. And then copy it and paste it to where the VirtualBox virtual machine is. All right, now that's ready. And then you come back to VirtualBox and say right-click Settings and go to Storage. And under Storage, go to Controller SATA and click on Add Hard Disk. And say choose an existing hard disk. And then when this opens, you have to go to the same place where you just copied the files, which will be for me under Gary, VirtualBox VMs, and Ether web hacking target. And then choose the virtual disk cl1.vmdk and open. Okay, and let's boot it. All right, it booted up as well. You can see the URL is now different, but it should still work. You can also SSH to it the same way. And basically that's it. So we'll use this machine during the whole course. So just make sure it works. And with that, we are finished with this lecture. So I will see you in the next one. Take care. Bye. Hi. In this lecture, we are going to install a Kali Linux in a virtual machine. Kali is a Linux distribution which was specifically designed for penetration testing or any kind of security assessment. This basically means that there are lots of tools pre-installed in Kali so that you don't have to install it yourself. But to be honest with you, for web assessment, the operating system doesn't really matter. Most of the tools we use, they run on Windows or on Linux as well, and because web is operating system independent, you can work really well on Windows as well. For instance, at work, I mostly use Windows for web testing. The only reason I will do everything here in Kali is that Kali is free and open source, so everybody can use that, and also it's a really essential tool for general security testing. So if you're not already familiar with Kali, it's a really good time to start it right now. So first of all, we need to download it. For that, go to kali.org/downloads, and then we are going to use the 64-bit version, and we're going to download the ISO. So start downloading it. It will take some time. As you can see, it's almost 3 gigs. So I suggest you pause and come back when it's ready. So when the download is finished, then go to your virtualization software. I use VMware Fusion, but you can use VirtualBox. VirtualBox is free, so you don't have to buy VMware for this course. You can just use VirtualBox. It works the same way, so there shouldn't be any problem with you doing the whole course in VirtualBox. I also use it a lot. But let's say in VMware, so I create a new virtual machine. I say it's a custom virtual machine, continue, and in the operating system you choose Linux and Linux 3. something kernel 64-bit, and continue, and we want to create a new virtual disk. We'll need more than 8 gigs, but we'll do that shortly. So continue, and then here we say customize settings. We rename this to Kali Web. Save. And then go to the hard disk settings and change this to 20 gigabytes. That should be enough. And then to install the operating system, we'll go here to the disks and choose disk or disk image. Go there and then search for the downloaded ISO image. And say open. And then start the virtual machine. And here in the menu, we choose install. And you can choose whatever language you want to use. I will do everything in English, so I go with English. Yeah, key map is also English. and I will call it ether root password. Choose some, it's like your root password, re-enter. Of course, you could see that mine wasn't secure, but anyways. Time zone, I don't really care about time zone, so I will just go with Eastern. I'm sitting in Europe, so it absolutely doesn't fit to my time zone, but it doesn't really matter. Now, partition method is guided, use the entire disk. This is the 20 gigs virtual disk we created. Yeah, default is good. Finish partitioning and write changes to disk. Write changes to disk, yes. I don't need the network mirror. Also don't need a proxy. And yes, we want to install a grub on the master boot record. Yeah, for the bootloader, we choose the dev SDA. That's the main disk we have. It installs. And the installation is complete, finally. So let's continue. And it reboots, and then we choose to start the Kali. When the login screen loads, then our username is root, and the password is the one which we choose during the installation. So let's log in. Oh yeah, we have our Kali notes. Awesome. Then there's one more thing to do. For various virtualization tools like VMware or VirtualBox, you can install, it's called either guest addition or something similar, and that will make the virtual machine work better in a virtualized environment. This means that, for instance, you could be able to copy paste or from your normal operating system to the virtualized machine, or you can drag and drop files from here and there, etc. I will install that. The problem with these tools that they don't always work. So for instance, sometimes copy pasting works, sometimes not. Sometimes drag and drop works, sometimes not. So we'll install it and we will hope that it works. So first, update the package list, opt get update. And then opt get install open VM tools desktop. Yes. All right, so it's finished. I will reboot. And log in again. And let's see. Yeah, it seems to work, because that was the most important for me, that when I resize the window, then the resolution is also changed automatically. That helps a lot. Whether copy pasting works or not, you can test it yourselves. As I said, even if everything is installed correctly, it not necessarily work. That's how it is. If you use VirtualBox, you can install the VirtualBox Guest Edition on the top of this. That might help you get everything right. Since I will use SCP to copy files to Kali, I have to start the SSH server. So first start the terminal. And we have to configure the SSH to allow password login for the root user. So go to etc/sshd-config and edit it with your favorite editor, and you will have to go to permit root login, and instead of prohibit password, say yes. And then you need to say service SSH start, and that's it. So the SSH service should be running now. We can check it. Yes, you see that it listens on port 22. We'll use that in the future to log on to the server or to copy files. I prefer this over the copy pasting or similar methods because, as I said, they don't always work. So that's the easiest. If you use Windows as your host operating system, then you can install WinSCP to copy files, or you can do it from a terminal, as I will do. But for us, that was all. We have now running Kali Linux. That's what we will use in our future hacking. So stay with me in the next lecture. See you there. Bye. Hi. In this lecture, I will show you how to set up the Burp suite. I will not really go into details about the tool because I created a separate course only about this tool. So if you're not familiar with it, you can just check it out and then come back to this course. You can find the other course at the hackademy.etherlab.net. If you're more or less familiar with the tool, then you can just follow along in this training. I will explain many things anyways, but if you feel any time that you don't understand something with the tool, then I really recommend to check out the other course. So Kali has already a Burp suite installed. If you go to Application, Web Application Analysis, then here on the top you see Burp suite. It's fine, you could actually start working with that, but this is not the newest version. It's the 1703, and I thought it will be better to work with the newest version. So what I'm going to do now is we're going to download the newest version and replace it in Kali so that we can use that in the future. So first off, open the browser. And go to portswigger.net. This is the company who makes Burp Suite. There's a free version, there's a paid version. The free is pretty cool, but if you're doing this penetration testing professionally, then at some point it is really worth to buy the paid version. But right now I will just download the free. So go to download and choose the free one and download. And yeah, download for, actually we were gonna download the jar file. So Burp is written in Java, so it's pretty much operating system independent. Now that we downloaded, let's go back to the terminal. And so it should be here in downloads, yes. And then what we are gonna do, so there's already a Burp suite somewhere, and we want to find out where that is. So which Burp suite, and it's under user bin. So I'm just gonna replace this file. First I will do a backup. So cp/user bin burp, and I will just do a backup here, burp suite.buck for backup. And then I will copy the file what we just downloaded to the location which is in the bin. And yeah, that should be it. Let's try it out. So I go back, Burp Suite. That's not interesting. And you can see that it's the 1.7.15. So that's the newest version. Let's just start it with a temporary project and use the default. Okay, so Burp is running, but as you know, Burp is an intercepting proxy, so we actually have to configure our browser to send the requests through the Burp suite so that we can capture these requests. For that, I like to use a browser extension called Foxy Proxy. So I will just Google for Foxy Proxy. And it's here in the top, add-on for Firefox. Sorry, that is German. So add the Foxy Proxy to Firefox, install, and then restart Firefox. What Foxy Proxy does, it just gives you a convenient way to edit your proxy settings. So if you come here, you can set up proxies. That's what I'm gonna do. We are gonna create a new proxy and say that it's localhost and the port 8080. So it's 8080 because Burp starts a proxy on localhost at port 8080 by default. So that's the proxy we want to use. You can see it under proxy options in Burp. We go back to general and call it Burp. Okay, and now we have a new proxy here. We can close here as well. And then if we right click on this, then we can choose from the proxy list. So we choose the Burp, and I can actually close all these windows. And let's try whether it works. So let's load example.com. So it's loading, and there's a reason why it's loading, because if you go back to Burp, you will see here under proxy intercept that the request what we send from the browser is intercepted here in Burp. That's actually a good sign that that the proxy is working. We just turn the interception off. Then we can see that the example.com was loaded. If you know example.com, that's just an example website, what is used in many RFC papers as a reference website. So you can just load it, that's it. So it was loaded in the browser. And if we go back to Burp, then go to proxy history, then you see all the requests that were sent from the browser, in this case to the example.com. We had two requests, one to load this simple page, here is the response, and then to load the favicon, which was not available because it returned a 404 not found. So that's it. Burp Suite is running. We are going to use Burp Suite all the time. So when you do web application testing, that's a tool which is running all the time, really, because you collect all the requests you're sending so that you can look up things later on, etc. You can play with the request. Again, if you feel any time that you don't understand something with this tool, then check out the other course I made. It's free. It's at hackademy.etherlab.net. Check it out and just come back to this course. And with that, our test environment is ready. We will install a few things on the fly during the lectures, but this is the essentials what you need for web application testing. So that's it for now, and I will see you in the next lecture. Bye. Hi. In this section, we are going to go through the basics of how the web works and what kind of technologies are used. These are going to be really the basics, so if you already have a grasp on this, then you could skip to the next section and start with that. However, if you're new to the internal workings of the web, then this part is really for you. We are going to learn some really important things which we will use throughout the whole course. So let's get started. I'm not going to give you a history lesson about HTTP. You can look that up on Wikipedia. I will rather show you how it works. So let's get into it. So first of all, it's an application layer protocol. So if you look into the networking layers, on the bottom, you have some kind of physical layer, depending on what kind of network you're using, whether it's Wi-Fi or cable or whatever. And on the top, usually we have Ethernet. And on that, we have IP. Of course, everybody knows IP with IP address and everything. And on that, we are running TCP. And on the top of all this, in the application layer, we are using HTTP. So HTTP consists from HTTP requests and responses. So for instance, we have our browser here, and we have our web server here. And when you load a page, the browser sends an HTTP request. And then the server does some kind of processing and replies with an HTTP response. By design, HTTP is a stateless protocol, which means that the server cannot decide from two requests whether they are related or not. If you would like to maintain some kind of state, you will have to transfer it in the contents of the HTTP request. So usually there is a cookie here or something similar. It's hard to read. The statelessness comes from the early age of the web, when only static websites existed. You requested a website from the server and it sent it to you. And that was all. Nothing really happened on the client side or on the server side. Basically, you requested an HTML file and the server sent back that file to you. But the websites were also pretty simple. There was no login or shopping cart or anything basically which needed session information or state information. Since then, the web got pretty far and ways had to be figured out how to keep state information in a stateless protocol. So that's why cookies were invented and added to requests. So after my fabulous drawings, let's see all of this in practice. For that, let's go back to our Kali Linux and open your browser, but also make sure that your Burp suite is running. And also that in your browser, you're using Burp as a proxy. So let's load example.com. We have seen it already when we set up the Burp suite. So the page is loaded. Let's go to Burp. And then we can see here that there was one request sent. And here in the bottom, you see the request. And under the response tab, you see the response. So let's go through what are the elements of a request. So first of all, it starts with HTTP verb. In our case, this is a get, but it could be post or options or put, delete, or trace. Or basically anything other, but these are the official HTTP verbs. It's up to the server what it does when it receives an HTTP verb, but basically the definition is that when you send a get, you're requesting data, and when you do like a post or put, then you are providing data to the server. Also, a very important difference is that GET request does not have a request body, but posts do. So if you look at here, these are the request headers, and then there is no request body. It's because in case of GET, you transfer any information what you want to send to the server in the URL, which will be here. Now we got to the second part. This is the path, what you request from the server. In this case, we are requesting the slash, which is usually translated to the main page, so the index.html or something similar. We can go back to the browser and request something else, like test. Yeah, probably nothing happens, but here we can see that we requested the path test. After that, there is the HTTP version. Nowadays, mostly it's 1.1. Some really old equipments and stuff like that use 1.0, and there is a new version on the way, but at the moment it's more or less always 1.1. After that, we start with the first header. If we click on headers here, it looks somewhat better, but I prefer to see the plain request. I didn't say it before, but what you see here is really the request. So this is the data which is sent through the wire. HTTP is a text-based protocol, so unless it's compressed, it's always plain text. So that's what I meant, that it's pretty easy to work with. So the second line is usually the host header, which basically just states the domain name of the host where you're sending the request. The host header can be important when the server hosts various domain names. For instance, my server hosts etherlab.net and GaryonSecurity.com, which was my old blog. The web server only knows from the host header which page are you requesting. So basically the IP address of these two domains are the same, but there are two websites running on. And the web server knows from the host header which websites you're requesting. Because of that, the host header is pretty essential. The rest of the header are not necessary for the request to be successful. They only contain additional information which can be useful for the server, such as like the user agent, which is like basically the browser. In many cases, that's how a server knows whether it talks with the browser or with a mobile browser or with a mobile app or something like that. Then in this case, the browser tells the server what kind of responses it accepts. So it accepts HTML or HTML and XML or XML. It also sends in information about the accepted languages and accepted encodings, so compression in this case. Let's get back to the first request. So this request tells the server that it would like to get the main page from example.com. And if we go to the response tab, then we see the HTTP response. Again, this is exactly what comes through the wire. These are the HTTP response headers. And after that, there is either content or not. In this case, there is. And basically, this is the content what is received by the browser, and it's going to be rendered by the browser. But let's start at the beginning. So again, the response states the version, the HTTP version, and there is a response status code, which is the 200 OK. Basically, when your request was successfully executed and responded, then most of the time you receive a 200 OK. There are various other codes, like the 300 something codes, which is usually some kind of redirect, or the 500 codes, which are usually internal errors, or for instance the other one which we see here is the well-known 404 file not found. But sometimes the server sends back 200 OK even if the request was unsuccessful. It really depends on the application and server what you're using, how that exactly works. But usually 200 OK means that the request was successful. Anything else means something else. The response also has headers, the rest here, which tells various information to the browser about how to handle this response. For instance, the content type header tells the browser or the client what kind of content it is, what's sent here in the body. If it's text HTML, then the browser knows that it's a simple HTML site and it can be rendered as HTML. It could be text XML, then the browser knows that it's an XML and it doesn't try to render it as HTML, but it just shows it as an XML. It could be also binary data. And then usually you get this download window because the browser cannot interpret the binary. But if it says that it's a JPEG, then the browser can show you a JPEG, so then it doesn't have to be downloaded to a file. It can be just shown in the browser. Then there are a bunch of other data for caching and stuff like that. Usually the server header is important for us in an assessment because it can tell you what kind of web server is in use or what's the technology stack. So it could say that it's an Apache or it's an IIS or something similar. And the content length just tells the client, the browser, how long is the content here. so that the browser knows what to expect. There are also various security headers which can be sent. We will talk about these later when we get to the security headers part. And in the body or in the content, you see HTML. This is the HTML code of this simple website. When the browser sees that the content type is text HTML, then it takes this content and renders it, and that's why it looks as it looks. This is the very basics of HTTP. We'll learn much more about it during this course, and there are endless resources on the internet. So never be afraid of Googling something you don't understand, because that's how you're gonna learn new stuff. So that's about HTTP. I will see you in the next section. So take care. Bye. Hello. In this lecture, we are going to talk about HTML. It stands for Hypertext Markup Language. It's the cornerstone of web applications or websites. Basically, before going all active on the websites, what we had is that you had some HTML files on your web server, and the user could browse your web server with his browser, and it requested an HTML file. The browser downloaded that and tried to render the HTML code in the browser. This was basically for static websites, so for your personal website or your company site where you had information about the company, or for your university lectures. But the point is that these were all static. So there were static files on the server containing HTML code, and the browser just downloaded them and rendered it in the browser. HTML is basically only a way to tell the browser how to show this information. So let's start writing HTML code, and then you will see yourself how it really works. So let's go to Kali, and first open a terminal. Okay, so first let's just make a folder for our exercises. This is gonna be the static HTML, and let's go in this folder, and here we create a file called who is your daddy.html. Now let's open the file. You can use your favorite editor. I'm gonna use Vim or VI, but if you don't have a favorite editor yet, then I suggest you use Gedit. It has a nice user interface. But if you like challenges, then you can start experimenting with VI. There is this Vim tutor. It's a tutorial program for VI. But if you don't like challenges, then use whatever else editor you want. So I will just open the whoisyourdaddy.html. As you can see, it's an empty file. Although we call it HTML, but it's really just a text file. And now I will just write, I am your father, and we save it and exit. Now we want to load this file in the browser. We could just open it from locally, but we can also start a simple web server. Python has a really simple web server which basically shares the files which are in the folder where you're standing. It's called simple HTTP server. As you can see that it's running on all interfaces on port 8000. So we can say localhost port 8000. And we get the directory listing from the web server, and there is this whoisyourdaddy.html. We click on that. As you can see, it's a simple text file which contains "I am your father." Now, if we go back here, I will actually open a new editor or terminal tab. But also there is yet nothing HTML specific in this file. So it's just simple text. And that's why in the browser, there's no formatting to it at all. It just prints the text. So let's add a few things. First, let's try to emphasize the word father by making it bold. In HTML, we work with tags. Tags are strings between the greater than and lower than signs. So this is the B tag because it's for bold. And each tag has to have a starting tag and a closing tag, which is always slash and then the tag name. Now we save it again and reload it in the browser. And as you can see, now the father is bold. So from this point on, it's not only simple plain text, it's already HTML because we are using an HTML tag, which is then translated by the browser, and it's rendered as bold text. Now this is great, we are on the right track. However, if we want to be really compliant and want to follow the rules of HTML, then we should add some default text which has to be in each HTML page. So first there has to be an HTML tag at starting stating that this is an HTML file. And at the end it has to have the corresponding closing tag. And then we need to have a head and also the closing head. And our text has to be in the body. In the header, there are usually meta informations or scripts or similar to that. The main content of the page is always in the body. Now we are more or less conform. If we load it again in the browser, you can see it doesn't make any difference. We can say Ctrl U to load the source code of this page. We can also add some other things like, okay, everybody know who we are talking about, so we can say, I'm your father, Luke.
I am your father.
And then we will add the options what Luke have in this situation. So first we add br/. We can use this if the tag is empty. So if we would say like br and then closing br without any content, then we can use this br and the slash after that. BR stands for break line. So with that, we are basically adding some empty lines. Then we are going to do a list, an ordered list. And in between the list elements. And these are the options what Luke has. First is join the dark side. And then his other option is die horrible death. All right. Let's try to reload it in the browser. Yes, you can see that we added Luke, and then there is the two spaces, and after that, join the dark side or die horrible death. I wonder what anybody would choose. So this is the basics of HTML. There are lots of other tags, like EMG for including images, or the A for making links, etc. So there are lots of other HTML tags. Tags can also have attributes. We will see all that in the future when we try to exploit various vulnerabilities. We'll look more into HTML, but this is the basics. So just to summarize it, HTML is a markup language to tell the browser how to render the content what you want to show to the user, and it's mostly static unless you're using JavaScript, and it comes from the early ages of websites, but of course it's still in use very actively, just combined with other technologies. All right, that's all for now. Experiment a little bit more with HTML. You can try everything in your small Python browser, and when you're finished, then we'll see each other in the next lecture. Bye.
Come with me. It is the only way.
Hello there. In this lecture, we're going to talk about a widespread technique how to create dynamic web pages. In the title, I said PHP and friends, but what I really meant is that I will talk about PHP, but there are lots of similar languages which work the same way. But I choose PHP because I think that's the mostly used. For instance, Facebook uses PHP. But I don't really want to focus on the language itself, but rather on how the pages are generated. So let's look into that. So in the previous section, we had a web page, which was an HTML5. So it contained HTML and some other HTML tags. And it was all static. So you just downloaded an HTML file. Now, in case of PHP and similar languages, what happens is that you have a PHP file. So it's a .php. And it partly contains HTML too. But at some point, it contains a tag. This is a question mark. PHP, and then inside is actually PHP source code. And after that, it can be again HTML. So what happens when you try to load this file in the browser? First, the server will see that there is PHP source code inside, so it will execute this source code. And the output of this source code is again HTML. So to the browser, a page will be returned which contains purely HTML, with everything which was there before. And then where the PHP source code was, it will contain the HTML code which was generated by the PHP code. So at the end, you will have pure HTML. A very important thing is that these things happen only on the server side. So on the client side, it's still pretty static. Not if you need to refresh data, you have to reload the page. And then that PHP code will be executed again on the server side, and HTML will be generated again. All right, this was already too much talking, so let's try it out. So to serve PHP applications, first you need a PHP capable web server. Luckily, the Kali Linux already has the Apache 2 web server installed, and it's configured to handle PHP as well. What we need to do is first start the web server. So service Apache to start. All right, we can check that it's running. It does. Then we can try whether PHP is interpreted at all. So we'll go to the server root folder, which is by default under var www/html. There's index.html. Let's create here a test.php text file and add some code. So let's edit it and insert. And as I said, everything inside this PHP kind of tag is going to be interpreted as PHP. So first I just want to do a hello world. So I say echo hello world. Let's save it and let's load it in the browser. I don't have Burp yet, so just load localhost /test.php. And as you can see, we got the test hello world. Let's look at the source code, the HTML source code of this page, and it only says hello world, so you don't see the PHP tag. It's because the server executed the PHP source code, which resulted in this string hello world. So that means that PHP execution works as expected. But why is this good? It's good because we can embed PHP code in HTML to generate those parts which are not static. To try that out, we are going to extend our earlier grand application whoisyourdaddy.html. So let's copy it here into the web root that was in root/exercises/static HTML whoisyourdaddy. I'll copy it here and rename it to whoisyourdaddy.php and then open. Yes. So first we are gonna add a form. So what we want to do is that this page can be reused not only to talk to Luke, but to anybody else. So we'll first make a form where you can submit your name, and then Darth Vader tells you that he is your father. Sounds good, doesn't it?
No.
So let's start with the form. In the body, I add form action equals to who is your daddy.php, so that the request will be sent to the same PHP file. Method is get. It could be post or something else, but get is the simplest. And then it has one input field called name, which is, as I said, input, and it's a type of text, and its name is name, because we are submitting a name. And there is other input, which will be the submit button. So it's a type submit, and the text on the button should be submit. And with that, our form is ready. Now actually, I still add a line break here so that it looks better. I save it and let's reload. So who is your daddy.php? Looks right, doesn't it? So there's a form with an input field where we can submit. And as you can see, the input is transmitted in the URL as a parameter. This happens because we choose the method get. So it will send a get request to the server, and the get request, if there are parameters, they are transmitted in the URL. Just that you know, this is not a good place to transmit confidential data, because it will be stored by the browser cache or firewall logs or load balancers or even in the web server log. So just don't use get when you're transmitting confidential data. But now we send the data, but nothing happens with it on the server side. So let's change that. Let's go back to our file. And what we want is that here it doesn't say look, it says something which is sent in the name parameter. So now let's delete look. Let's add PHP code to do that. So I will add PHP. And here's the closing tag. And then everything inside this will be considered PHP code. So what we want the name. And it is in the get request. This is a variable of PHP which contains all the parameters from a get request. And from there, we want the parameter called name. And then we just want to return this name as HTML code to the HTML page. And with that, it should be ready. So let's see. I'm your father, Gary. Well done. Now here, this is all the PHP what we are using. The rest is HTML. But it's pretty small, but here we have all the computing power of PHP. We could do anything which can be done with PHP to calculate the information what we want to return. Like we could do, for instance, we could turn the input name to all uppercase. We can do that with the function called str, so string to upper. It's a built-in function of PHP. Let's save and reload the page. I come here and instead of Gary with capital, I just type Gary, lowercase, and submit. And then I get, I'm your father, Gary, uppercase.
It is useless to resist.
So now you can see that here the PHP code, you could do basically anything. PHP is a very strong language. Your possibilities are almost unlimited. Another side note here, this page right now is absolutely vulnerable because it contains a cross-site scripting vulnerability. We will talk about that later on. I just wanted to put it out here so that you don't write code such as this in productive websites. All right, so let's just recap this lecture. With PHP and similar languages, you can extend HTML by being able to generate code dynamically when the page is loaded. With this, you have the full computing power of the particular language, such as PHP. As I said, that still only happens on the server side. So the client side is still static, so you always have to reload the page when you want to update the data. I suggest you to experiment with PHP a little bit, try to write some more complex code, and if you feel that you are more or less understanding how PHP works, then I will see you in the next lecture. Take care. Bye. Hello. In this lecture, we're going to learn about how modern web applications work. It will be pretty difficult to write complex application in a way how I showed you in the previous lecture. So there are hundreds of different frameworks out there in every possible languages which try to solve this problem. Even if you decide which language you want to use, there are still lots of frameworks to choose from. Most of them, however, have something in common, and that's their architecture. They follow a software development pattern called the Model View Controller, or MVC. This concept splits the responsibilities of the application to three different components. Let's see. So first, we have the model. The model basically manages the data. It is independent from any kind of user interface, and usually it interacts with some kind of database. And then the second is the view. It's kind of obvious what the view is. That's what the user sees. The view is responsible to represent data to the user. So if we have our user here, the view sends data to him. In a web application, this is basically what you see in the browser. Then we have the third part, which is the controller. The controller which receives the data from the user, and based on that data decides what should happen. And the controller will interact with the view and the model to instruct them to do that what the user requested. And when everything is ready, then the view will send the data back to the user. Now, this is really a basic definition, and all frameworks have different understanding what are the responsibilities of each component. As I said, there are lots of MVC frameworks out there, like ASP.NET or Ruby on Rails or Django or whatever else. But that's also the reason why it doesn't make sense to learn all of them, because it's not possible. There are so many of them that it's not possible that you will exactly know how each framework works. So basically, what I try to show you here is to understand the workings of the framework in the background, but not really the exact coding of each framework. In this lecture, we are going to work with Django, only because I like Python and I know Django. But the important thing is that you understand the concept, so that if you are going to do penetration testing for a living, when you see any of these frameworks, you have a general understanding what happens in the background. I think understanding a concept is going to be enough to start working with any of these frameworks. Of course, you have to do a lot of Googling when you're doing an assessment. So as I said, we are going to work with Django. So let's first install Django. I will do pip install. Pip is the package manager of Python. So you can install lots of Python packages through pip. And the application we are going to write is going to be a town dispatch. You know, towns are the lovely animals what Luke uses to survive in the snow desert on Hoth. So we're going to write an application which will help the nice guys at the rebellion to efficiently reserve towns for their travelings. So first go to the exercises folder, and we're going to start a Django project here with Django admin start project, and we will call the project town dispatch. You can see directory was created. And there's the manage.py. That's a Django file what we can use to manage this project. And then there is our project called town dispatch, and it has 4 files: init, settings, URL, and WSGI. I'm not gonna explain everything about Django. I will just tell you all those things which are necessary for this simple application. First, let's go into the settings. And then I go to the installed apps and add our project. Town dispatch. With that, we are hacking a little bit the Django structure, but I want to keep it as simple as it possible. I will make this window a little bit bigger. And now Django takes over all the database management for us. For that, first we have to create the database. We can do that if we go back a folder and then say Python manage.py migrate. As you can see, based on the necessary components, it created all the necessary databases and tables. All right, let's go back to the town dispatch folder, and first we are going to create the view. So it's called view.py, and we are using the Django .http and importing the HTTP response class. And then we say def index. This is going to be the function which is called when the index page is loaded. So it gets a request as a parameter. And first, only for testing, we return an HTTP response using the string index. So it's going to be a simple HTML file with the string index. And then we are going to have another view, which is the town request. This is going to be called when we are requesting a town reservation. And say return. Again, we are yet only gonna test whether it works, so we just return again a simple string. So basically here we define that we have 2 views. One is called index, the other is the town request. And so far it's gonna only return the string index or the string town request. All right. Although we have the views now, but the application doesn't know what to do with them. So the MVC frameworks are really different from the traditional websites, because now we are not really requesting files which are going to be either executed or delivered, but we are talking with a framework. So basically, when we are loading a URL, it's not pointing to a file anymore, but the framework will have to know what to do when this URL is called. So somehow we have to tell this to our application that we want to execute these views when specific URLs are called. We can do that in the urls.py. You see there is already a URL for the admin page, but that we are not going to use that, so we are going to override this right now. All the URLs which are relevant to the application should be listed under this URL patterns array. So I will need two URLs. This is a regular expression here. And the first is the request. And then here in the second parameter, I tell that whenever the URL request is called, then the town request function should be executed. I also have to import it so that we can execute. So from town dispatch.view import index and town request. So from the views, we are importing these two functions. The town request function is called when the request URL path is requested, and then when the page is simply loaded without a specific path, then the index should be called. Index. All right, that should be it for the URLs. So we have two URLs which are calling the two views. Let's test this first. So we go back one folder and then call Python manage.py and run server. This is the test server of Django. And it tells you that it runs on localhost port 8000. So let's go to a browser. So let's call localhost and port 8000. Let's see. Yeah, so we first called the root, then we received the text index because the index function was executed. And now if I called the request as we defined in our URLs file, then we get the string town request because from the views, the town request function was called. This is basically what's called routing in MVC applications, that you have some kind of URL list and the routing knows what part of the code should be called when that URL is loaded. This is basically the controller of the application. So we have now a controller and a view, but we don't have the model. Let's change that. Let's create models.py. And in the models.py, I will first load the models from the Django DB. And then I create a new class called reservation, which inherits from the models.model. So as I said, in Django, you don't interact with the database directly. You create a model for your database. That's basically, you create classes. A class is a table, and then you The class have attributes, and those are the columns in the table. In our model, we need two attributes, one called name, and that's going to be a character field. It's called char field. And we can set the max length to 30. Hopefully nobody has longer names than 30. And then we have a date. That's a date field. This table will have a third attribute that's an automatically created ID field. We were going to use the ID field as a reservation number later. So we have a reservation table with 3 columns, name, date, and ID. And with that, our model is more or less ready. So let's close this. And now we have to tell Django to actually create this table in the database. So we say Python manage.py make migrations and then our app name. So you can see that the reservations model was created. We do migrate as well. And that's it. Our database is ready to run. At this point, we have the model, the view, and the controller, but we have to improve the controller and the view so that the application actually do something. First, we are going to update our views. We will add the form so that you can submit a downtown request. So first, I will create a folder called template. This is where our templates for our views will be stored. And there I create an index.html. So this index.html is going to be a simple HTML file. Which will contain a form, which will send a request to the URL request, because that's what we defined in our URL spy. The method will be post, and it will have 2 input fields. The first is name. It's an input type text. We call it again creatively name. That's it. And we add a line break after that. And I will just copy paste this line and change it to be date, type text, but it's called date. And then again, we need a third input field, but that's the submit button. So it's type submit and value, the text of the button should be submit. All right, actually let's reserve. And with that, our form is ready. All right, so we created a simple form so that the user can submit a name and a date to the server. Let's close this. We still have to change our views.py so that the application knows that it should return this index.html when the index is loaded. So we say downtown dispatch view, and here instead of returning an HTTP response, object, I will import the render function from Django.shortcuts, render, and then I can remove this and say render request and index.html. It will search automatically in the templates folder for the index.html file and return that. And of course, if you would load now the index, you would get the index.html, but if you submit, nothing would happen. So we need to update the downtown requests function as well, so that it does something. I will just import our model from models, import reservation. This way your views have access to the database. And here, let's check whether the request have a name and a date parameter in request.post. With this, we check that the post request which was sent has a name parameter, and then that it also has a post parameter. Or then it has a date parameter, sorry. And if both parameters exist, then we create a new reservation object. So basically a new line in our table. You do that with the reservation class. And the name should be the name from the request, and the date should be the date from the request. All right, so we have a reservation object. The object is created, but it's not yet saved in the database. For that, we have to say reservation.save. And with that, we write the database. And if that's all done, we can return. But in the response, we say that your reservation ID is, and it's a string, and the string is reservation.id. So we'll return this text with the newly created reservation ID. We don't do too much error handling. We just say if there is no name or date supplied, then we return with another HTTP response saying that something went wrong. No town for you today. Sorry.
Steady. Hey, steady, girl. Hey, what's the matter?
Okay, so just to recap what we did, we said that if the index is called, then the index.html should be sent back to the browser. And if the downtown request is called, so a new downtown reservation request is sent, then we check whether it has a name parameter and a date parameter. If both exist, then we create a new reservation with these two parameters, and then we save that in the database. And at the end, we return the reservation ID to the user. If these parameters were not supplied, then we just give an error message back. So let's try this. I quit. Before we start the application, there's one more thing to do, which I forgot. Django is a pretty cool framework because it has lots of security in place by default, which of course we have to turn now off or at least some of them, because we are not implementing them in the application itself. So we go to the town dispatch folder and open the settings pie. And then we go to the middleware section. Basically, the middlewares are code which is executed in the background automatically. For us, what's problematic is the cross-site request forgery protection, because we didn't build it in the form what we created. So we will turn it off now. By the way, we will learn about cross-site request forgery shortly. It's a pretty interesting topic. So what I just do, I will just comment out this line, the CSRF line, and then that should do it. And then let's start the application. So Python manage.py run server. It's running. And then let's load the index. So localhost 8000. We got the form. So I tried to reserve a town for myself for 2017, 5th of May, and click on reserve. And we got that our reservation was successful, and the reservation ID is 1, because basically that was the first element in our database. Now let's go back a little bit to the project, close the server. And what I want to show you is that Django by default uses a SQLite database. That's basically a database written into one file. And you can see it here, the db.sqlite3. And we can open that with the command sqlite3. We can open this file. We get the SQLite prompt, and then we can execute more or less normal SQL queries. First, but in SQLite, you can ask for the tables by .tables. These are all the tables which our current application has at the moment. Most of them were created automatically by one of the middlewares or whatever, because all the session management is turned on and user authentication and all that thing. What's interesting for us is that you can see this table here. It consists of the project name and then the name of the model class, which was the reservation. Let's look into that table now. So select everything from town dispatch reservation. And with that, we are basically listing all elements in the table, but there is nothing else right now there except the one reservation we made. I will open a new tab to start the application and do another reservation. And then we can go back here and then reserve one for Luke for the day after. And he got the reservation ID too. And if we go back to the database and then we check the town dispatch reservation table, then you see that there is now another entry, a reservation for Luke. At this point we are finished. Now the Rebellion has a convenient way to manage its town resources. Yes. Of course, I admit the application needs a little bit of visual tuning, but it's up to you. So I suggest you to play a little bit with Django, experiment, see how it works. It's not a super easy framework, but it's pretty cool. And as you could see, there's a lot happening in the background, even in a small application. But I hope it kind of showed you the concept of MVC applications. Other frameworks use the same concept. So there is the controller with the routing URLs. There is some kind of model for the talking to the database. And then you use the views and templates to create the pages for the user. This is pretty complex, but don't be afraid. To be a good penetration tester, it doesn't mean that you have to be a good programmer. I'm not a good programmer myself, but I consider myself a good penetration tester. So the important thing is that if you don't understand something, then Google it and try to understand it. Okay, I hope you enjoyed this lecture, and I will see you in the next one. Bye. Hello. In this lecture, we are going to talk about one of the ugliest programming languages ever made. But you know, I'm not here to judge, but it's true. So we're going to talk about JavaScript. But to be honest, JavaScript saved the world when it needed a savior. This was the time when it was already hard to live with websites where only the server could do computing, and in the browser it was just static HTML. This was also the time when the sentence refresh the browser was just said too many times. Because if you wanted your content to be updated, then you had to refresh the page. And then came JavaScript and brought dynamic programming capabilities to the browser. Since then, websites are moving and jumping, all thanks to JavaScript. We even got so far that there are programming frameworks where most of the computing happens in the client side in JavaScript, and only the model in the database is on the server side. So when you do a security assessment, it really depends on the application and the framework. Sometimes you just need to read a little bit of JavaScript to see how it works, but sometimes you will have to really debug obfuscated JavaScript code, which is not that much fun. But in this lecture, we are not going to go so far. We're just going to try JavaScript so that you understand the basic concept, how it works. So first of all, let me draw a little bit. So as I showed you in PHP, you have the server, and then it has some HTML, and in it has some PHP, like that. And then when this sent to the browser, then it's just pure HTML. And because it was here pure HTML, it couldn't be dynamic because that was just static code. With JavaScript, what happens in the browser, that's really important, is that it receives a code which is partly HTML, as we have seen before with random HTML tags. But then there is a script tag, and then this is here, that's pure JavaScript code until the script tag finishes. And after that, it's again HTML. So the browser is going to start to render the page. It will do what the HTML says. There could be also CSS in the background, but let's not go into that. And then it comes to the script tag. Then it understands that it's probably JavaScript, and then it's going to execute the script. And basically, JavaScript is just yet another programming language, which in this case runs in the browser and is able to manipulate the page, send requests, etc. So you have the full programming capabilities of JavaScript inside your web page. And with that, you can use that to modify your web page, like update the list or change something or replace pictures, etc. So that's what really gives the dynamic to the web page, is what we basically see every day. You can also use JavaScript on the server side with using Node.js, but we're not gonna go into that. For us, it's more interesting how it works in the browser, because that's what we will be able to exploit later on in various attacks. So to try things out, we are gonna go back to our Who is Your Daddy application. As you remember, we have the whoisyourdaddy.php in the root folder of Apache. And I just turn the syntax highlighting on. And as you can remember, there is a form. If you submit the form, it will write, "I'm your father," and then use the name in the form, and then list the options you have or Luke has. So what we want is just to do a little bit of eye candy. We want these two options to appear after each other with 2 seconds delay. That's what we are going to implement in JavaScript. First, I will give our list an ID so that we can reference it later from the JavaScript code. And then here I start writing our script. Very important that it has to be in a script tag. There are other places where you can include JavaScript and it will be executed, but mostly it's inside a script tag. So first I will create an array of the options we have. Options is and then I copy paste these 2 options there. Actually, I can delete them from here. But this will be a simple string in this case, separated by a comma because it's an array. Yeah, so this options array holds our options, what we want to print. And then we create a function. We call it update, and it gets a parameter called counter or CTR. So that's how a function looks like. And first we need to find the reference for the list we want to update. For that we use the document. That's a built-in element in browsers that corresponds to the current document. So basically this web page where the JavaScript is embedded. And for that we use the get element by ID. Again, it's a built-in to find elements using their ID. As I said, that's why we gave an ID to the list, this one here, so that here we can find it easily. Then we are going to update this list by saying list.inner HTML. That's basically all HTML code inside this element, and it's going to be plus equals, so to add to it, and we will add the options CTR. So the counter element from the options array. So basically now we have to call this update function every 2 seconds and say the number of the element what we want to add to the list. And we do that with a for loop equals 0 until e less than options dot length. This way you can add more options to the list later on and it would still work. and I++ to keep going forward. So that's our for loop. And one really important attribute of JavaScript, it's that it's non-blocking. So functions are called, things are executed, but JavaScript is never idle. So it's not going to stop. It will call a function, but then immediately continue with the next line. This means that, for instance, we cannot do sleep. So we cannot just tell the code to wait. What we can do is set up timers where we tell the timer which function to call after how much time. So basically we set up a timer, tell it to call this function after 2 seconds. It looks like this: set timeout, and this is the function name, update, and we say 2000, and then 2000 milliseconds times I plus 1. So if you look at the set timeout, the first parameter is, as I said, the function which should be called after this much time, which is in milliseconds. So I added this, oh, it's actually wrong, I plus 1, so that a timeout is set up for each option after each other, but the timeout is always 2000 milliseconds more. That's why we have the counter here. So the first option will be called with 2000 milliseconds, the second will be with 4000, etc. And the last parameter is the parameter which should be given to this function when it's called. In our case, that's just a counter, so that we know in the update function which option to add to the list. And that's basically it. Let's see how it works. We need to start Apache if it's not running. And then we can try it out in the browser. Who is your daddy.php? And you see it's already running, and there are all the options. We can try it again, join the dark side, and die horrible death. So it works. JavaScript will be really important for us in the future. We will exploit it in various attacks. So you will definitely need a basic understanding of how it works, but we will talk about it some more during these attacks. So don't worry if you don't understand everything just now. But let's recap what we did. So we updated our whoisyourdaddy.php site. That list of options are coming with 2 seconds delay. For that, we added this script tag, which is used to embed the JavaScript. We defined an array of options. We created a function to update the list. This line finds the list on the page, and this updates the HTML code of the list. And then we created a for loop to go through all the options and created a timer for each option, always with 2 seconds more delay, and the counter to know which option to add to the list. So another important thing to note here is that all the HTML code is static during the whole time. Then we have this little PHP that's going to be executed on the server side. And then we have the script tag with JavaScript, and that's going to be executed in the browser. So basically now we have programming and dynamic elements in both the browser and on the server side. For now, this was a simple example. I recommend you to play a little bit more with JavaScript. If you can go to jsfiddle.com unauthenticated.net. It's a really good site to experiment with JavaScript code because it's really convenient to test JavaScript code there. And of course, this solution, what I did here for the problem, is not necessarily the best. So if you happen to have a better solution, then it would be really great if you would add it in the comments so that the others will see as well, and I might also learn something new. So this was all for this lecture. I will see you in the next one. Bye. Hello. In this lecture, we are going to start our assessment. As I told you at the beginning, there are 3 parts of an assessment. First is the planning phase, then the testing phase, and then the reporting phase. Now we are at the first day of our testing phase. Our goal right now is to get to know the application as good as possible. So what we're going to do is called application discovery. Usually when we work with customers, we ask for an application walkthrough where the customer shows us how they use the application, or actually how the users use the application. But of course, if you don't have a walkthrough, it's still not a problem, just you have to do the whole discovery yourself. There are some key aspects what you want to find out during the discovery. First is how the application works, how the users use the application. What is the technology stack? So what kind of frameworks and technologies are in use? Are there different user roles or not? What inputs the application have? That's very important. How can the user send the data to the application? And of course, what's the loot? What is that what an attacker can steal? What can an attacker gain from the application? That's basically to find out the motivation of the attacker. In this lecture, I'm going to talk about the manual discovery. In the next lecture, we are going to talk about the automated discovery, but I just want to put it out there right now that I don't really believe in scanners, so I think the manual discovery is much more important because that's where you really learn how the application works. So let's start. All right, so first start the Burp suite. From now on, we are going to use the Burp suite all the time. And because with that, we are basically recording each request what we send through the Burp suite. And I also start the browser. All right, both are running. Let's make sure that the requests are sent through the Burp. I will just load the example.com. Yes, it was intercepted. I can turn the intercept off. And then from here on, we see everything here in the proxy history. That's a little trick to change the ordering of the requests, because then you always see the newest on the top. Then let's go to the console of the virtual machine. On the console, you can see the URLs of the web applications we are going to test. The one we are going to work with right now is the Voice of the Emperor, and it's available on this URL. You need to check your console because the IP address might be different on your installation. Although we are talking about ethical hacking, but just the fun of it, we will search vulnerabilities in the applications of the Galactic Empire. So we are the part of the Rebel Intelligence, and other agents have already obtained credentials to this application. I will show you that when we get there.
It's spread throughout the galaxy in a vain effort to engage us. It is relatively unprotected.
But let's load the URL first, and then you will understand everything. So the URL was 92.168.203/VE4 Voice of the Emperor. Oh yeah. Our intelligence also told us what this website is. This is a newly created official page for the Imperial Public Affairs, aka the propaganda. So let's look around. Our first task usually when we do a discovery is basically just to click the application through, see what's there. So there are some posts here. Oh, they are looking for Hackers. At least now to protect our galaxy. Well, it's up to you. So there's recruitment, and yeah, this is the post, and oh yeah, there is a post about destroying the Alderaan. All right, let's go to the about page. Yeah, that tells us what this page is. Good. There's a search field here. And, yeah, you can just get back to results, but it doesn't say which to. You can see here in Burp, everything what we've done so far is listed here in the proxy history. We'll come to that later. All right, so that's not too much. It also says here that powered by Anchor and Barhope. We don't know what that is. Let's find out. For that, I quickly turn off the Burp suite so that it doesn't collect when I browse other pages. Normally what I do in assessments is that I have a different browser, so like Google Chrome, what I use just for internet browsing, and I have a separate browser like Firefox to do the assessment with, because then I don't have to turn Burp on and off all the time. But let's see what's this. Oh, it's the blog engine. So as you can see, it uses this blog engine called Anchor. It's open source. So it's basically a very simple content management system, CMS. And if you look, you can also already see here in the files that it uses PHP. And it's a very good thing that you have the source code, because whenever you have something you might think is attack, you can check in the source code why it doesn't work or why it works, etc. Scroll down in the requirements, you see that it uses PHP and MySQL. That are also really important things to know when you're actually doing exploitation. Then there was another thing here, this Barhope. Let's see. Oh yeah, basically this is a theme for the Anchor CMS. It's also PHP. So basically the code of the web application is based together by the core Anchor CMS code, which is here, and the code of the theme. Of course, it's possible that the Imperial folks have changed the code so that it's not exactly the same as here on Git, but it's always a good thing to start with. And if we go back to the main Anchor website, then you can see there is a docs part, so let's check that out. As our good friend always says, read the freaking manual. So that's always a good thing to have documentations. We usually request the documentation from the customers, but if you don't have it, it absolutely makes sense to search the internet. Also, here in our case, we found direct link to the technologies which are used. But in some cases, you don't have a direct link, but you see it in the, I don't know, in the HTML code or in JavaScript or something that it uses some kind of technology. Then you need to Google it and you need to check it out what that is and how it works, because that's how you will understand how the application works. But if we go back to the docs, then there is an important part. It says there's an admin interface. Let's go here. And if you look here on the picture, it's hard to see, but it says it's under admin. And because it's about the post, that's under admin post. So let's see this admin interface, because that's something which we wouldn't have found otherwise. I will just close these and say admin. And yeah, we got to a login screen. As I said, our intelligence supported us with a login. the user is admin, and the password is long live the emperor in camel case. Note that there is also a forgotten password feature that can be also useful later on. Let's log in. We got in. I forgot to turn Burp back on, so I'll just do it now. So this is the admin interface. We also learn here the exact version of the anchor which is used. That can be important when you're looking for public vulnerabilities, because from the version you can see whether the page you are testing is affected or not. And then let's look around here. So you can create and edit posts. Yeah, there's log, description, status. You can add custom CSS and custom JS and something with the image. All right. You can also alter the existing posts. Then there are comments, but there are no comments yet on any of the posts, so it's empty. Then you can add new pages. There's the about page. Here are quite a few input fields, which will be interesting later. There are categories. You can also create new categories. There are users. As you can see, there are 2 users right now. One is the admin, for which we have the credentials, and there's another one called script admin. That sounds also interesting. We'll get back to that later. And you can create new users. Here you can see everything which a user needs. And here we see that there are 3 possible user roles: admin, editor, and user. Probably the user is the one who cannot log in. And there's an extend where we can edit page types. Here are some input fields as well. You can create new custom fields. Variables, it's also interesting. You can set variables for the website. We don't know what all these things do right now, but it can be really useful in the future. Yeah, here you can set the theme. Plugins doesn't work yet. And of course, there is a logout, which brings us back to the main page. So as far as we could see, that's all what our application does. Let's go to the Burp suite a little bit. I've already showed you that under the proxy history, it collects all the requests which were sent. Like this is how we logged out. But there's also a better view. It's under target. This is the target module. And here you can see all the URLs or all the pages where requests were sent. And here under this domain is our web application. And you can see the same data what's here in the proxy, or basically the target collects all the data which was somehow collected through the application and structures it in this format, which can be really useful. Sometimes there are like lots of requests sent, so like your history is just spinning when you load a page, because when you log in there will be like 50 requests sent. It's really hard to track it. When you come into here to the target, here you will have a really structured view of what happened, and you can just drill down and see what's here and there, which request was sent to the admin users, what was in the request, what was the response, etc. So it's a really practical view, because if you understand, then you can try to find anomalies or suspicious stuff which could lead you to a vulnerability. By discovering the application, you are essentially understanding the attack surface. The bigger your attack surface is, the higher your chances are that you find something. So let's recap what we found out so far. So we learned a lot about technologies. It uses the Encore CMS system with the bar hop theme. It uses PHP and it runs on Apache web server. We know the version information for this as well. It also uses MySQL and runs on Ubuntu. We also learned a lot about the features of the website. It's generally a pretty small website. The public part is very small. You can only search, so that's your only input field. And then otherwise you can just browse the posts which were posted. But there is a bigger admin interface where there is a login, there's a forgotten password feature, and in the admin interface you can do much more. There were lots of input fields which you can test later. You can create posts, you can create pages, you can create categories, you can add extensions like site variables or site metadata. You can add new users, that's really important, and or change the current ones. And of course there's a logout. So more or less that's your attack surface for this application. The technologies and the features of the application, because these are the things what you can attack during an assessment. All right, that's basically the application discovery. As I said, the goal is to understand the application. This is a really small application. In some cases, the application is so big and so complex that it's impossible that you will understand everything. In some cases, it also needs some kinds of special skills, like understanding the topic, like finance, or I don't know if it's a medical application, then you need to know what it is about, etc. So it always depends on the application, but we are lucky because this one is pretty small, so it was easy to go through in a few minutes. In the next section, we will continue with the automated discovery. So I recommend you to play a little bit more with the application, look at the requests, look at the responses. If you find out something new, what we didn't talk about, then post it in the comments below so that everybody else sees it. Otherwise, I will see you in the next lecture. Bye.
The Death Star does have a strong defense mechanism.
Hello. In this lecture, we are going to talk about automated discovery. I told you earlier that I'm not really a big fan of scanners, but they are usually cheap, so why not? When I say cheap, what I mean is that when you already have the scanner, then starting it only takes a couple of minutes. So basically, if it gives you any findings, then that's practically a gift, because it didn't cost you anything apart from that few minutes what you used to start it. With that said, the important thing is that you don't expect the scanner to do your own work. I will show you two scanners. Both are open source and free. One is Nmap and the other is Nikto. Nmap is a more general port scanner, which is usually used in network assessments, because you can also scan a huge network very quickly. We'll only scan our own machine, but the advantages is that it can give you a good understanding about the target machine, not just about the web application. On the other hand, Nikto is also an open source software, but it's a web application scanner. That means that it focuses only on the web application, but it's really useful to find default pages like Tomcat management interface and things like that. If it finds something interesting, a well-known vulnerability or something like that, it also notifies you about it. So let's start first with Nmap. Let's open a terminal. I didn't say it earlier, but both of these tools are command line tools, so we will work in the command line in this lecture. So Nmap is installed by default on Kali. It is a very well-known tool. It basically sends a bunch of requests to the server, and based on the server responses, delays, or any special attributes, it tries to guess the open ports, the running services, or even the operating system. You can just simply type Nmap, enter, and you immediately see that Nmap basically have unlimited command line options. You can guess that we are not going to use most of them. First, we'll just do a scene scan, which is here. That basically sends a bunch of TCP SYN packets. These are the TCP packets to open a TCP connection to the server, to the specified TCP ports. And based on the response or the lack of the response or on delays, it tries to decide whether the given port is open or closed. So let's start that. Nmap, the SYN scan is lowercase s and then capital S. And then we will want to scan all TCP ports. That's from 1 till 65535. And then we just give the IP address. Again, check the console of the target machine if you don't remember your IP address. That's it. Let's start. The scene scan is usually pretty fast. As you can see, it found 3 open ports, 22, 80, and 443. This is not a surprise. 22 is for SSH, and 80 and 443 are for the web server. One is for HTTP, and the other is for HTTPS. Now, in case of the SYN scan, Nmap tells you the service, but it bases the guess only on the number of the port, because all these ports are well-known ports, so it just guesses the service from there. It doesn't really check what kind of service that is. The good thing with SYN scan is that it's fast and it's pretty safe, because running Nmap in a production environment can be problematic if you do a more aggressive scan. But ours is a test environment, so we can be as aggressive as we want to. So I will do another scan. It's called -A. You can look it up here what -C does. It tries OS detection, version detection. It executes scripts to try to find out what kind of service that is. And it also tries traceroute. The ports are the same. Let's start. It will take a little bit longer, but it's still pretty acceptable. All right, you can see that we got now somewhat more information, because now it really tested the services to find out what's behind that port. So for SSH, it found out the OpenSSH version. From here, we will know again that it's an Ubuntu, what we have found out earlier. There are also a few SSH host keys, what you can see here. About the web server, it found out that it's an Apache 247 on Ubuntu again. And the 443 is also for the same Apache, but it runs SSL. You can see the SSL certificate data here and the dates. And here is the OS detection. It's a Linux. It also makes a guess about the kernel. We haven't found anything surprising, but any of this information can be somehow useful later. As you could see, you can tune Nmap forever. I recommend you to read through the command line options just to understand what is the tool capable of. It's really useful in network assessment when we have to test a lot of computers in a short period of time. All right, our second tool is the Nikto. It is web application scanner, so it focuses on web. And it also have a few command line options, but as I said, most of them are not going to be useful for us right now. We are going to do some pretty basic scans. So let's do a simple scan, Nikto -host, and then you give the URL, the IP address, and then we can say -root, because the root folder of the application is not the slash, but it's the /ve, and that's it. Let's start. All right, as you can see, Nikto also returned us quite a few things. It tells us again that it's an Apache on Ubuntu, PHP. It also tells us there is no anti-click checking header, so a click checking is a possible attack. There is no cross-site scripting protection header set. There is no content type options header set. There is an Anchor CMS cookie without HTTP only flag. We'll talk about this later. It tests which HTTP verbs can be used. And here there are quite a few things which are pretty weird. So they are most probably false positives. You need to check them manually. But for instance, these things looks like ESP.NET. So we can try what happens if we load this URL. Nothing. What happens many times with Nikto, and it's the case probably here as well, that it loads a URL, and if there is some content returned, that it thinks that it's vulnerable. But in our case, we actually get an error page, but it's still some kind of content because it's still part of the website. But Nikto doesn't understand that, so that's why it gives us these tips. But if you use Nikto a lot, then you will get used to it quickly what kind of false positives Nikto gives you. Of course, for instance, we didn't test yet the admin page. You could tune Nikto a bit more, and that would be a good exercise for you. So try to do a Nikto scan in a way that it also tests the admin page. And just a little hint for that, you have to log in the browser, and you need the Anchor CMS cookie, and you have to tell Nikto to use this cookie to actually get access to the admin page. For that, check out the Nikto config file that's under /etc/nikto.conf. So as you could see, we haven't had so much luck with these scanners. We found out a lot of information which we already knew, but you can also start with the scanner and then these information will be new for you. But the thing is that it only costed us a couple of minutes. So in some cases you will get lucky and Nikto will give you immediately vulnerability what you can exploit right away. And that's awesome because it just costed you a few minutes. So I said already, scanners are not the solution for everything, but it makes sense to use them. So use them, but don't trust them. Also, there are a lot of scanners out there. Some of them are free, some of them are really expensive. So it's up to you what's your budget or what's your customer's budget. But to be honest, I think you're not here on this course to learn how to start a scanner. You're more likely here to actually learn how to hack manually. So we'll stick to that in the future. That said, we are finished with the application discovery. I want to emphasize that this is a really important part. You learned a lot about the application, which will be really useful in the future when you're actually trying to attack the application. So never try to skip the discovery part just because you want to save some time, because you're actually going to lose more time later on. So thanks for watching, and see you in the next section. Bye. Hi. In this section, we are going to talk about attacks against the session management of an application. But for that, first we have to understand how session management usually works. And this is what this lecture is about. So if you're a developer, you probably know all of this already, but it might be a good refresher. So let's start. So first of all, as I mentioned in the lecture about HTTP, it's a stateless protocol. This means that if you send two requests to the same server, it has no idea that they came from the same person. So here is your browser, and here is the web application. And when you send a request and then you send another request, the web application has no idea that this request comes from the same person. Of course, it will see the IP address, but the IP address doesn't really tell anything. If, for instance, if you go to a cafeteria and browse the internet from there, then you will have the same IP address as everybody else there. This was a big problem for web applications. To solve this, the idea of the session came along. The session is basically just an object kept in memory by the web application so that it can identify each user. So when you come and you send your first request to the server, so basically you open the page, then the web application will create a session in memory. It will have an ID, and if it already knows your username, then it will have your username, etc. And then in the response, you get this ID back, and every time when you send the request again, this ID will be in the request. And that's how the web application knows that this ID is for this user. If another user comes and sends a request, then the application creates another session for that user and gives it the ID as well. And after that, that user will always use that ID. In the browser, usually this ID is stored as a cookie, and that's how it's transferred to each request, because the browser will attach the cookies for that actual application to each request automatically. One important point is that the session ID has to be protected. If you're logged in and somebody can steal or guess your session ID, then he can hijack your session because the server will think it's you. So if, for instance, this one is an attacker and he figures out your ID and sends a request with your ID, then the browser will think that this user is you. So let's talk a little bit about how cookies work. When the server sends a cookie in an HTTP response, browser, let's say for instance this is Facebook. You open Facebook, log in, you get an ID, then the browser will store that for Facebook you have an ID as a cookie. And every time when you send a request to Facebook, it will contain the ID as a cookie. When the server issues a cookie, it can define three things. The domain, which is facebook.com, then the path, which will be either just slash or some directory, and a time frame, how long this cookie should be valid. And the browser will store all this data. So whenever you send a request to Facebook, it will check whether it has a corresponding cookie or not, which fits all of these three. So it's still in the time frame. It's sent either to this path or any subdirectory, and it's sent to facebook.com. If the server specifically defines the domain, that means that the cookie will be valid for Facebook and all subdomains. So it will be also valid for whatever images.facebook.com. So it will be sent there automatically. If the browser doesn't specify the domain, then it will be only set for the domain which actually sent the cookie. So after you log in on a page, you will have a session cookie, which will be sent with each request, and that's how the server knows that it's you. Of course, the cookies are the core of user tracking and marketing, but that's absolutely another story. So let's see how all these things work with our application, the Voice of the Emperor. So open your Kali and open your Burp suite and make sure it's connected. You can either restart Kali, or you can make sure that there is no cookies there. So for that, come to Preferences and Privacy, and here you can see Recent History and choose Everything, and here also Everything. That will delete any cached data in your browser. Let's go back and then load the application. So the page has loaded. Let's go to Burp and see what happened here. So as you can see, the first request just received a redirect with slash at the end, and then it was this one. And then when you look at the request, there is no cookies in the request. But if you look at the response, then you see that there is the set cookie header with this cookie anchor CMS and then hopefully random value. And then here are the attributes I explained. This tells the browser when this cookie should expire and the allowed maximum age of the cookie. And here the path. So this means that this cookie is valid for all subpaths under the root of this domain. And if you check any subsequent requests, you will see that the cookie is sent in any further requests automatically. It's always there. We can also check our cookies in the browser. In the developer tools, Ctrl-Shift-C opens it, or you can come here and choose developer tools and toggle tools, or open the inspector. What we need is the storage. You might not have that open. Then you can come to the settings and here check the storage tools. So go to storage, and then here are the cookies, and under the cookies you see that for this domain there is one cookie called anchor CMS. Here is the path, this is the domain, here are the dates and the value, and then some other attributes which we'll talk about later. The cookie is anchor CMS, it's for this path, and the domain is just the IP address because it doesn't have a host name. And then here are the specified dates, and this is the cookie value. And this is a cookie flag. There are two important cookie flags. One is the HTTP only, which says that the cookie cannot be accessed by JavaScript. That's very important when you do a cross-site scripting, because that decides whether you can read the session cookie with a cross-site scripting attack. We will see that when we learn about cross-site scripting. And there is another flag which is not shown here. It's called the secure flag, that defines whether the cookie should be sent through unencrypted or only through encrypted channels. Basically, if the secure flag is true, then the cookie will be only sent if the web page is opened through the HTTPS connection and not just HTTP. A cookie can be either a session cookie, which will be lost when you close your browser, or it can be permanent, which will be written to disk when you close your browser and loaded again when you open the browser. Basically, that's how you can stay logged in Gmail or in Facebook, even though you restart your computer or close your browser, because it will be saved to a file and then read again when you open it. Many applications have a lot of cookies. Most of them are actually used for marketing or for tracking or similar. Let's just open another page. And if we open the developer tools here and go to storage, and you can see it has plenty of cookies. For us, the most important thing is to find out which cookie is the session token. I can tell you now, not the one which is called here session, because that only means that the cookie will be removed when you close the browser. To find out which one is the session token, you will get used to it. Sometimes it's obvious, because when it's a Tomcat, then it will be called probably JSessionID or something similar. So you will get used to it, how the frameworks usually call the session cookie. So when it's not obvious by just looking at it, then you have to test it. What you can do is, if you can log into the website, then you log in, and then you start to send the same request over and over again, and always delete one cookie. And at the point when you remove a cookie, after that you get an authorization error, then that was your session cookie. Because after removing that, the server will not know anymore who are you, so you're not authorized anymore. So let's recap this lecture quickly. We learned that the web application uses session objects to identify users in the stateless HTTP protocol. There is always some kind of session ID which is sent to the user and mostly stored as a cookie in the browser. The cookie is then automatically attached to each request sent to the issuing domain. So if you want a little exercise, you can go back to the Who is Your Daddy application, implement a session management for it in PHP. When you open the site, you get a session token, and when you submit a username, then that username will be stored in the session. And whenever you come back, then the site should check whether you already submitted a username or not. And if you have, then it fills out the name automatically without you submitting a name. It's a good exercise, but it will take some time. If you manage to do it, you can post it in the comments so that everybody else sees it. All right, thank you for watching. In the next sections, we are going to look at some attacks against the session management. So it will be pretty interesting. So see you there. Bye.
Join me, and I will complete your training.
Hello. So let's start discovering session-based attacks. The first one is called session fixation. For this to occur, the application needs some kind of login mechanism. Session fixation means that the attacker is somehow able to set the session cookie in the user's browser before the user logs into the application. When the user logs in and the application keeps the session ID which is provided by the user and uses that for the authenticated part of the application, then the attacker can use the session cookie which he knows in any other browser to connect to the application, and by that he can hijack the user's session. Let's look at this in a little bit more details. So we have the browser and we have web application. Let's see how it works in a secure application. You open the browser, you receive a session cookie, let's say AAA, but you're not yet logged in. So you go to log in, and then you receive a new cookie from the application. The first one, the AAA, will be invalidated, and you get another one, let's say B. And every time when you send a new request with B, then the web application will know that you're accessing your logged in session. The difference between the cookie AAA and the cookie BBBB is really important, because this cookie has basically no value, because it's not to an authorized session. So if somebody steals this cookie, they can only access those pages which can anybody do from the internet. However, this cookie here, that has a lot of value, because if somebody can steal this cookie and connect to the application, then he will hijack your session. So it's very important that this cookie is protected. So this is how a secure application works. Now let's see our Voice of the Emperor application, how that works. So have Burp open and Firefox, and let's go to the Voice of the Emperor.
Lord Vader, the fleet has moved out to flight speed and we're preparing to...
You have failed me for the last time, Admiral.
Yeah, it's intercepting. And we go to the admin page, because here's the login. You can already check our cookies here. We have this cookie here, whatever. Let's log in and see what happens. So it's admin and long live the Emperor login. Let's see in Burp what happened. Go to proxy history. And this is where the login was loaded. You can see we have this session cookie. And then here is with the post request, here is when we actually use our username and credentials. You can see them here. And after that, we don't receive a new cookie. So as I said, in case of a secure application, we should receive a new cookie because we are accessing an authorized session. And as you can see later on, the same cookie is used as before. So this is not yet the session fixation, but this is already a vulnerability what you can report to your customer. Because the problem is that even if the user doesn't log in, if the attacker is able to steal this cookie, and at some point when the user logs in, the attacker will be able to use the cookie to hijack his session. But let's see whether this website is vulnerable to session fixation. The difference between this problem and session fixation is that here we are using a token or an ID which was generated by the server. The question is whether the server accepts any ID, so whether it's possible for the attacker to set this ID himself. So we are going to first test that in the repeater. So I will just take the request where we log in and send it to repeater. So go to repeater, and we are first just send it as it is. And you will see this happens when you successfully log in. You get a 302 redirect to the admin panel page. We can also test what happens when your login is unsuccessful. You get again a redirect, but to the admin login page. But what we really want to find out, what happens if we don't use this token, but we use something else, what, for instance, just a few A's. This is obviously a token which was not generated by the web server, so let's see how the web server reacts. As you can see, you got the redirect, and it redirects to the admin panel. That means that the login was successful, even though you actually used super simple token, and you also doesn't get any others. Let's try that in a browser as well. For that, first delete the cookies from the browser. Clear your recent history, clear now. And I go to the proxy, go to options, because what we want to do, we want to change the cookie when the server sends it to the browser. But for that, we need to intercept the responses as well. So go to intercept server responses, check that you want to intercept them, and check also that intercept when the request was intercepted. In this way, we will see both the request and the response. Now go to the Intercept tab, turn it on, and then reload the page. Or actually, let's start with the login. So in Burp, this is the request without any cookie. Let's forward. And then this is the response. And here you can see that the server sets this anchor CMS cookie. Now we want to change that to, let's say, another one, BBBB. So a few Bs. And then forward. And then we can turn the intercept off and go back to the browser. We can check that the cookie is the BBBB. Here you can see it is. And let's log in. Admin, long live the emperor, and log in. We are logged in. First, let's check the cookie again. You could see that it's still BBBB, which is very good for us, attackers. Let's look at it in Burp as well. Here is our login. You see its cookie is BBBB, and in the response, there is no cookie change. And in the next page, in the request, it's still BBBB. So basically what we could do, we could force the browser and the application to use a cookie which we know as an attacker. You might ask how an attacker would exploit this problem. There are various ways to set a cookie, but the simplest one is physical access. So if there is any shared computer, like at work or in a library or wherever, if the attacker goes there and sets the cookie for you prior to login, then when you go there and log in, the cookie what the attacker set will be used, and immediately after you log in, the attacker will be able to hijack your session. That's the simplest, but there could be lots of various scenarios. So let's recap. What was session fixation? The problem is that when the attacker can set your cookie to a value he knows, and if at login the server doesn't change this value to another one, which is not known to the attacker, but it uses the value from the attacker, then this application is vulnerable to session fixation. Now let's talk a little bit about how to fix this problem. There are a few things which has to be correctly implemented to have a secure session management. The first one is long and truly random session values or session IDs. Like this one is not random at all. The second is that when you log in, the old token should be discarded and invalidated on the server side, and the new token should be generated for you for your authenticated session. And the third, that this should happen when you log out as well. So your authenticated session should be discarded, and then you should get a newly generated session token after logout. As an exercise, you could go to the source code of the Voice of the Emperor application and try to find out why it's vulnerable to session fixation. So this was our first vulnerability. I hope you liked it. There is more to come. So I will see you in the next lecture. Bye.
You are in command now, Admiral Piet.
Thank you, Lord Vader.
Hi. In this lecture, we are going to continue to assess the session management of the Voice of the Emperor. We have already established that the application is vulnerable to session fixation, so let's look at the logout right now. Generally, logout is as important as the login. Logout is implemented so that when you use a computer you don't trust, or you're afraid that your session has been compromised, then you can log out so that you can protect your own account. So if the logout doesn't really work, what happens is that you log out and then you think your account is safe, but hackers can still try to attack it. There are plenty of things which can go wrong with the logout. For instance, I mentioned earlier that it's a problem if you don't change the session token when you log out. So let's see how logout works in our target application. So make sure Burp is running and then load the website. And go to the admin page and let's log in. Long live the Emperor. And then we are at the admin page. You can browse a little bit and then click logout. So it seems like working. We click logout, we were redirected to main page, but let's see what really happened. Let's go to the bottom. So this is our last request before logout. You can see there is the session cookie. And then we go to logout, we send the session cookie, we look at the response. We see that the cookie is not changed, but it looks like we've been logged out. Let's go back to the browser and try to load the admin page again. And we immediately got back. So what happens is that the same cookie is used all along. This is generally a problem of this application, that it never changes the cookie, not even at logout. And what really happens is nothing. So you click the logout button, and apart from being redirected to the main page, the server does nothing. So it doesn't really invalidate the existing session. This is really problematic because you would think that you logged out, but your session is still active. So the next person who sits at the computer will actually have access to your account. Another version of this vulnerability is a bit more subtle. When the cookie is removed from the browser, so it gets emptied, but the session is not really destroyed on the server side. It's less bad as this one, because the attacker will not have access to the cookie in the browser after you logged out. However, if the attacker manages to steal your cookie from the browser during your session is active, or somehow your cookie gets stored somewhere and the attacker will access to that later on, that he will still be able to access your account, because your session will be active more or less indefinitely. So even if this is the case, then you should still report that to your customers. So this is one version of a weak logout implementation. Try to think about other versions and post it as a comment. And as an exercise, you can go to the Voice of the Emperor application and try to fix this. If you log into the target machine through SSH, then you will find the application under var www/html/ve. So go there and try to fix it. Otherwise, I will see you in the next lecture. Take care. Bye. Hi. In this lecture, we are going to talk about the same origin policy. This is a very important security feature of browsers. First, I will explain the problem, why we need the same origin policy, and then you will see how it fixes it. We've already talked about that running JavaScript code in browsers is a very powerful tool. So let's see another detail of that. The JavaScript code in browsers is also capable to send requests to other websites using the XML HTTP request object. It's always implemented a little bit different in every browser, and it's totally different in IE, but I was talking about browsers, so it doesn't matter. But let's look at how it really looks like. So you would do something like var xhr is a new XML HTTP request to create an object, and then you would say something like xhr dot open, and then the request verb, then where to send the request, and at the end you say whether it should be synchronous or asynchronous, and then you say xhr.send. So with that, we create maximal HTTP request object. We set it up to be a GET request to the etherlab.net, and then we send it. And if this code is executed in the browser, this will send GET request to the etherlab.net. Here, with XML HTTP request, you are pretty free to create whatever request you want. You can add new headers, you can add content, you can add whatever. So if this wouldn't be regulated in the browser, then the following attack scenario would be possible. So we have our browser here, and we have a website here. It's the attacker's website called boobs.com, set up to lure innocent young men to it. But to the contrary, what they expect, it will show only cute cat pictures. But that doesn't really matter, because the attacker's goal is that they just load the page. Because when the page is loaded, then it downloads JavaScript code, which starts sending requests to facebook.com. So when somebody loads boobs.com, it will reply with JavaScript, and then the JavaScript will start sending requests to facebook.com using the XML HTTP request and receiving the responses. Since the browser will attach the session cookie to every request which is sent to somewhere, if the cookie exists in a browser, then if the user is already logged in to facebook.com, which is pretty probable, then these requests will be valid for facebook.com because they will include the ID for facebook.com. As I said, this is a fictional attack scenario, but what do you think the problem is here? Pause and think about it a bit, and restart when you figure it out. Alright, the problem is essentially that JavaScript downloaded from boobs.com is allowed to talk with any other websites on the internet, and exploiting the fact that the browser will attach the cookies automatically. So the same origin policy was created to fight this problem. It says that JavaScript is only allowed to send requests to its own origin, in this case to boobs.com. The origin is defined by three things: the protocol, the domain, and the port number. So if we take http://boobs.com, and let's say it's on port 80 as our basic, then this is our protocol, this is the domain, and this is the port number. So when you try to send an XML HTTP request, it will be checked whether where you want to send it is the same as where the JavaScript came from. If any of these three is different, then the request will be blocked. So let's look at a few URLs. This is where we downloaded our JavaScript from. So sending requests to this URL will fail because the port is different. Sending requests to this URL will fail because the protocol is different, because it's HTTPS. And sending requests to this URL will fail because it's to facebook.com. However, sending requests to this URL will be successful because all these three elements, the protocol, the domain, and the port, is the same. It's just to another path. So that's all right. So this regulation in the browser is the same origin policy. Just to recap, it makes sure that JavaScript cannot simply talk to any other website. There's a new technology called cross-origin resource sharing, or CORS, we've changed the same origin policy and how it works a little bit. The course is out of scope of training, but on the long term, it makes sense to look at it and understand it. It could be a little bit complicated, so Google it, look it up. I also made some conference presentations about it. You can find one at this URL, and you can check out that one. I try to explain course pretty deeply there. The reason why we talked about this, because this is a pretty important security feature of browsers, and we need that to understand how JavaScript works and how attacks can be implemented. And we will use that in the future. Until then, see you next time. Bye. Hello. In this lecture, we are going to talk about the cross-site request forgery attack, or CSRF, or even cooler, CSRF. Now, this is a really interesting attack, which can be found in many web applications. The only disadvantage is that it requires some kind of social engineering to trick the user to open your website. So let's see how it works. The goal of the attack is to execute some kind of action in the application, like adding a new user, but to do all this without really having access to the application. The attack exploits the fact that the browser will automatically attach cookies to requests sent to the application. So let's say Facebook is vulnerable to cross-site request forgery. It's probably not, but let's say. And our goal is to post something on the target user's timeline. Since we don't have access to his password or his session cookie, we cannot really do this alone. But we know how a request to post an update looks like. So we could create a website which contains a form which results in the same request as an update request. Of course, when submitted. Although, as we discussed earlier, JavaScript is not allowed to send requests to any other domains, just to its origin, because of the same origin policy. Forms can still do that. So I can create a form on cutecats.com, which will send a request to facebook.com. We just need to trick the user to open our website. So let's see how it works. So the browser loads cutecats.com. It's downloaded in the browser. And it had a hidden form inside, which is now in the browser. When this website is loaded in the browser, this form is submitted automatically, and the form will send the request from this browser to facebook.com. Since there was already ID for Facebook in the browser, this will be automatically attached to the request. So basically Facebook will think that this request is really originated from the user of this browser. So whatever this request requested will happen. So I wanted to post an update. So basically this request will post a new update on facebook.com and then return whatever it has to return. So the point is that the browser contains everything which is needed to legitimately talk with facebook.com. We just have to trick the user to send the request there, and because of the automatically attached cookies, it will be valid for Facebook. Facebook has no idea this is a fake request, and it will do what the request wanted to do. So let's see all this in practice. So load the voice of the emperor through Burp. So our goal is going to be to use cross-site request forgery to create a new user in the application. That's a really well-known attack scenario because creating a new user is the best way to get access to an application without really having access before. So first we have to find out how a user is created, how a request to do that looks like. So go to users, and we are just going to create a new user called test. We have to make sure that it's active and it's admin and test. And the password is test because it has to be longer than 6 characters. And I come to the history, what I usually do is, it's a little trick, but I want to record something and I have already lots of requests here that I mark here with a color to see where was I standing before doing that specific action I want to record. And then I come back here and say create. And in this case, it's pretty simple. It's just 2 requests. And the second one is probably just loading the page again. So we are basically interested in this one. And yeah, you can see here that it's a post request. And here is every data what we just filled out. So this is the request what we want to reproduce with a form. You might say that it's easy because now we have access to the web page, so we can figure out how a user is created, but how an attacker would do that without really having access to the application. Now the thing is that in most of the cases you will be able to find some way to really test this. For instance, this is an open source web application, so even if you don't have access to the particular website, you can still download the framework and create a test environment where you can check that out. If it's not an open source but a commercial application, there might be an open source version of it, or in many cases there's an evaluation version, or you can actually request to evaluate from the company, and since they will think that you are a potential buyer, then they will provide a test version what you can then use to find out such things like how to create a user. Now the next step is to create a web page which will reproduce this form. So I will just go to the root folder of the web server for www.html, and here I create a file called csrf.html. And this is a simple HTML web page, so I will just keep it as simple as possible so that I don't have to write too much. HTML body, then here we create a form. The method is post, because that's what the original request uses. And the action, it is very important, the action should point to the URL where the target is and not where this HTML page is stored. It should point to the target. So you can come to our request here and say copy URL. And here paste. And that's it. Then now we have to create input fields. If you come here, we can count how many input fields there are. It's 1, 2, 3, 4, 5, 6, 7, 8. So we need 8 input fields. First I just create a template, and then I can copy paste that. So the type is hidden because we want these input fields to be hidden from the user so that he doesn't see this malicious form. And then they have some kind of name and value and close, and we need 8 of this. So it's 1, 2, 3, 4, 5, 6, 7, 8. Actually, we will need one more for the submit button. So 9 inputs, and then let's start with the first one. Token value, I will just copy paste it from here. Yes. Then real name, attacker. Of course, it's stupid to create a user called attacker if you're the attacker, but you know. bio test status. It's important that the status is active. Role, also important that it's an administrator. The name, username is attacker. Password found 1111. Email a@evil.com. And as I said, the last one is the submit button. Alright, with that our form is finished. So we close it and close the body and close the HTML. So this is our malicious website. Let's test that it works. So what we hope for is that we can trick the user to go and load our website. Of course, then it's not running a local host, and it's not called csrf.html, but cutecats.com. But the point is that he loads our website. Again, I come back to Burp and close this request. And I mark again where we were standing. And go. Now the page is loaded. Now this is where the social engineering comes in. We have to trick our user to click on this button. He clicks, something happens, and as you can see in the list you already see the attacker user. This is what we created, and if we come back you see that here our website was loaded. There's the content, and here's the request which was sent by our website. And as you can see, although we didn't have access to the Anchor CMS token, which is the session token, it was automatically attached to the request when it was sent from the user's browser. As I said, we still have to trick the user to actually submit our form by, defacing it to a download button or something like that, but that's not necessary, because we can also submit it automatically. So we can do it here, something like onload is document dot get element by ID. So find our form. For that we have to give a name, an ID to the form. So I will call it CSRF form. So we are searching for CSRF form. Here, the onload, we are actually executing JavaScript. So this is a JavaScript command, which searches in the document, which is this web page, for an element called CSRF form. And when it finds it, it's gonna submit it. And I will just change the username to evil attacker so that we actually see that this attack was successful. You also need to delete the name parameter from the submit button because that's going to confuse our JavaScript. It's also not necessary to be there. So I will save it. And let's go to the browser. Open again the localhost csrf.html. Let's go to Burp Suite and mark again where we were standing. And go. And as you can see, quickly the CSRF HTML came up, but then immediately after that we were redirected. And here you can see there is a new user, the evil attacker. And you could see in Burp, the page was downloaded, the JavaScript, the form was loaded, then the JavaScript was executed to submit the form. So a post request was sent to the website, which then redirected us to the user's page. So that's why the user's page was loaded immediately. So now you could see that it's possible to automate the attack. What the attacker still needs to do is to trick the user to actually visit his website, or what he can do is to embed his code in a vulnerable website somehow, which is visited frequently by the target user. And then when the target user loads that website, then the attack is executed. One important point is that the attacker has to be logged in the target website when he loads the malicious website, because that's how the cookie will attach to the malicious request. So that's very important. But you know, it would work against sites like Facebook or similar where we actually logged in all the time. Even if you don't have a tab open, the credentials are still stored in the browsers, so the attack would work. Now if we go back to our request, let's open this one. As you could see, our request is not exactly the same as the one we have seen. It's only because it's a multi-part request, but for this website it doesn't matter. It's pretty flexible from this point of view. If it would matter, then you would have to work a little bit more to create a similar request, but in our case, luckily that's not necessary. Now you could see that there was a parameter called token, which we just copied in our request. Now I can tell you right now that this parameter is actually a cross-site request forgery protection token. This site is supposed to be protected against cross-site request forgery. The protection against cross-site request forgery is to embed hidden random data in each form every time when it's reloaded. So this random data should be regenerated when it's loaded, so that every form has a unique identifier so that the web server can see when this form was already submitted or not. So if, for instance, we use a token which was already used, then the server can check in the session data and see that this token is not valid anymore, and then just reject the request. So when the server receives a request from the client, then it has to check that this token exists, it's still valid, it has never been used before, and it was issued for the user who are actually submitting it. If any of this is not correct, then the request should be rejected. In our case, what happens is that this protection is not really working, so it's just broken. I've seen that in real life scenarios that there was a protection implemented, but just it didn't work. What I want to say is that even if you see that the application has a protection, it still makes sense to test it whether it works or not. And even if you see that some forms are protected, there might be some other forms which are not. So it makes sense to always look for new potential attacks. So don't give up at the first sign of a protection. And if you remember, this is the protection what we turned off in the Downtown Dispatch application what we wrote in Django. CSRF can be also used to deliver other attacks, so basically to combine it with other attacks. Sometimes there's a cross-site scripting in the admin page, but the attacker wouldn't have access to the admin page, obviously, so he cannot just put the cross-site scripting there. But he can use the cross-site request forgery to trick a user to actually deliver the cross-site scripting attack to the website. So it's a really practical attack to combine with other attacks. I hope you understand cross-site request forgery now a little bit. I recommend now to experiment a bit. A really good exercise is to go back to the town dispatch, turn the protection back on, and try to change the application in a way that the cross-site request forgery protection actually works. You have to Google for it a little bit how that works in Django, but it shouldn't be a really difficult challenge. If you have any questions, start a discussion or a comment, and otherwise I will see you in the next lecture. Bye. Hi, in this lecture we are going to talk about how developers can create a secure session management. Most of the techniques I mentioned earlier. However, it makes sense to go through them once more. So first, you need to start by creating a secure session token. Secure token. So how to do that? The key aspect of secure session token is that it cannot be guessed or brute forced. So to do that, the token has to be long enough and really truly random. So it has to be random and long. And as random, it can be a UUID. So any other way than generating a truly random number or using a UUID is wrong. People tried with various ways like incremental numbers or base 64 encoded username and login time or something like that, or even hashed username and login time together. But in all of these cases, this can be only secure as long as the attacker figures out how the data was generated. When the attacker figures out how the session IDs are created, he can create whatever session ID he wants, and by that hijack anybody's session. So the key is randomness. You also have to protect the session ID because if it gets stolen, then the attacker can hijack the user session. So the third point is token protection. To do that, there are a few things you can do. First of all, never transfer the token in the URL. Never in URL. Because URLs are not considered confidential. So it's not guaranteed that any other software on the way to the server is going to handle your URL confidential. It's going to be logged in your browser, it's going to be logged on the web server, it's going to be logged on firewalls, it's going to be logged on load balancers, whatever. So just never send the token in the URL. You can also apply various cookie flags to protect the session ID if it's in the cookie. So cookie flags, such as the HTTP only, which tells the browser that this cookie is not supposed to be accessed by JavaScript. It's only supposed to be accessed by the browser to attach it to a request. And the other is the secure flag, which tells the browser that these cookies only supposed to send if the connection is encrypted. So basically, if it's sent through HTTPS. So the second point is making sure that the session handling is secure. So secure session handling. This means basically two things. Make sure that the session token is always regenerated when you log in and when you log out. So new token at login, logout. And the other is make sure that the old session ID and the old session is destroyed when the user logs in and logs out. In both cases, that's very important. Old session is destroyed. Also make sure that the session is destroyed both on the client side and on the server side. The third point is to implement a reasonable session timeout. 3 timeout. This basically means that the user will be automatically logged out if he's idle for some time. Of course, the length of the timeout really depends on the application. There are applications where what you don't use all the time, you just log in, you do one thing, and then you leave it there. In these cases, the timeout can be short. If there are applications where the user works for a long time, then you might think about lengthening the timeout. If for some reason you cannot allow the user to be kicked in because that's not your business goal, like Facebook, then you have to make sure that the session token is regenerated time to time and replaced in the browser as well. By that, making sure that if it gets stolen, it cannot be used for a long time. If the developers follow your suggestions, then it's not impossible to make a secure session handling. And with that, we are concluded our section on session management and attacks against the session. So stop a little bit, think about what we learned, go through all the things again, just to make sure that you are understanding everything. And when you're finished, then I will see you in the next section. Bye. Hello there. In this section, we are going to talk about attacks against the authentication. So basically, attacks against login. Apart from protecting your session ID, another important thing is protecting the user's credentials, such as the username and password. The best way to do that is encrypting the communication between the client and the server. This can be done by the Secure Socket Layer, or SSL, or its successor, the Transport Layer Security, or TLS. When I say SSL, I usually mean both. This is a really interesting technology. What happens is that SSL is not really a separate communications protocol. It's rather a layer what you can use on various communications protocol to provide encryption and decryption to these protocols. So, for instance, when we say HTTPS, it means that the communication is still done with the HTTP protocol, but there is a SSL layer on the top which makes sure that all the communication is encrypted and decrypted. You can imagine this as a tunnel. When you connect to an HTTPS website, first you're going to build an SSL tunnel and then send all the HTTP communications through this tunnel. To establish this tunnel, first a so-called SSL handshake has to be done. So let's see how that looks like. So we have here our client. In our case, that's the browser. And we have here the server, SSL server, which is the web server. When you open the website and it's on HTTPS, then first the browser will send a client hello request, which contains all cryptographic informations, such as which cipher suits the client supports, and also cryptographic data, which will be used later in the key exchange. Then the second step is that the server sends a server hello request, which contains the cipher suit which was chosen by the server, and the server certificate, so that the browser can check whether this certificate is valid or not. And if the server wants to validate the client, then he can also ask for a certificate with a client certificate request. After that, the browser will check the server certificate and the cryptographic parameters and start with the next request, the client key exchange. The goal is to create a secure key which they can use later on to encrypt the traffic. What happens is that the handshake is done using asymmetric encryptions like RSA, but during the communication, symmetric encryption will be used. The reason is that asymmetric encryption is really slow compared to symmetric, so it will affect the performance of the website if asymmetric would be used all the time. So they only use asymmetric to securely do a key exchange, and then they use this key later on in the symmetric encryption. They both calculate the key based on the exchanged cryptographic material, and then the client sends a client finished request, and the server replies with a server finished. These requests are already encrypted with the established secret key, with that indicating that both of them know the secret key. And when the server sends the finished request, basically with that, the handshake is over and they can start communicating through the SSL tunnel. So basically from here on, the HTTP communication can be started. All right, so let's see this in practice. Let's go to your Kali. What you want to do, we're going to open Firefox. The Voice of the Emperor application supports HTTPS. So we will work with that. We're not going to use Burp at this time because Burp only intercepts the HTTP communication and we want to see the whole network stack. To do that, we are going to use Wireshark. You can find Wireshark at the sniffing and spoofing, and here Wireshark. So Wireshark is a well-known network monitoring tool, and what it does, it can listen on any interfaces and record the network packets sent through that interface. So first we need to set it up. We're going to use the ETH0 interface because that's where the communication goes to the web server. But we don't want to intercept all the traffic which is going through because there could be too much noise. So we will say that we only want to intercept traffic going to the web server's IP address. So basically to this host. And then let's say start. Your virtualizing software might ask for permission. I will give permission. And so Wireshark is listening. You could see here on ETH0 and with this filter. So now we have to load our website. So let's go to the Voice of the Emperor. I will just load the web root, but I will also make sure that it uses HTTPS. So let's open the page while Wireshark is listening. So first of all, you might get this warning message, which tells you that there is some problem with the certificate. So if you click on Advanced, that will tell you that the issuer is unknown. Now it's because I am the issuer, so I generated the certificate authority for this certificate as well, which is unknown for the browser. So you can just say add exception and then confirm security exception. But basically, whenever you get this warning message for legitimate applications, so for instance, if you're browsing Gmail and from one day to another, you will get this warning message, that means that somebody is messing with the Gmail certificate. So it's probably a fake service or a fake certificate, or there is something fishy going on. Basically, if you go to Preferences and then Advanced and Certificates and View Certificates, then you see here all these trusted certificate authorities which the browser works with. So if you want to run your own website, then you better get your certificate signed by any of these certificate authorities so that people don't get the warning message we just got. When we loaded this website, it was recorded by Wireshark, so let's check it out. So here we can already see some interesting things. For instance, it says that it's a TLS 1.2 and this is the client hello message. There's the server hello. We can try to say follow TCP stream. It doesn't bring us anything useful. You can see here some data from the certificate, but otherwise nothing interesting. But if you keep looking here, you can open because it's a TLS packet and Wireshark recognizes it, there's a secure sockets layer part here. And there is all the information you should have in a client hello message. All the mathematical attributes which is needed to build up the SSL channel, etc. You can also check out the server hello message. Here's, for instance, the cipher suit, which is chosen by the application. And there is key exchange. So I recommend you to check out all these packets and see how all the necessary parts of the SSL handshake are transferred in these packets. And of course, if you scroll down, there is lots of data here. Send. It's basically all the data which is transferred for the website, but if you check it, it already says that it's encrypted, because that was the whole reason to do the SSL handshake, so that we have an encrypted channel where we can transfer data. So in Wireshark, you cannot see that, because Wireshark only sees the packets and the data in the packets are already encrypted. But Wireshark is a good tool to understand how the SSL handshake is built. You can also see that the SSL handshake is repeated at some point. It's probably because there is a different TCP channel open for some different data which the website loads. Then, of course, you have to make another SSL handshake. Now, if you go back to the browser, then you probably already know that if you click here, then it will tell you that it's a secure connection, but only because we accepted the certificate of the server. And then you can get some information about the certificate which was provided. But now, to get a better look at the certificates, I will show you that on the server. So we are going to log on to the target machine. Yes. So let's go to etc Apache and SSL. So this is where the Apache web server stores the keys for the server, or the certificate and the private key. So let's look into them. So if we just print out the Apache CRT, it's called CRT, but it's actually just a text file, and it contains a base64 encoded data, because it uses the X509 format. It's a well-known certificate format, and we can make it readable with OpenSSL. So we can say OpenSSL X509 -in, and then the certificate file name, and -no out -text. So this prints the contents of the certificate file. So this is the certificate of the public certificate of the web server. You can see all important data. Here is the issuer, what we have already seen. And basically you can see here that it's a self-signed certificate. So it was signed by the same certificate. That's the easiest way to create a certificate, but of course that it's not really secure. And at the end, there is the public part of the RSA key. So here we can see this uses the RSA encryption, and this is the public part. So these are the mathematical attributes which are needed for RSA, the modulus and the exponent. And then here is the signature. As I said, it's a self-signed certificate. So, but this is the signature which is used to validate the authenticity of a certificate. And then there was another file, which was the Apache key. That's also a text file, and it's a private key file. We already found out that it's RSA, so we can just say RSA, and then instead of CRT we just say key, and then it's going to print the contents of this key file. So this is the private key. It contains only the mathematical components which are needed for the RSA. So this is pure mathematics. If you're interested in that, I really recommend you to Google it up, check it out, how RSA works, how this private public key works. Actually, you can really calculate on paper all how the encryption should work. So it's an interesting challenge. I did it once at the university. It was enough for me once in a lifetime. And the private key is called private key because this is really the file which you have to keep safe. But when I say safe, it means that certificate authorities who are signing all these other certificates, they kind of keep their private keys like 15 stories underground in their super secure safe. So it really has to be kept secure. If you're making yourself a serious certificate, what you're really using for confidential data, then the private key is what you will want to keep somewhere safe, stored in a secure location. So far we've seen how the SSL handshake works and how the certificates and the keys look like. There's one more thing I wanted to show you, and that's an application called SSL scan. So that's what we are doing most of the time, is that there are quite a few well-known vulnerabilities in various versions of SSL and TLS. So it's always worth to check whether the target server runs a secure configuration of these protocols or not. As I said, there are various vulnerabilities, so it will be pretty time consuming to check by hand whether the configuration is secure or not. So that's why I use the application called SSL scan. It gives you quite a bunch of configuration possibilities, but what we really want is basically the IP address. And then start. So let's scroll back at the beginning to see what were the results. So it tests against some well-known vulnerabilities like the renegotiation and the Heartbleed. They are pretty famous, so I don't really want to talk about it. And then here it lists all the supported ciphers, which is offered by the server. And basically it colors you those which have something problematic in it. So these are probably because RC4 is a not too good stream cipher. It's not necessarily bad in SSL, but my opinion is that we shouldn't encourage customers to use bad encryption algorithms, even if in that specific case it's not necessarily insecure. So I usually tell the customers not to use RC4. Then as we scroll down, then we get to the place where the version is already not so secure. So for instance, you can see here that SSL version 3 is already marked as red because that's an insecure version of SSL. So there is a vulnerability in it, and that's why it shouldn't be used. And there at the end, there is a few information about the certificate of the server. That's what we've just seen. So you could see here who is the server and who was the issuer, and then the validity of the certificate. So SSL scan is a really good tool to get a quick impression about the used cipher suits and generally the SSL configuration of the server. And you can put this in a finding if you find something problematic, like the versions or some famous vulnerability or something like that, then create a finding about it. So it's not easy to configure a secure SSL server. So your customers are definitely going to need your help. As a homework, you can check out this SSL cheat sheet from OWASP. It's pretty good. So look it through and then you will get a general understanding about what's good and what's bad in SSL. So I know that SSL is a huge topic. I could basically make a whole course only about SSL because it contains all the cryptography part, and then there is a whole infrastructure for it, the PKI, etc. But I think we talked through the essentials, what you would need when you're actually doing an assessment. But if you have questions, then don't afraid to Google or to comment to this lecture or send me some kind of email or something. Otherwise, I will see you in the next lecture. Take care. Hi, in this lecture, we are going to try an authentication bypass attack. Basically, if you can log in without using the password, that's awesome. That's going to be immediately a critical finding in your report. But with that said, this is not some kind of boilerplate attack. You cannot just find it everywhere or search for it. What you need to do is closely analyze how the login works and then try to find problems in the login process. So that's what we are going to do. So let's go to the Voice of the Emperor. So make sure that Burp is running and make sure that you are using Burp in your browser, and then load the admin page. Accept the certificate. And then first I go back to Burp. We did this earlier, that I mark the place, the current state, so that we'll see which requests are really related to the login. So let's log in, admin, long live the emperor.
General, prepare your troops for a surface attack.
Yes, my lord.
Yeah, so we logged in. Let's go back to Burp. You could see that there are two requests related to the login. Basically, the first one is when you send the credentials, you get a redirect to the panel page, and the second one is just loading that page. So mostly the first one is interesting for us. So let's really look at what happens here. So we know there is the Anchor CMS cookie, there is the CSRF token, which doesn't work. Then here's the username, and here's the password. And there is something which was not on the login side. So there was no input field for it, but there is still another parameter called isScriptAdmin. So that really reminds me to old well-known vulnerability, which you could still see in some web applications. That's the admin equals 1. Basically what happened is that people, to use admin rights, people just put in the URL this parameter admin, and if it equal to 1, then the user got admin rights. So this is similar. There is some kind of parameter here talking about an admin. So we need to check somehow whether we can do anything with it. So let's send this to the repeater and go there. First, we can just send it again to see that this is a successful login because it's redirects to the panel. Now this cookie is already logged in. So we need another cookie, but we know that the application is vulnerable to session fixation. So we can use any other value as a cookie. The token now doesn't matter because it doesn't work. So first, this cookie is already logged in. So we need to use another cookie. But since we know that the application is vulnerable to session fixation, we can just use any other value. The token is also fine because the CSRF protection doesn't work. There's the username and there's the password. We need to change the password now because we want to figure out how to log in without password. So I will just change it to AAA. And then let's try a few things with this parameter. So is script admin? Yes. Let's see what happens. nothing. As you could see, it redirects us to the login page. That means that the login was not successful. Then let's try true. It still didn't work. Let's try 1. Also didn't work. Let's try 0. Still not. Okay, so we don't have too much luck, but let's stop a little bit and think. What does this parameter really says? It's a question, and it says is script admin. So maybe the user has to be script admin. So let's try with that. Script admin. Is script admin 0? No. Then yes. Still not working. 1. Oh, now it worked. So it seems that if we use the username scriptadmin and is scriptadmin is 1, then we get a login. That looks really good. We just need to test it in the browser. So I will go back to the proxy and let's clear our session here. Privacy, clear recent history, clear. All right, and yes, now we want to turn on intercept, and we say script admin and some random password login. It gets intercepted in Burp. Yes, and now we have to say here 1. And we are in. That's awesome. That means that with the user script admin, you can log in without actually having credentials. You just have to set this script admin variable to 1. But why is that? Let's go to the users. You can see there is actually really a script admin user. And if you open it, it says, this is a technical user to allow scripts to interact with the page. That actually not an entirely crazy scenario. So people really do this, that if they want scripts to use the application, they create some default accounts or anything. So to make it easy that scripts can always talk with the application. In our case, this basically gives us full administrator access to the application. That's really good. And this is just an example of an authentication bypass. Although it might look simple, but you could really see similar things in practice, sometimes in a more complicated environment, but the whole idea of it is similar. And yes, you will have to try a lot and you will fail most of the time. But when you find a problem, then you actually found a really critical problem. And that's going to be awesome. As an exercise, you could look at the code of the Voice of the Emperor and try to find in the code where is this script admin users implemented and why it lets users in without actually checking the password. You can also fix it if you like. Also, try to make up new other scenarios when such a problem could emerge, why people would implement such things. And you could post a comment or start the discussions or something like that. Otherwise, see you in the next lecture. Bye. Hello there. In this lecture, we're going to talk about unauthorized access. In many times, you actually don't really have to hack anything. You just have to ask for things and magically you will get it. You know the joke about the bunny when he goes to the bear and says, "Hey bear, I heard you have a death list. Is that true?" It's like, "Yes, bunny, of course. I do have a death list." What's going to happen with the people on the death list? Well, of course, I'm going to hunt them down and kill them with my bare hands. You understand? My bare hands. Anyways. And may I ask whether I'm on the list or not? Well, let me check. Oh, yeah. Actually, you're in the top 10. Oh, okay. And Is it possible that you take me off the list? Well, sure, why not? That's it, fine. So, of course, it's not a really good joke, but it's really on point. Sometimes this is exactly what happens with application. You just have to ask for things and you get them, because people forget to do the authorization and the authentication correctly. This you can try to download documents or access features, do changes in the application, or download source code. Whatever, it makes sense to try anything because it might work. With that said, let's check the Voice of the Emperor application for similar vulnerabilities. So make sure that you're not logged in, and we're gonna try to load the various admin pages because only the admin pages are not accessible for anybody. So I will first try with panel. Nothing happened. Then let's try with users. Again, nothing happened. Now let's try, posts. Oh, well, this looks interesting. So you could see that the page is not functioning properly, but you kind of still see things. So these are supposed to be the two posts which are available on the website. Now let's click on this one, and you get the post and all the metadata, and you might even be able to save it. Let's do a change and save it. Go rebels. I will just load it. Awesome. This means that without authentication, so without logging in, we are able to read and change posts. That's by itself really awesome, because that would mean, in the case of this application, that we can manipulate the propaganda of the empire. That's just really good. But there might be something else. So if you scroll down, for instance, there is this custom JS field. If this means that the application allow you to add JavaScript to the page, that's just the best thing what can happen with you as an attacker, and the worst thing what can happen with the empire. Let's test whether this works. So I will just add alert document dot cookie. Yes, and let's save it and go back and refresh this page. And we immediately got a pop-up window. The JavaScript what we added here, alert, is a JavaScript function which gives this pop-up window. It gives an alert window, and we said that we want to see the cookie for this document in that. So you could see we get the Encore CMS cookie here. This is just a proof of concept, but it basically says that we can do anything with JavaScript. We could create an XML HTTP request and send this cookie to our own site, and just wait as long as an admin comes down and we get his cookie, and with that we can essentially hijack the admin session. So basically we can get full control with this vulnerability in the application. So it's always worth to test whether any resources like pages or features or downloadables can be accessed without authentication or even with less privileges. Because sometimes you have a read-only user, but you can still write things, although you're not supposed to. So you need to test all these things, and sometimes you get lucky. As an exercise, you could log into the target machine and try to find in the source code of the Voice of the Emperor why this page is accessible without authentication, and you can even try to fix it. Otherwise, I will see you in the next lecture. Bye. Hi. In this lecture, we are going to talk about password quality. I know it's a pretty boring topic, but we need to talk about it because you can develop the most sophisticated technology to secure your application. If your user uses the password Skywalker123, then you're done. Even today, weak passwords are a serious problem. Any application which has something to protect has to make sure that their users are using strong passwords. Probably you already know how to do that, basically rejecting every password until they give a strong one. But what is really a strong password? I consider the following as strong password. It's at least 8 characters long, but hopefully more. It uses letters, it uses capital letters, it uses digits or numbers, and some kind of special characters. If the application handles strictly confidential data, then you can go further and, for instance, enforce password change in every 90 days and make sure that they are not reusing the same passwords. When you're doing an application assessment, you have to make sure that the application enforces strong passwords. For instance, at my work, there is even a company policy that every application used by a company has to enforce some strong passwords. But let's see how the voice of the emperor does that. Let's go to the user, try to change somebody's password. For instance, I will try to change it to AAA. The password must be at least 6 characters. But I will try to do AAAAAA. So 6 A's. Update. But the password was changed. That's pretty bad. This means that although there is a function which checks the password, but it doesn't really enforce strong password because 6 A's is not strong at all. Also, I have to mention it here that the way how password change is implemented here is also insecure because when you allow password change for the user, you always have to ask for the current password so that they give in the current password and the new password. The reason for that is that if somebody is able to hijack the account, somehow log in like with the session fixation or something similar, then if the old password is not required, then the attacker can simply log out the user. So the user won't be able to log in again. If you require the old password, then whoever hijacked the account will at least not be able to change the password. So in this case, you would write 2 findings in your report. 1, that weak passwords are allowed, and 2, that the password change is insecure. So that's all about password quality. I hope I didn't bore you to death, but it's still an important topic. But there are more exciting lectures to come, so I will see you in the next one. Bye. Hello again. In this lecture, we are gonna talk about password brute forcing. In a normal paid assessment, we usually don't really do brute forcing, but we want to find out whether it's a feasible attack or not. The reason is that in an assessment project, you usually have limited time, so it doesn't make sense to waste your time with stuff which doesn't really benefit you. For instance, you already have the credentials for the applications, then you don't really need to crack the login to get access to the applications. So you don't really have to do the whole brute forcing. However, you have to figure out whether it's possible or not. Because if it's technologically possible, then the attacker can spend 2 days or even 2 months brute forcing the application. So in this lecture, we want to find out whether such an attack would work against the voice of the emperor. So let's go to the application. Let's record a login request. The password doesn't have to be correct. And then go to Burp. Go to the proxy history, and here is the login. and send this login request to the intruder. With the intruder, we can test various positions in the request. Now we want to test the password, and we can specify a payload. So if it's a pro version, then you have built-in lists, but we're using the free, so we have to use another word list. But luckily, Kali has a bunch of word lists available under user share word list. This raw queue is actually dumped from a real hack, and it contains millions of passwords. That's why it's also compressed, because it's a pretty huge database. We are just going to use the default from Nmap, and I will also only use the first couple. So I will just take some. I will tell you in shortly why that is. So copy, and then come to Burp, and here say paste. So we choose one position to test with 76 elements, and I will just add the real password at the end. Long leave the emperor. Because what we want to figure out is that if you're brute forcing the password, when the real password comes just after 70 something tries, whether it would be still successful or not. So before we start the scan, we have to somehow make sure that we will actually see which one was the real password. So for that, go to options, and we are going to set a grep match rule. That's basically, we can automatically search in the responses and mark requests which have a specific thing in the response. The only thing what we know is that if the login is successful, so the password was the real one, then the redirect will go to admin/panel. So basically, if the response has panel in it, then that's the real password. Make sure that you uncheck this exclude HTTP headers, because this is going to be in the headers. Now, let's start the attack. You get this warning because the free burp doesn't support full speed for the intruder. That's why I only choose 70 something passwords to test. In the full version burp, the intruder is much more faster, but don't forget that this is not a fuzzing tool. We are only making a proof of concept to show that such an attack works. All right, let's start. Now you can see here, as each password in the password list is tested, the status code, length, and here will be marked if we find the real password. All right, it's finished finally. So we have all the 77 requests here in the results. So what we are interested in, where this grep and match requirement will match, because that's going to be the real password. So let's scroll down and see whether any of them was successful. And of course, as expected, the last one, which is the known password, was matched to the panel because it has in the response panel, and that's how we figured out this is the real password. Of course, as I said, this is only a proof of concept, but basically this means that we can send 70 requests to the server, and if we send the real password, then it will be still successful. There's no brute force protection implemented in the application, and basically if we can send 70 requests, then we can also send 7,000 or 70,000. It doesn't really matter from this point of view. So you can put this in your report that it is possible to fuzz the password. So let's quickly talk about mitigations. The application should enforce strong password. That's very important. The application could log down for some time after a few login attempts. Like after 5 login attempts, it doesn't allow that user to try to log in for 10 minutes or something. Or after a few failed logins, the application could include a CAPTCHA in the login form to make sure that it's a real human and not a script fuzzing the application. Also, the application could always increase the response delay after each unsuccessful login. And by that, after like 20 or 50 requests, the delay could be so big that it will be unfeasible to really do brute forcing. As I said, Burp Suite is not a brute forcing tool because it doesn't do manipulation and permutations on the given word list. But there are other tools you can try. For instance, on Burp, there is the wfuzz, which is a web brute forcer. So as an exercise, you could try to use wfuzz to fuzz the Voice of the Emperor application. So good luck with that, and I will see you in the next lecture. Bye. Hello and welcome back. In this lecture, we are going to talk about default accounts. This is not a technically super interesting topic, but this is something which you always have to check, and sometimes it can get you into the application. So it could be useful. So the thing is that many applications come with a built-in account, like an admin to configure the application or an installation user or something like that. For that, usually there are some simple user password combinations like admin or admin change me or root tor or similar like that. They are also usually documented in the installation guide or in the documentation in the application. So it always makes sense to check it there, especially if it's some kind of off-the-shelf application or it's it's an IoT device or something like that. Otherwise, as always, Google is your friend. So if you just search for something like default password list, you will get quite a few hits. You see there are a bunch of passwords. There are quite a few other websites. Some of them looks pretty dodgy. But the point is that if it's not in the documentation, then you will still have quite a chance to find it on the internet. These attacks are working very well against IoT stuff, so devices, because then the vendors want to make an easy way for the users to set it up, so there's always some kind of default account. Also, if you happen to find an undocumented default account, that's awesome. That's probably not even for the users, it's probably a backdoor for the company. That happens as well. So that was a pretty quick and painless lecture. The only important thing that you shouldn't forget is whatever it happened, check for default accounts. It might help you and get you into the application. So that's all, and see you in the next lecture. Bye. Hi. In this lecture, we are going to talk about password recovery. So most of the web applications have some kind of feature to recover lost or forgotten passwords. Since it affects the login credentials, it's pretty critical that these features work properly. Such a feature can contain various vulnerabilities, from injection problems to logical flows. So the spectrum is pretty wide, although usually the feature itself is pretty simple. So let's have a look at the Voice of the Emperor, and then we will see how it works there.
Rise, my friend.
Alright, so go to the login page. And then you will see that here there is a link what to do if you have forgotten your password. So let's open, and it says that it wants your username. So let's check first with a non-existing username to see what happens in that case. Say reset, profile not found. And let's check with the admin. Reset. We have sent you an email to confirm your password change. That's wonderful. So you can see in case the profile exists, then an email is going to be sent. Of course, this application cannot send emails because it's a closed system, but it's supposed to send an email. If the profile doesn't exist, then it just gives back the error message. So now you can pause a little bit and think about what's the problem here. How could an attacker exploit this feature? All right, you might have figured out, but of course I will tell you anyways. The point is that the two responses are different because it allows an attacker to brute force username. Basically, he can check all possible usernames and he will know which one has a profile in the system and which doesn't. Now you might ask again, why does it problem if somebody finds out your username? The username is usually not a confidential data. Yes, but this is the first step to brute forcing the password. Because if you start brute forcing the whole login without knowing the username or the password, then if an attempt fails, then you will never know whether the username was wrong or the password. So the problem is that if you don't know any of them, then you have to test the whole Descartes multiplication of the username and password set, which means that your test set is going to explode and you're going to be brute forcing forever. Now we don't want that. So a much better way to do it is to find a way to first brute force the username, to figure out at least one existing username, and then start to brute force the password for that user. In this way, you can make sure that your test set is not going to be too big. Although this is not a high-risk vulnerability, but it shows how low-risk problems can be combined to achieve a critical result. So when you are testing, always think about how you could combine various vulnerabilities to achieve something with a bigger impact. Now, the best way to implement a password reset would be to ask only for the email address of the user and always tell the user that email is sent. This should be the response even if the profile doesn't exist. You can tell in the response that you sent an email. If it doesn't arrive in 1 day, then they should repeat the password reset request because maybe they made a typo in the email address. So it's possible, but the goal is to not disclose to the user whether there is really an account with this email address in the system. In this way, for people who actually know the email address, it's possible to reset the password. For people who are just trying to brute force it, they will never figure out when it was an existing email address and when it wasn't. As an exercise, you could try to implement a brute force attack against the username using this password recovery feature. You can do that in the same way as we did the password brute force, just you will use now this other form in the Burp intruder. So try with that, and when you're ready, then I will see you in the next lecture. Bye. Hi. With this lecture, we are essentially finished with the section about authentication attacks. That's awesome. But before going forward, let's talk a little bit about mitigation techniques. So let's go through point by point. First, you need to protect the session ID and the login credentials. So protect session ID and credentials. The best way to do that is to use encryption. The easiest would be to do SSLTLS. Just make sure that you're creating a secure configuration for your SSL. The second is that attacks against authentication usually involve some kind of brute forcing attacks. So you have to protect against brute forcing. Protect brute forcing. You can do that by anti-brute force techniques or automation techniques, such as captchas or rate limitation or login limits, etc. Now the third is that still the biggest problem is that users use weak passwords. So you have to enforce strong passwords. Also make sure that these strong passwords are renewed time to time. Yes, it's a pain in the ass, but that's the way it is. The fourth point is you could implement some kind of two-factor authentication, like a mobile token or similar. That's definitely a huge step forward. So 4 is two-factor auth. And the fifth point is anomaly detection. So for instance, if you record the login from the same user at China and then 1 minute later another login from the same user in Germany, then probably there is something fishy going on. So you could respond by notifications, or you could use the two-factor authentication to make sure that it's the correct user or something like that. But anomaly detection always helps. Detection. These are all going to be really important for your customers because login and authentication is basically the three-headed dogs protecting the treasure. If it can be circumvented, then everything is lost. You could have perfect cross-site scripting protection or whatever firewalls and logging. If the attacker can figure out a password, then he will look like just a normal user and you will probably not notice that something bad is going on. All right, so congrats for finishing this section. I hope you liked it, and I will see you in the next one. Bye. Hi, this short section is about authorization. This section is not short because authorization is a short and easy topic, but because some parts we are going to cover in other sections. In this lecture, I would like to talk generally about authorization. So first, let's discuss the difference between authorization and authentication. So first, authentication. Authentication is making sure that the user is who he says he is. So when the user says he is Alice, then he has to provide some proof, like a password or a smart card or fingerprint or whatever, to prove that he is really Alice. That's authentication. On the other hand, authorization is making sure that the user cannot do anything else but what his privileges allow him. His privileges can be his access rights, the rule he has, the group he is in, but the important that he cannot do anything else, only what he's allowed to do. So authentication is a one-time check when the user logs in, but authorization is a constant check whenever the user does some kind of actions. So if the user says he wants to upload a file, then we have to check whether the role what the user has is allowed to upload files or not. Applications always have some kind of authorization concept. They can be very different, but they have the typical building blocks. So we have the application here, and it can have tenants. This could be different companies or different departments at the companies. It can also have roles like administrator, editor, read-only user, whatever. And then it has users, like you or me or whoever uses the application. And then we also have resources, like files or reports, features, rights like read or edit. So these are all some kind of resources. The authorization concept has to be a clear mapping between these elements. So a mapping between these. Basically, rules which tells us who is allowed to do what. It tells us which tenants are allowed to access which files, or whether a specific rule is allowed to create reports or read documentations. It has to be very specific because the application has to be able to check it. Also, the more complex the authorization concept is, the higher the chance that somebody screwed something up. Also, this is something which cannot be dealt with only at the implementation phase. The authorization has to be designed in the designated planning or design or architecture or whatever it's called phase. But the important is that it has to be started at the very beginning. Sometimes I tested applications when they didn't have really a sensible authorization concept, and they wanted to release the application like a week after our assessment, but the problems we found were so deep in the architecture of the application that it wasn't just possible to fix it with like an if or just adding a few lines of code. They had to go back to the design table and start all over again. For the customer, it was super expensive and immense delay. And with that said, let's start to see some attacks. I can tell you right now that these attacks are usually not technically extremely sophisticated. They are more about finding the weak spot than creating a tricky exploit. It's mostly about tricking the system. But I can assure you they are pretty interesting, so let's start with that in the next lecture. Bye. Hello. This lecture will give you an example about how variables or parameters can be manipulated to bypass authorization. So the goal is to figure out whether a specific parameter has effect on the authorization or not. If you see something that might have, then you need to check it closely. So let's see an example.
Everything is proceeding as I have foreseen.
Let's log into the Voice of the Emperor application. So I go to admin and use the low privileged user called Shale, and password is Shale123. And maybe you noticed during the discovery of this application that there is something weird in the HTML. There's a comment saying, fix me remove role parameter from admin URLs. So I looked through in Burp, but I haven't seen a parameter called role anywhere. And if you test a little bit this user role, you will see that it's the only limitation this user has is that the page is not loaded. So instead of the pages, you get a redirect back to the panel. So probably that's the limitation of the user role, that he cannot make new pages. So let's try to overcome this limitation using this role parameter. I will actually go to Burp. I will do it rather there. And I take a request which is sent to the pages and send it to the repeater. And let's see, you can see that if you try to load pages, you get a 302 found and it redirects to the admin panel. Okay, so I'm just guessing here. If it's a parameter, then it might be a parameter for the GET request, say role equals And I guess it has to equal with some roles. So let's start with administrator, yeah, go. Nothing changes, it's still redirect. Then let's do editor. That's the other role which exists in the application. Still nothing. Let's try admin. All right, that's something new. It seems like we got something. So let's go and say request in browser. Or I will just copy the URL, go back to browser and paste. And great, we are getting the pages page. That's awesome. So basically we could circumvent the authorization and get to the pages page, although we didn't have the rights to do that. You might ask, why does it matter? Because everybody can see the pages on the website. But if you look here, for instance, there is a page which is called Fix Me, and it's in draft, so you cannot read this. And if you look it through, then it's something, it talks about another website on the same server under II. And oh, there is the username and password for Lord Vader. Interesting. Okay, that could be interesting in the future. It's a perfect intel for a rebel agent like us.
The Emperor's made a critical error and the time for our attack has come.
Now, this was a pretty obvious example. We could edit the role with this parameter and get access to something which we're not supposed to access. But you would be surprised how many times this really works like that. And also, the same vulnerability comes in many forms. Sometimes you see parameters with access rights like read, write, or execute, or tenant IDs, or groups, or roles, or whatever. Basically anything what you see in requests, which could be related to the authorization and related to the fact how is it decided whether somebody can access that resource, then it might make sense to check that out really closely, because your chances that you might get an unauthorized access is probably pretty high. So that's it for now. We will go on with the authorization in the next lecture. So thanks for watching. Bye. Hi. In this lecture, we are going to check out another very typical authorization attack. In many applications, sometimes all, but at least some of the authorization decisions happen in the client side. So for instance, in JavaScript intensive applications, the JavaScript decides what parts of the website you can see, whether a feature allowed for you or not, or similar things, or whether you can submit a request or not. The only problem with that is that the client can be always changed. So the attacker has full control over the client, so it can, even if it's technically difficult, theoretically he can do whatever he wants. This is also very typical with rich clients, so with desktop applications, that the authorization decisions happen in the local desktop application, and the server will do whatever the application asks. But you can still override the application, change the application. Sometimes you don't even have to use the client, you can just mimic the client with another tool, and you get the same results. For instance, I've seen web applications where after the login, the server told the JavaScript in the browser which roles the user have, and then it was up to the JavaScript which buttons to show to the user or whether the user should have access to the administrator interface and things like that. But you could just simply change the role in the login response coming from the server, and from there the client thought you are an administrator and allowed you anything, and because the server thought that the client is checking the user, the server didn't check anything afterwards. So you could just do anything what you wanted. But let's see the Voice of the Emperor application, whether we see something like that there. All right, let's log in with Shale, the user which has the user rights. Password is Shale123. Let's use the same attack we used in the previous section to get access to the pages side. So pages and role equals admin. So you get access to the pages, but if you click on create a new page, then you will see that the save button is grayed out. So you can create a page, but you cannot save it. So you click on it, but nothing happens. So let's see that in HTML. Find the save button. It says class button type submit disabled. This happens really often, that you can just remove the HTML part which disables the button, and so altering the client in the browser. And now we can click on save, and it says the page was created. So let's just go back, and it's true, the page was really created. This is a typical error that you can just edit the client to do whatever you wanted, and it's just fine. Now you might think that this is too easy, and you're right. This is a very easy attack, but it still works many times. So when you are testing an application, look for security measures inside the client, because if you can bypass the security measure in the client, then you have a good chance that the server will not check it again, and then your attack will succeed. If you have other examples for similar attacks, then you could open a discussion or leave a comment or something like that. Just let me know. Otherwise, I will see you in the next lecture. Bye. Hi. So let's talk about countermeasures. The most important rule here is to never believe what the client says. That's the biggest failure developers do, is that they are trusting the data what comes from the client. Because that's wrong. That data could be at any point sent from an attacker or a malicious client or something like that. For instance, if the client says that, hey, I have admin rights, I can write this file, then your server should say that, wait a second, let me check that, even if the client also does authorization checks. Basically, any check done on the client side is only for user experience. Like, your client can tell you that you're not allowed to submit that form just to make it faster and don't send requests unnecessarily to the server, but all real security decisions must be made on the server side. Also, apart from the session token, the client shouldn't really send any authorization related information to the server, like the group or whatever, because the server knows everything. The server can take the session token and with that find out which user that is, which roles this user have, which groups this user is in, which rights he has, etc. Because it has the whole database there. So there is absolutely no need to transfer this information from the client when the server already has this information. As I mentioned at the beginning, authorization is both a design and an implementation problem. But you have to pay attention from the very beginning, because the later you're finding an authorization problem, the more it's going to cost to fix it. With this, we are finished with this section. So congrats. And as always, take some time, go through again what we learned in this section, see that you understand everything. And when you're ready, we will do some really cool attacks in the next section. So stay tuned, and I will see you there. Bye. Hi, and welcome in the Attacks Against the Client section. As the title says, this section we are going to discover attacks which specifically target the client. so the browser and the user. This means that these attacks will execute in the user's browser, although the malicious data is gonna pass through the web server, but it doesn't really gonna affect the server side. But these are still pretty serious attacks. The worst case scenario is usually that an attacker can take over user's account, and if that user is an administrator, then he will basically have full access to the application. Of course, after that, the attacker can still try to go further and attack the server side, but we will see that in the next section. This lecture is about the reflected cross-site scripting attack. The cross-site scripting is a kind of vulnerability where an attacker can manipulate the application in the browser. So, in theory, if you have a form, for instance, to get your name, and you submit this form, then the application is gonna use your data to create something in the HTML. For instance, generate a page where it writes your name. So if I put my name here in, Gary, then the application will generate an HTML code where it puts my name here, Gary. However, if you here submit some kind of HTML code, then when the website generates this page, then it will include the HTML, and this is what's going to be returned to the browser, and the browser will not be able to distinguish the original HTML content from the submitted input, so it will just render the whole thing as HTML code. This way, it's possible to alter the web page with an input parameter. We call a cross-site scripting reflected if the malicious input is not stored on the server, but rather reflected back to the user in the resulting page. So a request is sent to the server with the malicious input, and the malicious HTML code is then immediately delivered back to the user. In this case, the data is not going to store it on the server, but it's still going to take an effect on the user's browser. Of course, you see, the user has to submit the malicious data, so the attacker has to find some way to trick the user to submit malicious data. So usually, the reflected cross-site scripting involves some kind of social engineering, like sending malicious link to the user, and when the user opens this link, then the attack will execute. Or sending the user to a specific website, and when he opens it, then he gets redirected, and through that redirect, the malicious input will be submitted. Things like that. So there's always some kind of social engineering aspect. So let's see this in practice. As I told you earlier, the Who is Your Daddy application, what we wrote, is vulnerable to reflected cross-site scripting. So we can just go to var www.html and open our whoisyourdaddy.php. So if you look at here in the PHP code, you can see that we are taking the name parameter directly from the request and using it to include it in the HTML page. So we don't care what's exactly in this name parameter, we'll just turn it to uppercase and then put it in the page. That's pretty dangerous, because if we go to the page on localhost, there it is, whoisyourdaddy.php. Then you remember when we say Gary, then it's going to be just like I'm your father, Gary. But what happens if I say hi, Gary, hi? You can stop a little bit if you want to think about it. Just try to figure it out what happens if we submit this request. Okay, let's try. So the I stands for italic. So if I submit it, then you could see that the string Gary became italic because the PHP code turned our input string to uppercase and then returned it, but it's still HTML. Let's look at the HTML code. When I'm opening the source code, I do Ctrl U. Here you can see that this is our submitted string. You can see that everything is uppercase, but it's still HTML. The thing is that HTML is case insensitive, so it doesn't matter whether it's uppercase or lowercase. If it looks like HTML, the browser is going to render it. So let's try the most typical cross-site scripting attack. Script tag, and then JavaScript alert to pop up an alert window, and then closing the script tag. So let's see what happens in this case. What we are expecting is a pop-up window with the number 42 in it. But nothing happens. So let's look at the HTML code again. And you could see that the text is here, but it seems like it was ignored by the browser. We can turn on the developer tools. Specifically the console. And you could see that in the console there is an error that alert is not defined. So the problem is that when the PHP code turned our string to uppercase, it broke the JavaScript inside because JavaScript is case sensitive. So alert with uppercase is not the same function as the lowercase, and most importantly, it doesn't exist. So this happens many times that you kind of feel that there is a vulnerability there, but when you try to exploit it, it doesn't work. In that case, never give up, just try harder and try to figure out a workaround. That's what we're gonna do. So as you might know, JavaScript can be downloaded from other URLs as well, so it doesn't have to be embedded in the page. There's a source parameter for the script tag where you can define the URL where the JavaScript should be downloaded. And when the browser downloads the JavaScript code, it will be executed as if it was inside the script tag. The source attribute is not even subject to the same origin policy, so you can even host your JavaScript on other servers on the internet. So for our attack to work, we need to have our JavaScript somewhere. In our test, we'll just have it on the same server, but it could be somewhere else as well. So I will create a file called attack.js. And I deliberately wrote it with uppercase letters because that's going to be important for the attack. And I will just put some JavaScript code in it. Alert, I am the king of the universe. So this is basically pure JavaScript code, and it hosted on our server as attack.js. So what we can do in the browser, I close this, and instead of writing the script code inside the script tag, we can write script and not closing it, but saying source is HTTP localhost slash attack.js, and then we are closing the script. So again, it's script source src, sorry, HTTP and localhost attack.js. So as I said, it's now localhost, but it could be anywhere else on the internet, which can be reached from this page. Let's submit. And yes, the attack worked. It's awesome. The JavaScript in the attack.js was executed. That's why we get this pop-up window. So let's say OK, and let's look at the HTML source. As you could see here, here is our crypt tag transformed to uppercase letters. So the thing is that HTML is case insensitive, and also domain names are case insensitive. So as long as the attack.js is uppercase on the server, then it's going to be a valid URL. So when the page is loaded, the script tag is executed, the JavaScript code is downloaded from this page and executed as well. This is a really good example that if your attack doesn't work on the first try, just keep trying. You're going to fail many times, but the point is to keep your goal in mind. So let's talk about protection. How you could protect against cross-site scripting. The protection is two-sided. First is about validation, so validating all the input which comes to your application, and the other part is output escaping. So when we talk about validation, the point is to always make sure that the data which you're receiving is the data what you're expecting. So if it's a name, then you shouldn't allow any characters or anything. You just allow characters which are normally in a name. So letters, it shouldn't be longer than 50 characters because most of the names aren't, etc. If it's about a telephone number, then it's supposed to only have like digits and maybe a plus sign, and also limited length. So when you receive input in your application, then before doing any processing, you need to make sure that the received input fits to the data what you're expecting, and if it doesn't, then you should throw it away. Validation should be done with any kind of input what your application receives. Validation, however, is not enough. The other side is output escaping. So the problem here was that the browser, when he receives this data, it is not able to distinguish whether this is a text or HTML. Of course, in web applications, it's reasonable that some texts need to use special characters like the less than symbol. So you have to find a way to allow this. The way is to use encoding. So you can use HTML encoding to encode this string when you're building this page. And this way the browser will see that that's not really HTML because it's encoded, so it's supposed to be only printed as a text. So you've probably seen HTML encoding at some point. For instance, the less than is like ampersand LT as less than and semicolon. And greater than is GT semicolon. So some characters have a short form like the less than and the greater than, but most of the characters are just ampersand and then number and semicolon. So you can go to Burp, to the decoder, and say, for instance, test encode as HTML. And you can see here that D is encoded to this string, E is to this, etc. This means here that it's in hexadecimal. You can also write it in decimal, then you don't need the hash and the X, just the number. What you need to do in your application, make sure that all the data which was user input at some point, when it used to generate HTML, it's getting HTML encoded, so that the browser knows that it's simply data and not HTML code. Of course, most of the web frameworks have some kind of built-in mechanism for that. It shouldn't be really difficult. Usually the difficulty and the reason why there are still cross-site scriptings everywhere is that people are not encoding all the data because they don't think that this data came from the user at some point or the user has some influence on it. They just think it's some data from the database and they forget to encode the data when they generate the view. If we go back to our PHP application, we can fix this with a PHP function called HTML special cars, HTML special cars, and then we put the data in it. So the HTML special cars will transform all special characters to the HTML encoded version. So if we go back to the browser and reload this page, you can see here, this is where we submitted the script tag with the URL. And as you could see, now it appears as normal text and we don't get the pop-up window. Actually, when you see it, that already means that it wasn't executed as HTML, so that's a good sign. Control U, let's look at the source. And as I told you, the special characters, so the less than and greater than signs, were changed to the HTML encoded version. This way the browser knows exactly that this part is HTML, this is just a simple text, and the rest is also HTML. As an exercise, you can do two things. First off, implement input validation in this application. So try to think about how a name should be validated, what characters should be allowed and what doesn't. And in PHP here, before you do this line where you echo the result, you should transform before this line. You should check whether the name which was submitted is really a name or it's something else. If it's something else, then you can just drop it. That's the first exercise. And the second is that this HTML special cars function has its own flows. So it might be possible to work around it and find another way to do cross-site scripting even if this protection is in place. I can tell you right now that I don't know the answer to this question or to this exercise. So if you find a way to circumvent the HTML special cars function and still do a cross-site scripting, then you can post it here under this video. Otherwise, I will see you in the next lecture where we are going to talk about the stored cross-site scripting. Bye. Hi, in this lecture we are going to continue with cross-site scripting, but we'll talk about stored cross-site scripting. So the difference between reflected and stored cross-site scripting is that in case of a reflected, the malicious input is not stored on the server, but it's immediately sent back to the browser. However, with the stored cross-site scripting, surprise, surprise, the data is stored in the application database, and then it gets shown on various pages of the application. So basically, in case of a stored cross-site scripting, the attacker can deliver the malicious input himself and then wait until the target user or any users load the page where the malicious input is used, and all these users will be automatically tagged. So let's start to look at the other applications we know. So as before, go to the console of the Etherlab target machine and look for the Imperial Intelligence URL. Here's the URL. It's the same as the Voice of the Emperor, just with II at the end for Imperial Intelligence. Now load the URL in the browser, II, and you could do the same discovery what we did with the other application. It's a person of interest application, so basically a database about various people who are, for some reason, are interesting for the Galactic Empire.
The shield must be deactivated if any attack is to be attempted.
If you open any of the profiles, I go with Luke Skywalker, then you see that at the end there's a comment section. So we're going to experiment with the comment, whether it's vulnerable to stored cross-site scripting. You see, our input with the comment will be stored in the database, and then shown to every user who opens the profile of Luke Skywalker. So first of all, I will just test comment. What I usually do is I use the following test string, because this contains various special characters which could affect cross-site scripting. So if you submit this and then in the website where this string is used, then you might see something weird. And if you see something weird, then it makes sense to investigate further. So you can fill out the user and email address, but it's not necessary, and post comment. And you could see that it is weird. The XSS tag is missing. Let's see a little bit closer. So open the developer tools inspector. With the inspector, you can just easier inspect the HTML code. It's good if you have a bigger page. So yes, that's exactly what we were expecting. So you could see here's the first part of the test string. And then when the XSS tag comes, the browser really thought that this is a tag called XSS, an HTML tag. And then comes the second part of the string. And because there was no ending for this tag in the string, the browser added one. So this really looks like cross-site scripting, because the browser interpreted our input as HTML. All right, then let's do another test with probably the most famous cross-site scripting test string ever, alert 42. Yeah. So with that, we are trying to execute a JavaScript in the comment and make a alert window. Let's post the comment. It didn't work, and it says that the Imperial Cyber Counterattack team is notified. Yeah, that's bad for us. But anyways, if we are here, just keep testing. It happens many times that the application has some kind of protection against cross-site scripting, but most often there is a way to circumvent this protection. So now our simple script tag didn't work, so we just need another way to exploit this potential cross-site scripting. The good news is there are more or less unlimited ways to exploit cross-site scripting. What I usually do, you can search for OWASP XSS cheat sheet. Okay, it's because of the Burp suite. Actually, I turned this off for a second because it's super slow. And if you open this filter evasion cheat sheet, you will see that the locator, there's a longer locator, and here is the short one which I used. And then there are lots of various ways how you could exploit cross-site scripting. These are all techniques to avoid some kind of filtering or protection mechanism. You see there are a lot with image tag. So that's gonna be the next step what we're gonna try, to include JavaScript with an image tag. For that we say img source is, I will explain what this means in a minute, on error alert bound. It's important that the on-error attribute can contain JavaScript. That means that when some kind of error occurs with the loading of the image, this code will be executed. Now, for this to be executed, we have to trigger some kind of error. And to do that, we are going to load an image from a bogus source. This is this XX. And since that's going to cause an error, the JavaScript in the onError attribute will be called. So let's see if this works. Awesome. So as you can see, it worked. We get the pop-up window with the string. And if you push OK, you could see that there is this image which couldn't be loaded, which is fine because that's what we wanted. You can see it here in the HTML code. And it executed the injected JavaScript. So what this means for us, that anybody who browses this website and opens the profile of Luke Skywalker will get this JavaScript executed. So from here on, you can do whatever you want in the JavaScript. You could try to steal the session cookie, do some kind of manipulation on the website, load like rootkit in the browser, or even try to exploit the browser itself to get access to the user's whole machine. So there are unlimited ways what you can do with cross-site scripting, because the JavaScript in the browser is really powerful, and you will get all this power when you have a cross-site scripting attack. This attack is now much more widespread than the other because everybody will be attacked who opens this page. With the reflected cross-site scripting, we only attacked that user whom we social engineered to submit our malicious link or something like that. But in this case, everybody is attacked who opens this page. Also, if we want to do targeted attack, we can just trick the user to open this page by sending this link to him or something like that. With that, we are finished with cross-site scripting. There are various ways how cross-site scripting can occur in a website. Sometimes you can inject into JavaScript directly, sometimes through file upload, sometimes you can attack through XHTML, sometimes even through CSS style sheets. So there are lots of ways how a cross-site scripting can happen and how you can exploit them. So it's really up to your creativity. But important is to recognize when you can manipulate the website with your user input. If you can manipulate it some way, then you might be able to get it to working exploitation. As an exercise, you can try to find out why the protection against script tags, which gives us this error message, didn't work against the image tag. You can try to look it up in the source code of the application. You find it on the target server under /var/www/html/ii. If you're ready with that, I will see you in the next lecture. Hello. In this lecture, we are going to experiment with the HTTP header injection attack. In cross-site scripting, we injected data into the contents of the HTTP response. Now we are going to do more or less the same, but instead of injecting in the content, we're going to inject in the HTTP response headers. So let's go to the application, which is called the test page. So if you go to the target machine console, you can see the URL there. The IP is the same as the others, just it runs on port 8000. So let's load that. Port 8000. And make sure that Burp is also running. Yes, it's running, it's intercepting as well. So you could see that it's a pretty simple test page. If we go to Burp, we can go to history and here is the request. Nothing interesting. Here's the response. Also pretty simple, just a few headers and then a little HTML. So this is a pretty simple page. It doesn't really do anything. It mostly just proves that the server is running. But if you look closer in the response, you could see that there is an unusual HTTP header there, this request path. This kind of implies that the path that was requested is repeated here. Let's try that. Send it to the repeater, and first just repeat the request. It's the same, and let's see whether that's really the path. I will say test and go, and yeah. So basically, whatever your path is in the request, that will be mirrored back as the request path header. Now that we understand what it does, we can try to do some kind of manipulation. When we're talking about header injection, what we want to do is to inject a new line and a carriage return character in the header. If the application allows that, then we can add new headers to the response. So I said the carriage return and new line. In some programming languages, that's usually called \r and \n. That's the carriage return and then the new line. Of course, these are non-printable characters, so we cannot just write it here, and we also cannot use these forms. But what we can do, we can use the URL encoded version of these characters. URL encoding is always starts with the %, and then the ASCII number of the character in hexa, which will be 0D for carriage return and 0A for new line. And then we just add some text after that to see what happens. So let's send the request, and it looks pretty good. So what you see is exactly what we wanted. After the string test, the carriage return and the new line was left in the header, which was then interpreted as a carriage return new line, and basically the rest of the path was jammed down one line, and with that creating a new header element. Now XXXXX is not really a header, so we could use that for something else. We could use this in various ways. For instance, we could use this vulnerability to set a new cookie. That could be pretty useful. Since this test page runs on the same server as the Voice of the Emperor, we could create an Encore CMS cookie, which was the session cookie for that application, and that might be useful. To do that, we have to create a new header called set cookie. So here, instead of the XXXXX, we create a header called set cookie colon, and we are not going to use space here right now because it might mess up the request. So I will just do Encore CMS. This is the name of the cookie what we want to set. And then as a value, you could use anything. I will use the string all your apps belong to us. All right, let's try what happens now. Send the request, and that looks really good. So basically now with the header injection, we were able to create a good looking set cookie header with the appropriate cookie value. So it looks very nice, but let's see how that works in the browser. So I will just do right click and copy URL and go back to the browser. We can prove first that we don't have a cookie right now. I will then submit this URL. And as you could immediately see, a new cookie was set, Encore CMS, all your apps belong to us. And if I would reload just the normal page without injection and look at this in Burp, we could see that first we did the injection, there is no cookies in the request, then came the set cookie, and then when I reloaded the page, in the request, the cookie was actually really used. So we could create an active cookie for this IP address, and now we can go back to the browser and load our Voice of the Emperor application. It loads, and then check the storage, and you could see that the attacker's cookie is still used. Again, check in the burp. Here, yes, the cookie is in use, and all requests have our cookie in it. Now you might wonder why this is good for us that we created a cookie. Hopefully you remember that the Voice of the Emperor application is vulnerable to session fixation. When we dealt with session fixation, we said that the attacker needs to set the cookie somehow, either by physically changing it on the user's computer or to find another vulnerability that he can use to set this cookie. Now, this is exactly that kind of vulnerability. So the attack scenario would be that the attacker creates this URL, tricks the user to load it. When the user loads it, it will create an Encore CMS cookie in his browser, and then the user comes for any reason to the Voice of the Emperor application, and the attacker's cookie will be used. When the user goes to the admin page and actually logs in, we could still confirm here that we are still using the attacker's cookie. So he logs in as admin, long live the emperor. I hope I wrote it correctly. And yes, and because the application is vulnerable to session fixation, the attacker's cookie will be used for the administrative session as well. So basically, using this cookie, what the attacker already knows, he can load it in any other browser and connect to the admin panel, and he will get access to the administration pages with the user rights of the admin, because basically he's hijacking the admin's session. This example shows again that such innocent bugs can be combined to create a critical attack. For instance, even such a simple site as this test page, which literally doesn't do anything, can be useful in some attacks. Now, as I mentioned earlier, the header injection can be exploited in various ways. It could be also exploited to do cross-site scripting. So as an exercise, you could try to create a cross-site scripting attack using this header injection. Basically, what you want to reach is by injecting in the header. Basically, what you want to do is to use the malicious URL to somehow manipulate the content of the HTML page, because then you can inject HTML or even JavaScript, and then you have a cross-site scripting. It can be done, so try it, spend some time with it, and when you're finished, then we will see each other in the next section. Thanks for watching, and bye. Hello. In this lecture, we are going to exploit poorly implemented HTTP redirects. Basically, the server can tell the browser to load another URL instead of the one the browser tried to load. These are the redirects. But let me draw it. So here is our browser. And here is the server 1. And when, for instance, the browser tries to load a page from server 1, like index.html, then the server can tell the browser to go somewhere else. So instead of sending a 200 OK with the index.html, it can send an answer with 300 something. So for instance, 301 or 302, all of the 300 responses are some kind of redirects. Most of the 301 and the 302 is used. And in the header, it can tell the browser where to go. So it can tell to, instead of at this server, it should go to http server 2 / whatever. When the browser receives this response, it will, this is server 2, it will automatically load the provided URL from server 2. And then probably it will get a 200 OK from the server 2 with the requested content. This happens all the time in web applications. There could be various reasons to do this. For instance, when you load an HTTP website and the server wants you to use SSL, it will redirect you to the HTTPS port of the same website. Or it's a really important tool of online marketing. Whenever you click on a link in a marketing email, then the link will take you to an analytics page, like Google Analytics or something like that, to collect data from you, and then automatically redirect you to the real page of the product, what you wanted to see. This happens pretty quickly, so apart from the changing URLs, you will not really notice that there are a lot happening in the background. So let's see an example in the person of interest application. So let's go to our browser, make sure that Burp is also running and you are connected, and then load the person of interest. Yeah, Burp stopped my request. I turn the interception off. And yeah, the website loaded. And we go to the admin page. For that, I will just load the VP admin URL. And you could immediately see that something happened because this is not the URL what we requested. So let's quickly check it in Burp. So we loaded here the VP admin page, and the response was, as I told you, a 301 moved permanently response, and the location header tells the browser where to go. Now this redirect only happened because we didn't have the slash at the end of the URL. So now we are just loading the same URL, but with a slash at the end. So you could see here. And then for that, we get a 302 found redirect. And here in the location, we get another URL, which also has a redirect to parameter where our original URL is saved. I will tell you shortly why that happens. And then the browser will automatically load the given URL. Here you can see that. And in the response, you see the HTML code of the page, what we see here. If we analyze the page a little bit with the inspector, then let's start with the password field, but we are not interested in the password. But here, if you open this submit class, then there is a hidden input field called redirect to, and its value is the one which was given in the URL. So if we go back here, there is this value here, and you can see that in the response, also in a parameter called redirect to. Now if we log in, let's log in. It's Vader and for script for the bin. I hope you love my passwords. We logged in. Let's check in Burp what happened exactly. So you could see that in this request to the VP login, we send the username, password, and then there is this redirect to parameter with the original URL where we wanted to go. And in the response, we get again a 302. And here, if you scroll down a little bit, there is the location header, and location header redirects us back to the original URL, what I wanted to open. So what happens here is that this is just a way for the browser to remember where I wanted to go, but still do the authentication in the middle. So I wanted to load a URL, but I had to authenticate, so I had to go to the authentication page. So during the whole authentication, the original URL where I wanted to go is passed along in this redirect to parameter. And at the end, when my authentication is successful, I will be redirected back to the original URL where I wanted to go. So that's the reason of all these redirections here. Now we understand how the feature works, but why is this a problem? As you remember, in many attacks, we said that the attacker has to trick the user to open a URL or to open a malicious web page. Now, in many times it works with any bogus URLs and any weird web pages, but in case of a security-aware user, it might be more difficult to trick him to open a weird URL or open facebook.com with one O instead of facebook.com. So in such cases, it is much fruitful to trick the user to open a page in a web application which he trusts. And then we exploit this web application to redirect the user to the page our malicious code is. So let's see whether we can do it here in the person of interest or not. First, what I'm going to do is I take the login request and I send it to the repeater. First, I just want to see whether when we change this URL here, we will be redirected to an external URL or not. So you can go to params and here say, let's redirect to example.com. Example.com/can stay, but I delete the rest. All right. So if we go back, you could see that now the URL here is example.com. The important difference is that it is an external website. And let's send it. Awesome. Now you can see that we got the 302 found, and in the locations we are sent to the example.com. So that looks really good. It seems that if a user submits his login credentials with a malicious URL here, then he will be sent to that URL. Let's look at the first step. If we go back here, you see that when the login page is loaded, there is this parameter here, which actually tells the server where we want it to be redirected, and it will be used in the login page so that it passed along when we actually log in. So let's copy this URL and try it in the browser. So I will just delete all the cookies so that we have a clear session. And instead of this, actually I open a new window. So I click here, copy URL, and paste it here. But what I want to see is if I change the URL, the redirect URL here to example.com, again, delete the rest. Yeah, enter. And then let's look in the code of this page. And if you come here, no, it was not in the forgot me, it was in the submit. Yes, so in the redirect to, there is the example.com. Now let's log in. Oh, it's either for script for the bin. And as you could see, we arrive at example.com. In the request, it says go to example.com, and in the response, we actually get the real redirect to example.com. So the attack scenario would be that the attacker creates an evil page or a malicious page, and then sends this URL to the user, where the redirect to points to his malicious page. And because the user actually knows the application, usually people doesn't really care what's here. But if they know the application, so they know the host name, then they are probably going to trust it. So the chances that the user opens this URL is much higher than with any weird website. User opens this URL, he gets to the login page of the WordPress, and he logs in, and then he gets redirected to the malicious website of the attacker. Then the attacker can do whatever he wanted to do on this website, and he can even redirect the user back to the original website, so to the person of interest. On the malicious page, the attacker could implement various attacks. He can embed like exploits against the browser, or he can try to inject some kind of Trojan in the browser. Or if you remember, in the cross-site request forgery, we said that what the attacker needs is two things. First, the user has to be logged in when the cross-site request forgery attack is done, and that the attacker has to trick him to go to a website where the cross-site request forgery is triggered. Now, this vulnerability actually helps with both parts. First, it makes the user to log in, so that enables the cross-site request forgery, and then he is immediately redirected to the page where the cross-site request forgery is triggered. So from there on, there is no stopping of the cross-site request forgery attack. So it's pretty good. So with that, we are finished with the open redirect problems. Just to summarize, the root cause of the problem is that the application allows redirects to external website. This problem could be solved by not allowing external website to be redirected to, but just locally to the same domain. If you have questions to this topic, just post a comment or start a discussion. And otherwise, I will see you in the next lecture. Bye. Hello there. In this lecture, we are going to work with the content type header. So let's see. Just quickly load the person of interest application with the Burp listening. And go to Burp, allow, and go to the proxy history. And pick a request. This is the request to load the home page. And here in the response data, you could see that there's a header called content type, and it says that this is text HTML and also specifies the character set. So as the name says, the goal of this header is to tell the browser what type of the content of the request. And then the browser knows how to deal with this data. So for instance, if it says text HTML, then the browser knows that it's HTML code and it can be simply rendered as HTML. If it says, for instance, that it's an image JPEG, then the browser will know that it can show it as an image. And if it says, for instance, that it's an application octet stream, then the browser knows that it cannot do anything with it, so it will just download it as a file. So it's a kind of communication between the browser and the server, which specifies what to do with the content of the response. The importance of the content type comes in when it's wrong. For instance, a text file can contain HTML, because why not? Or at least something which looks like HTML, because when it's downloaded with the right content type, then the browser will know not to render it. It will just show it as text. However, if the content type falsely states that it's HTML, for instance by saying that it's a text HTML, then the browser will do its best to render it as HTML. So if the text file contains anything which is similar to HTML, the browser will render that. And this could lead to cross-site scripting. But let's try this in the person of interest. First, try it with our local server. So let's go to /var www/html and create a file here called innocent.txt and add some content. This is just an innocent text file, and after that I add the little HTML, the usual suspect or not. And I save it. So basically this is just a text file, but it happens to contain HTML code. Now if we load this from our local server, so from localhost /innocent.txt, then you can see it is just shown as simple text. Nothing happens with the HTML code inside. This happens because if we look at it in Burp, the response states that the content type is text plain. From this, the browser knows that he doesn't need to do anything with this file, just print it as text. Now let's log into the person of interest, vp-admin, and it's reader force grip for the win. Yes, and go to media. Here users can upload files to the web server, which can be then used in the posts. So click on add new and then say select file. Go to file system and choose var, then www, HTML, and then choose the innocent. And it was successfully uploaded here. We can open it and click on view attachment page. And then you can click on this link. And that's exactly what we were expecting. This is just an innocent text file or not. What happened here is that you can see that this is a direct URL to the innocent.txt on the server. So we download it directly. And if we go to Burp, here you can see the file is requested. And in the response, it says, the content type says that it's a text HTML. And since the content type said that it's text HTML, the browser will try really hard to render it as HTML. And since there is actually HTML code inside, the script tag will be rendered. And by that, the JavaScript is executed. And that's why we got the pop-up window here. So let's click on OK. So what you can do, or what the attacker can do, is upload a simple text file with HTML and JavaScript inside, then take the URL and send this URL to the user. And if the user opens this URL, then in his browser, the JavaScript will be executed. And with that, we are able to do cross-site scripting. The advantage here is, again, that since this is a legitimate website, the user will most probably open the URL. Although in this case, we need the user in the application because we have to log in to upload this file, but it can be still used to attack other users in the application. So it could be possible that this website is used by different people, and the attacker only has limited rights in the application, and he wants to escalate his privileges to administrator rights. So he uploads a file with JavaScript, then send it to an administrator, and through that he can steal the cookie of the administrator to hijack his session, or even to change his rights in the application. The wrong content type can be exploited in different ways, not just with cross-site scripting. Wherever you see that the content type is different than what's the actual content, then it always makes sense to analyze it and try to figure out whether it's exploitable or not. All right, that's all for this lecture. Play a little bit with this content type, try to figure out other ways how you could use it, and otherwise I will see you in the next lecture. Bye.
You have failed me for the last time, Admiral. Captain Piet,
Yes, my lord.
make ready to land our troops beyond their energy field, then deploy the fleet so that nothing gets off the system. You are in command now, Admiral Piet.
Thank you, Lord Vader.
Hello there. We are finishing the section about client-side attacks. So as always, I would like to talk a little bit about mitigation techniques. So let's see them point by point. First, you need to do validation. So first is validation. As we already mentioned, as you could see, most of the attacks are based on that users could manipulate something to input data. So the first step to security is to validate this data. Developers need to know for every input field what kind of data they are expecting there, and make sure that everything else is rejected. So if it's a telephone number, then no letters, for instance. This is not necessarily about security. It can save you lots of functional bugs as well when you make sure that your database is clean from garbage. The second point is output escaping. When the application sends data back to the user, then you have to make sure that these data will be used as intended. So if you're including user data in the HTML page, then you have to always make sure that all this output is HTML encoded. With that, you can catch most of the cross-site scripting attacks. The third point is the XSS protection header. So XSS protection header. Modern browsers have built-in cross-site scripting protection, what you can manage with the XSS protection response header. So it responds what comes from the server. You can tell whether you want this protection to be turned on or turned off and how it should work. This works well against reflected cross-site scripting attacks because what it does, it checks that whether a suspicious input in the request was reflected back in the HTTP response. If it sees that, then you can either remove the suspicious part or block the response altogether. Of course, as always, there are quite a few bypass techniques. So as an exercise, you can research a little bit how you can bypass this XSS protection in browsers. If you find something, then post a comment or open a discussion about it. The fourth is the content security policy header. So for the policy header, this is also an HTTP response header, and this is the newest protection mechanism. With this header, the server can tell the browser from where and how resources could be downloaded. For instance, when we did the cross-site scripting with the external JavaScript file, we could protect against such attacks with the content security policy because we can tell the browser that JavaScript files are not allowed to be downloaded from external domains. A great resource on CSP is the contentsecuritypolicy.com. Check it out. With this, we are finished with the client-side attacks. Of course, there are plenty of other attacks, techniques, various exploitation methods, but I think what we learned here are the mostly used and most important. But anyways, congrats for finishing this section. I recommend you now to stop a little bit, go through again what we learned in this section, make sure that you really understand everything. If it doesn't, then exercise a bit more, research a bit more, or open a discussion. And when you're finished with that, then I will see you in the next section. So thanks for watching, and bye. Hello. Welcome to the section about server-side injections. Here we are going to focus on attacking the server itself and try to get shell access to it. This lecture is about file uploads. Testing the file upload is always very promising. Uploading a file can be your Trojan horse. And I don't mean the malware, I mean Greeks attacking Troy. There are various attacks you can do, but the one I really like is uploading source code, what you can call later, and with that you can get full shell access to the application. But enough talking, let's try it out. So let's go to the person of interest application and log in. Vader force grip for the win. Yes, and if you go to media, by the way, make sure that Burp is running. And here you can see here are all the files which are uploaded, and we can add the new one. So since we know that this application runs PHP, we can try to upload a PHP file. So let's go and try. But first, I will go to Burp and I will mark our position to see which requests are sent. And then select file. And I will just go to var www html, and here are the various files we wrote before. So I would just, as an example, I would just try to upload the whoisyourdaddy.php. And nothing seems to happen, but if you scroll down, you see that you get an error message that this file type is not allowed to be uploaded. Let's check it in Burp. Weird, because there's a request sent, but it doesn't upload anything. It's just a heartbeat request, so it just tells the server that it's running. What this really means is that this error actually comes from the JavaScript code running inside the browser. So that checks whether a file that we want to upload can be uploaded or not. And if not, then it will reject it. That means that there is actually no file sent to the server. What we can do is usually such checks can be easily circumvented by not using the browser to upload it, but doing it in another way. So what I'm going to do is click on Add New, and first I will set up Burp to intercept, and then I will upload just a simple text file. For instance, here is this innocent.txt, what we created earlier. And it started to upload it. That looks better, but of course it was intercepted by Burp, so it's standing here and waiting to be forwarded. But before I forward, I will change it to be a PHP file. So test.php. Here I call it also test.php, and I will change this code to PHP code, PHP, and then PHP info This is a simple info function from PHP, just to prove that if PHP is executed or not. And then forward. Okay, intercept off. Let's go back to the browser. It looks good. You see now there is a test.php there. So what happened is that the browser thought we are uploading a text file, and then we changed the file contents in Burp. So basically between the browser and the server, that instead of the text file, we upload a real PHP file. So click on that file and then go to View Attachments. Now we want to call it in the browser, because what we want to see is whether the server actually interprets it as PHP or not. Because if it does, that means that we have code execution on the server. So let's open it. And it's awesome. So what happened now is that we were able to save a PHP file on the server. And when we call that PHP file, so when we load the URL of that file, then the Apache server will actually run it as PHP. So that means that we can upload now any PHP files and do whatever we can with PHP source code on the server. Let's use it for something to actually get shell access. So if you go to a terminal, then there are actually various web shells preloaded on Kali for various languages. So if you go to user, share, and web shells, then here you can see all the languages which Kali has web shells for, and we need the PHP, so go into PHP. And here you can see there are quite a few possibilities. We're just gonna try the simple backdoor first. So it's pretty simple. This is the PHP code for it. As you can see, what it does, it checks whether the request has a CMD parameter. It can be a GET request or a POST request. And if it does, then it will execute the CMD parameter with the system function. So basically call it in the shell. So with that, we could have command execution on the server. So let's try that. We will go back to Burp and go to history and try to find the request where you uploaded that file. Yes, it's here. This is this vp-admin async-upload.php, and it's a post request there. So this was the request we manipulated. So let's take the edited request and right click, send to repeater. In this way we don't have to play around with the browser, we can do everything here in Burp. And let's call it shell.php, change it here as well, and then copy paste from the terminal. By the way, if you don't know, the hotkey for copy pasting in terminal is Ctrl+Shift+C for copy and Ctrl+Shift+V for paste. Now back to the Burp, and then here with Ctrl+V, just simply insert it. Okay, so now we upload that. It says it was successful. Now let's go back to our browser and go back to media. Yeah, and you can see there is the shell.php. Let's open it. We just want the direct URL to it. Here, click on the link. So this is the direct URL for the shell. As you can see, it does nothing by default, but if you add a parameter called cmd and then say a shell command ID, and then enter, then you actually get back the results. So this is the same as we would type ID here, just of course on the other machine. And with that, we see that we have the rights of the web server, which is the user www-data. So we can now do anything on the server with the rights of this user, which is still somewhat limited, but this could be your first step to actually own the whole server. But you need to look for a privilege escalation vulnerability to get root access. We can also do else like cat /etc/passwd to see the users. You can see these are the users existing on the server, etc. So here you can execute any kinds of command, what you want to do. It's now just up to you what you want to do on the server. You can also try a different web shell. Let's try this one. Again, copy paste it. It's a bit more sophisticated, not just the command execution. It has a little bit of web interface to it. Yeah. So copy, then go back to Burp, and we can paste it here in the repeater. Just give it another name. Yeah, like let's call it shell2. Here I will shell2 and go. It was successful. Now we can go back again to the server. And it's here. Let's open it again. But as you can see, this is now a bit more. If you knew the MySQL password, you could immediately send requests to the database. We can browse the whole file system. This is the root file system. Of course, we are doing all this with the rights of the web server user. But for instance, we could go to var www html and II, and here if you open the vpconfig.php, then you have the database password. So you could start extracting data from the database, things like that. And that's only with the rights of the web server user. On the button, you can also do the same kind of command execution, and that's it. So this is just, it's the same thing. You can see that it's PHP, so whatever you implement in PHP, you can use it on the server. So that is how you can get shell access on the server with file upload. Similar attacks work with other languages and frameworks as well. So it always makes sense to analyze the file upload closely, depending on the target application what you're using. So how to fix such a vulnerability? First, you need to validate the uploaded files on the server as well. So there was a reason why the JavaScript rejected this file, and it should have been rechecked on the server and rejected again. So always, and this is not just for file upload, it's always very important that if you have a client and a server, and if you do validation or any kinds of check, you need to do that on both sides, because the client can be always circumvented by the attacker. You can always talk directly with the application. And it's true for rich clients as well, not just for web applications. And the second is that you could configure your web server not to allow execution for uploaded files. So for instance, you could set that for the folder where the uploaded files are saved, that any file in that folder shouldn't be executed as PHP, but just used as a normal file. As an exercise, you could try the other PHP shells here on Kali. the rest here. Play with it, see how they work, because when you will need it, it's good if you know what are your possibilities and which is your favorite. Otherwise, when you're ready with that, I will see you in the next lecture. Until then, bye. Hi, in this lecture we are going to talk about these two cryptic acronyms, LFI and RFI. They stand for Local File Inclusion and Remote File Inclusion. So file inclusion is like importing or loading a library. In PHP you can include the file in another PHP file, and with that basically taking the content of the included file and putting it into the original file. There are various reasons to do that. One is to structure your applications. For instance, you could have like separate PHP files for header and footer, and then in the main file you just include these so you don't have to repeat them. You can use them in every file. Or you can also use it like libraries, that you implement helper functions in a separate file, and then you just include it everywhere where you want to use these functions. For instance, if we log on to the target machine with SSH, and go to the root folder of the application. So if we go to VP admin and then, for instance, open the user edit.php, the color is not too good, and then search for include, then you could see that this include takes the content of the admin header.php file and inserts it here. That means that whatever is in the admin headers PHP file, that will be included at this point of this file. And at the end, you could see that the admin footer is also included. This is exactly the example what I said, that there is a separate admin header and a separate admin footer, which can be included in any other files. That will give us all the content on the admin page, which is the header and the footer. So like this one, that's the footer. So the application is vulnerable to file inclusion if the attacker can somehow manipulate which file gets included in the website. So let's go to the main page. Here you are. And let's look at the source code. During your application discovery of this application, you have probably seen something weird, that there is a comment here which says, fix me, remove the debug param before going to production. So it's in production and we don't know what this debug param really is, but it's a good idea to start experimenting with it. So first, let's hope that it is just a simple get parameter, debug param equals test. Let's see what happens. Nothing specific. Let's try whether file inclusion works. There is a readme HTML in every WordPress installation here at the root folder, readme.html. Let's try to include it here. Okay, that looks good. it seems a bit broken, it's because we actually took the content of the README HTML and inserted it somewhere at the beginning of the home page. And that kind of breaks the design of the home page. But that basically means that we have a local file inclusion for sure. But what can you do with that? For instance, you can start extracting data from the server. Like if we say we do a little path traversal and step back until the root folder, I just input like a lot of step backs so that we at some point arrive to the root of the file system. And then from there we say etc passvd to download the passvd file. And it's really good. You could see that the passvd file was included. So what happens, we were in this folder and here we went back a lot, and then etc passvd. And then, for instance, if we say cut, then we get the same response. So this is the content of the file, and this was included in this web page because of the file inclusion. So probably what happens is that this debug param is used in a include function, and it includes whatever is specified in this parameter. So this is already a way to steal data from the server, because you can access all those files which the web server's user have access to. But it would be better to get shell access as before. We could do the same thing what we did in the previous lecture, to upload a shell and then load the shell locally from here. So basically give the path to that PHP file here. But what's even better is if we can do a remote file include. That would mean that we are not including file from the local file system, but we are downloading a file from somewhere from the internet and using that in our PHP code. Let's try that. To do that, first we have to actually have a file somewhere what we want to download. So we are going to do this on our Kali machine. So go to your Kali and go to the user share web shells PHP, where we had our shell before, and copy the simple PHP backdoor to the root of Apache, which is under /var www/html, and we will just call the file backdoor.php. Yes, now if you check your IP address, it's here, and then we load it in the browser and we ask for the backdoor.php. Then we get access to this backdoor file. But the problem is that it's a PHP file and our own Apache is interpreting that as a PHP file. Be careful, because now with that you're actually opening a backdoor on your own machine. But we want to do something else, because we actually need the source code content of this file. So we have to tell our web server not to interpret or not to execute the file when somebody's loading it. To do that, first go to the web root. And here we are going to create a file called .htaccess. htaccess is a Apache configuration file where you can extend the main Apache config with additional configuration, but on a folder basis. So wherever this file is, that means that adds a new configuration to that folder and all subfolders. So what I want to do is say PHP flag engine off. This will tell the web server to turn the PHP engine off. And we save it. But we still need to tell the Apache to check these htaccess files. We can do that in the etc apache2.conf. So open that file and scroll down. These are all just comments. And what's important for us is that this is the configuration for the directory where our web root is. At this line, the allow override tells whether .htaccess files are allowed or not. So we have to change that from none to all. And then reload the web server. So service Apache 2 restart. Yes, and I go back to the browser and load the backdoor PHP again. And it doesn't look too good, but if we open the source code, you could see that instead of interpreting it as PHP code, it was just served as a file. So that means that now we can download it and include it in the other application. So if we go back here, that means that here, as the include parameter, instead of a file name, we'll say the whole URL. So http / and then the IP address of the Kali machine. And backdoor.php, enter. Okay, you see that it works because we got this usage info here, which is in the backdoor PHP. Now to actually use the backdoor, we just add the other parameter with an end, and then cmd is ID. And you could see that now the ID command was executed on the server. So basically, with that, we got a remote command execution on the server again. So we have shell access again. So the good part with the remote file inclusion is that we don't need rights to upload files. So with the local file inclusion, although we could still get shell access, we can only do that if we actually have a user to log in to be able to upload PHP file. However, with the remote file inclusion, we don't have to upload this file. So basically anybody who has access to this main page can do the shell access. This is just increasing the risk of the vulnerability. Although this seems like a pretty PHP specific problem, but it can happen in any other languages where there is a possibility of file inclusion. To fix this problem, you either don't use user supplied data in file includes, or you make sure that this input data is really well validated before passing it to the include function. Also, against the remote file inclusion, you can configure PHP not to allow external includes. That's actually the default configuration of PHP. As an exercise, I recommend you to check the source code of the person of interest and try to find the vulnerable part. A good starting point would be to search for this comment in the source code, and wherever this comment is, you will find the vulnerable code. So look at it, try to understand how it really worked, and when you are ready, I will see you in the next lecture. So take care and bye. Hi, in this lecture we are going to discover another way how you can get shell access to the target server. This type of attacks are boringly called operating system command injections. This tells us that somehow we are going to be able to execute operating system commands on the server. So what happens in many times with web applications is that the developer wants to interact with the operating system somehow to whatever, create files or get the current time or something like that. In most of the times, the used programming language like PHP has a built-in function to do that. So to get the time or something like that, or create a file. But in some cases, there is no function in the programming language. And then the easiest way to do this is to call shell commands on the system and do the same thing in shell. So to create a file that you can do touch in a shell command or something like that. Most of the languages have function to call shell commands in the operating system. So for instance, in PHP, there is the exec and the shell exec function. So exec and shell exec. The difference is only how the output is interpreted or returned to the program. So these are PHP functions, so you can call them in the PHP code, and you pass along a shell command what you want to execute. So for instance, if you want to list the files in the web root, then you can do the following: exec and then ls for listing files /var/bv/html. So this command is PHP, and this is the shell command to be executed. Now, a command injection happens when you can somehow manipulate the command which is executed in shell with your user input. So for instance, the following code would be vulnerable: exec, and then starts off as the previous one, ls, but then we allow the folder to be specified. So in this case, we're taking the folder from a folder parameter in a GET request. So the URL would be like something / whatever index.php, and then folder is, and then the folder. However, you don't have to stop here. In shell, you can concatenate comments after each other with the semicolon or with the end symbol. So you can say like ls current folder and then echo hello. So it lists the current folder and then prints hello, because these are actually two commands. This is the first one and a semicolon, and this is the second one. You can do the same with end. The difference is that this command only gets executed if this one is successful. So in this case, we could do /index.php and then folder equals to whatever, and then new command touch /tmp/test file. So basically, when you would call this URL with this value in the folder parameter, as that passed along to this exec, that will actually execute two commands. One is the ls/ and the other is the touch test file. And with that, we can basically write on the disk of the target machine. So with that, we get the command injection because we are injecting an unexpected command or even more commands in this one call. But let's see if we can find one in the person of interest. So when you did the manual discovery on this application, then you could have noticed that if you go to your user profile, under user, your profile, then there is a attribute called website. So you can add your website to your user profile. The only problem was that it didn't work all the time. So you marked it to be analyzed later. Now we are analyzing it. So first start with the normal URL, example.com. And scroll down and update profile. Profile updated. That seems fine. So now let's try with a bogus URL. It could be whatever dot something, and then update profile. And you get an error message saying that website doesn't exist, wget returned 4. So if you're familiar with wget, it's a command line tool to download something from the internet. So my suspicion is that they are using exec to call wget to check whether that website what you typed in really exists. So they just want to make sure that it's not a fake website, and they are checking it. But that tells us that we might be able to inject into this wget, because they are probably just adding the URL to the wget. And if they are not validating the URL before calling the shell command, then you might get command injection. So let's first just try to create a new file. I would say semicolon and touch, and we'll do that under the root of this app. So var www html ii, and we call the file test.txt, and then go and update profile. So profile is updated. That already sounds good. Now open another window and say the URL of the app, and then test.txt. Now the good sign is that we didn't get a file not found error. That tells us that this file exists. Of course, the file is empty, so we also doesn't get any content. But what this means is that the command injection here, this command was really executed because this test.txt was created in the web root. That's awesome. That means that we can use this to execute any kind of commands in the operating system shell. Let's try another thing. I would say cp for copy, and then etc bus with the, and then again to the web application folder. I use the web applications folder because that's what we can access from the outside. So this will copy the passvd file to the web app folder, update profile. It was successful. So let's go to the other tab and try to open passvd, and we get the file. So this means that now we are capable of extracting any files from the server. We could just copy them to the web app folder, and from there you can download it. We have more or less read access to the whole disk of the target machine. So in this case, I want to show you the source code, so the vulnerability itself. So if you go to your Kali, then log onto the target machine. And then I will become root. So here we are in the app root, and then we can find where the vulnerability is by triggering the error again, and then searching for the error text. So we can search for this. So grep -r for recursive search, and here it was found, and you could see that it's under vp admin includes user php. So let's open that file. So the color scheme is pretty bad, so I will just quickly change that to color. Yeah, hopefully you will see that better now. And if you scroll down a little bit, we are just looking for the same error message, and it's here. So basically it says this is the checking URL, and here this is the vulnerability. So as you can see, it calls the exec and then wget and some parameters, and then it directly takes the URL from the post request and concatenates it to the command, and then the command is executed. And if the execution was unsuccessful, then it gives us the error message. So that's how the vulnerability looks like, because we are directly using the post parameter. That's always a bad idea, not to sanitize the parameter. This was probably just a mistake, because here, as you can see, it takes the URL and it does an escaping, and that's how it stores it in the user object. So the programmer could have been used the user object user URL here instead of directly from the post. So that's how the problem looks like. As an exercise, you could try to download a web shell from your own Kali, similar to what we did in the previous lecture. But what you want to do is serve the backdoor on your own web server on Kali. And then here, the injected command should be also a wget, where you download it from your own Kali and save the file in the root folder. Just check the wget how you can configure it to do that. And then you would have root shell on the application. So you could do the same thing what we did in the previous lectures, just look around and execute commands a bit more easier. When you're ready with that, you can join me in the next lecture. So take care, bye. Hi, in this lecture we are going to talk about one of the most well-known vulnerabilities of web applications, and that's the SQL injection or SQL injection. Obviously, to have a SQL injection in a web application, it has to talk somehow with a SQL database. If you research a little bit about WordPress, the framework what the person of interest app uses, then you will see that WordPress uses MySQL as a database. So we have the possibility of an injection. But first, let's see what is an SQL injection. For that, let's log on to the target machine. So I go SSH, ether, and then the IP of the machine. And for ether is the password. And we are almost in. Yes. I will actually immediately change to root rights. So if you go to var log MySQL, and there's a file called MySQL all. I configured the database so that it logs all requests, what you can then see here. So let's do tail -f and MySQL log. If you don't know, tail -f is to follow along with a file as it changes. So this is where we stand now. And for instance, if you do a search here, I search for test, go. Then here we see that there were so many requests sent to do only this one search. So I'm assuming that you more or less know the SQL syntax. These are all the queries that were sent. And of course, sometimes you need to use the input from the user in queries. Like for instance, our search for the string test is here. You see it was used in various conditions to get back all the posts which somehow contain the term test in them. So the SQL injection comes from the programming failure of how these queries are built in the application. Because what we are going to try to do is to manipulate queries with our user input to actually get back results which are interesting for us as attackers. Let's look at a simple example. I will just open a new tab and just open a file. So let's say if you want to list all users, then you can say select all from VP users. This is the VP users is the table in the WordPress database where the users are stored. So that returns the user list. If you just want to find out something about a specific user, then you say select all from VP users where user login is Vader. So in this case, this query will already return users from the VP users table where the user login equals to the string Vader.
What is it, General?
Of course, in the where statement, you could have various conditions which will result exactly in the data what you're wanting. As you can see, these requests, for instance, have many conditions to only get those posts which are interesting for us. And of course, as I already said, at some point you will want to use somehow the user input in your request because, of course, you want to serve your users. So that's the whole reason of the application. So as the search term is used here, or as the username used here, at some point you will also use user input in your request. So the wrong way to create a SQL query is just to concatenate together the user input with the rest of the query without doing any validation or something like that. So for instance, if you say in PHP that your query is this string, select all from VP users where user login is, and then since we will want to use the user input here, we'll just concatenate. Dot is the concatenation in PHP, and then from the get request we take the name parameter and then continue our select statement with and user password is, and again taking it from the request. I left out two quotes, single quotes here. So basically you're creating a new query where the first part is always the same, Then you use the supplied username for the user login and the supplied password for the password. And then this is the request what you're going to send to the database. Now this could be a way to do a login, to use the supplied username and password, and if this query returns anything, then the user exists, then you can let them into your application. Now this is vulnerable. A SQL injection happens when you submit these data. So name is whatever admin, and password, and here comes the trick. We say some text, then apostrophe. With that, this is where we are injecting. So at this point, we filled out this part, which is supposed to be a password. So we are here right now. And instead of letting this apostrophe close our user password string, we are closing it ourselves in the input. And then we continue and say, or 1 equals 1. Comma. So we just copy this request and add it here, and then I will fill out the blanks. So we said that the username was admin and the password was xxx and then apostrophe, and this is where the injection really happens, because we are stepping outside of the variable or the value of that variable which we were supposed to edit, and then we keep writing and we say or 1 equals 1, and then with the colon we are closing the query, and with a double dash we are going to comment out the rest. So the double dash is a comment in MySQL. So basically the rest which stays from the original request, that's the apostrophe and the colon, will be ignored by the database when this query is sent to it. But what can we do with this one? So basically we added another condition, this or 1 equals 1. We use 1 equals 1 because that's true. That's always true, because 1 is always 1. And then we added or, because what happens is that if you have an or true in your where statement, then the whole statement is true. Because if you have options that something is false or true, or true, then because of the or true, it's always going to be true. So what happens is whatever your username and password was, because of this or true, this whole condition will be ignored, and the query will return all users from the database. So that's not an accident why I'm using this example, because that's basically the textbook example of SQL injection. Because if your application is doing the login like this, the checking whether this SQL query returns anything, and if yes, then lets the user in. Then with this or 1 equals 1, you can actually get access to the application without knowing the password, because you didn't put in the real password, you just did the SQL injection. But the injection makes this whole request true. It will return all users from the database, and then the application checks whether this request returned anything, and since it did, it's going to let you in. So as I said, it's the textbook example of SQL injections, but it was actually used a lot in applications for some time. Nowadays, because of that, because it's very well known, you probably are not going to see it anymore. But I like it because it shows perfectly how you could manipulate SQL query with the user input. How you can use SQL injection vulnerability really depends on the application and on the input field, because sometimes you can extract data, sometimes, like in this case, you can get unauthorized access. So it really depends on how the query is used and what the application does with the requested data. But enough talking, let's see some examples. So go to your browser, have Burp running. And I'm sure if you did a manual discovery on this application, you've already noticed that it has something called API service. So if you open it just like that, you get a simple help page, which tells you that this API is created for scripts and other applications to request data from the person of interest database, and that there are some parameters what you can use basically to do your searches. So let's just try it. I will just search for the title solo. And as you can see, we got back JSON. JSON is a data format which is used a lot in web services. So if we go to Burp, we can do the rest of the testing in Burp because we don't need any interface to do this. So just go to this request. This is the request what we send, and I will send it to the repeater. And we can repeat it here. So you can see you get all the data. So this is basically all posts which have solo in the title. And you can see that it's 5,800 something bytes long. Now let's try the attack what we just did in the text file. So I'm assuming that we can go back to our MySQL log. And as you can see, this is the query which was sent when we did our search. So it searches for post title, post excerpt, post content, and it checks whether the post title contains the string solo. These percentage signs, that's only for the like, to return all titles which have the substring solo in them. So we are trying to inject here. Let's try to do that. So first we need to finish that like string. For that we need a percentage and then an apostrophe to close it. And then we can start injecting. Plus is, since we are writing in a URL, we need to do URL encoding. And in the URLs, plus means space. So instead of space, I write plus. And then we say or space 1 equals 1 colon or semicolon dash dash to comment out the rest. And I will add another space at the end because otherwise the syntax will not work. One other thing, the percentage is used in URL encoding, and that's why it doesn't always work to use percentage as a literal string. So I want to use the URL encoded version of the percentage. You can find it out if you go to decoder and then you say percentage and encode as URL. Then you will see that it's %25. That's why we cannot use the percent, because each URL encoded character starts with the percent and then a number. So we just take %25, and that's what we are going to use here instead of the single percent, right? And now let's send it. Now what you should notice that instead of the 5,000 something bytes, we got 78,000 bytes. And you could see that this post title starts with Boba Fett, which absolutely doesn't have solo in it. So our injection was probably working. If we go again to the logs, you could see our injection here. It's pretty unfortunate how it looks like. I will make it a little smaller. So you can see here that here it looks like an absolutely fine query, which asks for all titles including solo, but then adds an or 1 equals 1, so an or true condition, which makes the whole where statement true. So it's going to return all posts from the table. And that's the reason why we got so much data, because we basically got all posts, not only those which contain solo. Of course, in this specific attack vector, it doesn't really do anything harmful, because you could get the same data in a simple request. So you don't really have to do injection to get this data. You could do it with a normal request. but at least it gives you the chance to understand my forever favorite XKCD comic, Little Bobby Tables. So this was just an easy example. In the following lectures, I will show you how to exploit this vulnerability to actually get unauthorized access to data, to extract data, and how to automate it. Until then, as an exercise, you can check out the source code of the API.php to understand why it's vulnerable. You can find it on the target machine in var www.html.ii, and it's here, api.php. So check it out, and when you're finished, I will see you in the next lecture. Bye. Hi, let's continue our adventures in SQL injection. In this lecture, we are going to try an exploitation technique called the union select. Union is an operator in SQL languages which allows two select statements to be combined and return only one resulting table. So basically, the return table will first contain the results of the first select, and then at the end, the results of the second select. Because of that, a really important thing is that both select statements have to result in the same number of columns. So if the first one returns 3 columns, then the second one also have to return 3 columns so that you can combine it into one table. But let's see an example. So let's log on to the target machine. Yeah, if I knew the password. And I will change to root. And then I will open the MySQL console. So the username is root, and we will add the password. So the password is my lowercase, and then SQL uppercase, and PW lowercase. So we are now here at the MySQL console. So we say that we want to use the VPDB, which stands for WordPress database. Then, for instance, show tables. So these are the tables for the person of interest application. So let's do a query. Select ID, post, title, post date, and from the vpdb.vp post. So we are just requesting these rows from the posts table. As you can see, we get back the table. There's a ID column, post title column, and post date column. And let's do another request. Select and user login, user email, and display name from vpdb.vp users. So we are requesting these columns from the VP users table. Let's see. Yeah, we get there 2 users, and these are the 3 columns. Now we want to combine these 2 requests to get the results of both requests, but as one table. So first, we're going to take the first request, and instead of closing it, we'll continue with union all select, and then comes the rest of the second request. Right? So basically, we are creating one select query from 2, but important that they have to have the same number of columns, which is all right in this case because both of them have 3 columns. Now let's see. Yes, you could see first it starts with the results of the first select query, and then here it continues with the results of the second select query. But why is this interesting for us? In a SQL injection, you can only manipulate the request you are injecting into. And usually you can only inject into the where clause. So for instance, if we say here where whatever, so usually you can inject in this where clause. So you cannot really tell from which table you want data. So with a simple SQL injection, you are limited to the data which is in the table what the original request uses. So if you want access to other tables, we need to execute another query and somehow include its output in the output of the original request so that we see that on the website. Now the union operator allows us to do exactly this, to combine 2 select statements and return both of their results in one table. But when one tries to use a union in an injection, then the first question is always how many columns the select query has. This is all obvious when all queried data is sent back to the user, but sometimes the application queries more data what actually he shows to the user, like it queries 5 columns, but in the resulting table on the website, you can only see 3 columns. But we can figure this out easily. Let's go back to our Burp. I still have my request here with the injection. That's what I want to develop further. Here in the terminal, I will exit this and tail the log file so that we actually see the request, the select queries we are sending. Log MySQL. Yes. So you want to change only this part. Instead of the or, we add the union all select. Oh, the spaces has to be replaced with plus. And I will just add the number 1. Because now we just want to find out how many columns the first statement has. And with this, we are guessing that it has just 1 column, not with the number, but with the number of columns here in the second select. But we will see that in a minute. So let's do it. And as you could see, it didn't return anything, probably because the number of columns is different in the two statements. Let's check it in the MySQL log. You could see that the first statement, which is built in, has 3 columns. And in the union statement, we only had 1. So because of that, it cannot return the resulting table. But you can brute force this really easily. You just always add another column. It doesn't really matter what's the string here. The important is the number here. It is the number of columns. So I test for 2, still nothing. And then I test for 3, and then we got results. But we already know that the original or the first statement has 3 columns, so we also have to have 3 columns here. Now that we are getting back data, we actually have a fresh select statement in our hands, so we can start extracting data from the database. So for instance, we could do things like use the variables in the database. This is a MySQL variable to ask for the version number. And if you scroll down at the end, you see the results of the second statement. Here are just these 2 strings, which we use the number 1 and number 2. That's just copied there. And then here is the value of the version variable. So we found out the version of the database, which can be good if we want to attack or exploit the database directly, or want to do a privilege escalation or something like that. We can also use database functions here, like asking for the current user. Go, and then when you scroll down, at the end, as a last parameter, you will see, and start to read a bit, that it's root localhost. So that's the user, what the web application is using to communicate with the database, which is actually already a finding what you can put in your report. So MySQL can handle many databases, even for different applications. And each of them should have their own user, so that the user of one database cannot access the user of the other database. Like on this server, there are two applications running, the Voice of the Emperor and the Person of Interest. And the fact that the person of interest is using the user root, which probably has access to all databases, that means that if you find vulnerability in the person of interest, then you can access the data of the Voice of the Emperor. That could be, for instance, a problem if you're hosting your server somewhere in the cloud where they are hosting different servers on one machine. And then if one application gets hacked, then your application can be hacked as well. So, but now let's try to get something more. So let's try host user password from MySQL.user. So with this query, we want to dump the available users and passwords of the MySQL database itself. So the server, and go, and at the end, you could see that for localhost, there is a root, and this is its password hash. And there is for the target machine, so that's the host name, there is again a root, and that's the password hash, etc. What haven't we seen before? Oh yeah, there is a user called Encore user, and then the password hash. And there is a VP user and the password hash. So basically, the Encore CMS, which is the Voice of the Emperor, has its own user, and actually WordPress has its own user as well. Just for some reason, it's not used. Instead of that, the root user is used to connect to the database. So for instance, after this attack, you can take these password hashes and start cracking them by brute forcing. We are not going to do that right now, but it could be a good exercise for you. So basically, the union select is a great way to extract data out from the database, because you can then query other tables, even the tables of the database user. Of course, it depends on which user is the application using to connect to the database, because that's going to limit your possibilities. As an exercise, what you can do is try to create a union select injection to find the users of the Encore CMS database. So try to dump the users and password hashes for the Encore CMS. If you're finished, then I will see you in the next lecture. Bye. Hi. In this lecture, we are going to talk about blind SQL injections. So in some cases, you can inject in a query, but you will never see the result. That's why it's called blind, because we don't see the result. So extracting data from the database, it's not as trivial as it was with the union select. So we have to find another way how we could get out data from the database without actually seeing the result. To do that, we have to somehow create queries which either return true or false. It's up to us how we define what means true and what means false. The goal is to make this definition and then tailor a query to that it will return true or false, depending on the question what we ask. And when we have that, we can start asking questions like, is the first letter of the user is A? And then if the query returns false, then we continue that is the first letter of the user B? And when it's false, then we continue. And at some point when it says it's true, then we know the first letter of the current user. Now that's pretty high level this way. So let's look at an example. I go back to Burp and get back to my original request. And if you check the help of the API PHP, it says that there is a parameter called count only, and if it's one, then it only returns the number of results, so not really the data. So if we say here count only 1 and go, and then we just got the count of the post titles, which is 4. So this is now a blind injection, because we can still inject SQL through the title, but we don't really get the data we were requesting, so we just cannot extract the data so easily. Of course, this is just an exercise because we make it more difficult for us deliberately, so we don't have to use here blind injection, but in many cases that's not an option to get the data or not, it's just blind, so it makes sense to learn how it works. So as I said, first we have to define what means true and what means false. So the original request returns the number 4. So let's say that's what we are going to consider true if we get the number 4. And 0 will mean false. So whenever we get 0, we get false. And now we have to create a condition which will return true or false depending on the question what we ask. So let's try to figure out the current username, database username, what we talked about earlier. To do that, we start the injection as before, %, and then adding the additional condition, which will be an AND, because our goal is that if this injected condition returns true, then the result of the whole query is true, and if it's false, then the result of the whole query is false. First, I use the S key. I will just type it in and I'll explain what it means. Substring user equals 97. And then I finish up the query here with semicolon -- space. Now I wanted to first type it in because we have to start from the middle. So we want to find out the username. We get that with the user function. But we will ask always for one letter because we are just guessing and the query will tell us whether it's true or false. To do that, we have to take the first letter of the username. We do that with the substring and from the first letter until the first letter. So that's how we get the first letter. And then with the ASCII function, we get the number, the ASCII code of this first letter, and we test it against 97. 97 is the lowercase a. So if you go to an ASCII table, then you will see that A is decimal 97. That's why we are comparing it to 97. So basically with this query, we are asking a question, is the first letter of the username A? So let's try it. And it returns 0, which we said that's the false. So it's not true. Because what happens is that it's not A, so it's not equals to 97. So this condition is false. And because it was with an AND, the whole condition is going to be false. So it returns 0. Now we can continue with 98 to test whether it's B. It's also not B. So we can keep going like that, but I would rather show you how to automate it with intruder. So send the request to the intruder. Yes. Go to positions, clear, and we'll overlay. Actually, I changed this to back to 97, and we're going to only work with this one. So I select this one as an injection point, and in a payload, I say I want numbers from 97 to, let's go to the table, and we're just going to test the lowercase letters, so until 122. 122, step is 1. You see the 26 request will be sent, and here we just, to the fraction digits, I say 0, 0, so that we always use integers. And we go to options, and I will add a grep match. I will clear this one. Yes, and I want just one requirement, that it contains the air quotes 4, because that's when the response is, for us, means true. All right, and let's start the attack. Okay. And it is running. So these are the ASCII characters tested. And it's running. And there is one result here, 114. You could see in the response, it returned 4. And there is nothing else. So 114, let's go back to our ASCII table, is R. All right, so now we know that the first letter of the username is R. Now let's try the second letter. For that, we have to change here in the substring the starting and the ending character to 2 and 2. Otherwise, the attack is the same, so just start attack. And there is a hit. It's 111. Again, it returned 4. Let's check what's 111. It's O. Now you could keep going. Of course, we already know that the username is root. We have seen it in the previous lecture. And that also shows that our attack actually works. So we found out the first 2 letters of the current username, which was root. But even this one, when we have so much return data, is still kind of a lucky situation, because we still get something back. But in some cases, you don't get anything back from the application, because it uses your input in a query, what it only uses in some kind of calculations. So it queries the database, gets the data back, it calculates something, and then you never see the output in any ways. So then we have to find another way how to figure out whether our query was successful or not, and what's true or false. So the best way to do that is doing a time-based attack. So in this case, we are going to define true, that the response will have a long delay, and false if the response doesn't have a long delay. So we have to now construct our query to somehow include a delay. So I will just delete this one and back until this. So I will do a union select. But only because I want to do an if function, which can be done in a select. And I will type it in, and then I explain what that is. So our condition here is that if the first letter of the username, this is the username, this is the first letter, and then this is the first letter in ASCII, is 97, so it's A, then we sleep for 5 seconds. If it's not A, then we don't sleep. With that, we basically could build in a condition which either sleeps or not. So let's try it. You could see that the response time was 27 milliseconds, so it was pretty quick. So it's not 97. So let's try with 98. Now 24 milliseconds. Now we already know that the first letter is R, so it's 114. Let's try that. And we are waiting. And you could see it was exactly 5 seconds and 27 milliseconds. So it was true that the first letter is 114, which is the letter R. So we could base on our guesses on the delay. Now you can dump the whole database with time-based blind SQL injection. Just it's gonna take some time, and it's pretty complicated to automate it. For instance, we can hardly do the same attack what we did in the repeater, in the intruder, with the time-based attacks, because we have to specify how we decide true or false. Now, different databases have different syntax. So we tested MySQL now, but the point is to understand the concept of these attacks, because whenever you find a SQL injection, it will depend on the query, what's used by the application. It will depend on the database system, what's in use, and also on your creativity, how you're going to exploit it. So the point is that you know your possibilities. There are lots of SQL injection cheat sheets in the internet, which I also use all the time. So whenever you find some kind of vulnerability like this, you can just search for a cheat sheet and try to figure out how these kind of attacks would work in that environment or in that situation. All right, in the next lecture, we are going to talk about automation, because as you could see, these blind injections are pretty difficult to dump a lot of data without automation. So we will see that in the next lecture. See you there. Hi, in this lecture we are going to talk about automating SQL injections. Now, discovering a SQL injection manually is quite alright, but actually extracting a lot of data, that's pretty much pain in the ass if you want to do it manually. But luckily for us, there are lots of various tools which can help in automating SQL injections. The tool we are going to focus in this lecture is the SQL map. That's a very well-known SQL injection tool with a pretty extensive feature set. So I think it's really important that you get to know this tool, and then you can discover other tools by yourself. So let's start. Probably you have already guessed that it's a command line tool. So you can just say SQL map -minus help. Which gives you back all the possible command line switches. As you can see, first there are quite a few parameters to define the target and then put the request together. Like you can create your request using SQL map, telling it the method, the data, cookies, refer, host, whatever else you want. And then you could also specify that the injections want to use, or which techniques should be used. And at the end, you can tell what you actually want from the database, whether it's just the current user or all users, or dump the whole database, or you can even try getting an OS shell or even a SQL shell. So there are much to do here. We are going to test with the simplest way possible. But as I said, the tool itself is pretty extensive. So as I mentioned, you could create your request using the parameters, but what I really like with SQL Map is that you can just go to Burp, and I will just take the original request, which was this one, and you can say right click, copy to file, and I will copy it to the normal.sql. It's just a text file. I just called it SQL injection. Save, and yeah, I overwrite it. And then when you come back to the command line tool, then you can say SQL map -l. That's to take it from a log file, and the file is the normal.sql. So --dump all. So we'll try to dump the whole database with every database and every table and everything in it. So let's start. Since I didn't configure everything, whenever some question comes up, SQL Map will ask it. So it sees that it's a MySQL, so we can just focus on that. That's a great idea. So I will do just yes, and I will also extend the risk levels. So you can see SQL Map tells which kind of attacks it is trying, and now it runs. Because I asked for the whole database, it will take some time. I will try to speed it up when nothing happens. Yeah, now it tells us that the title is vulnerable, which we knew, and that's great. Do you want to keep testing for others? No, actually right now we don't, but in a normal assessment, you would want to find all the possible injections. So you can do that in a normal assessment, but right now we just stick with the title. And then it asks whether we want to exploit it. And yes, we want. So it's dumping the database now. These are the tables dumped. It tells you that it saves it here under the .sql map folder. And now it's running. No, I don't want to store the hashes. No, I don't want the dictionary attack now. It says that we might have been blocked, but I don't think so. So I will just let it run. It's still doing something. No, I don't want to crack. I just want the data. And it finished. So it took some time, but we actually dumped the whole database. That's awesome. But if you go into the .sql map directory, there is output, there is the IP address, and here's our dump. And these are the databases which were dumped. So you could see the VPDB is the WordPress database, and the MySQL DB is the database of the MySQL, and the Encore DB is the Voice of the Emperor database. So for instance, if you go to Encore DB, then you can say Encore users.csv. Then you could see these were the users of the Voice of the Emperor. Here's the password hash, username. So basically that's what I told you in the other lectures, that using the SQL injection in the person of interest we can actually access the data of the Encore CMS, so of the voice of the Emperor. For some customers, this is a worst case scenario, even if it's not another application, but like if the application is used by two different companies and then you're able to access the data of the other companies, that's like the worst. Like imagine that your company is using Gmail Pro, and of course other companies are also using Gmail Pro, and then you find a vulnerability what you can use to access the emails of the other company. That's pretty bad. But this is exactly how such things work. Now we can also try to exploit the blind SQL injection. As I said, it's actually more important for the blind injection to be automated because it takes a lot of time. So I can just create a request for that. It's account only equals 1. Yes. So this is the request what we want to use. So copy to file. I have this blind.sql save. Yes. So I will just do SQL map -l and then define blind.sql, and then I will just dump the users because the database users, because otherwise it would take really a long time and probably you don't want to watch this in a video. So let's just start with this. Yes, URL is found. Let's test that. Yes, we want to test this injection. So it says time-based comparison requires larger statistical model. So it's doing it. Yes, let's optimize. Now, as you can see, it started to figure out the username. It already figured out the first 3 letters. And that's how it's gonna go. As I said, it takes some time. But let's speed it up a little. So as you could see, the first username was brute forced. So I will actually cancel it right now because it takes a long time. So you can see the blind SQL injection attack is something you want to do during the night and leave it there to run. But it is still much more efficient than doing it by hand. So there is one more thing I wanted to show you, and I'll just use the normal injection, and I will ask for a SQL shell. Yes, inject, and then we get a shell. So basically we can here do simple SQL queries ourselves. So we type in the SQL query we want to execute, and then SQL map sends it to the server, putting it into an injection query, and then we get the results. So this way we can interactively communicate with the database through this SQL injection, and SQL Maps makes this available for us. So it's a pretty cool tool. As you could see, there are lots of things what this tool can do. So I recommend you to play a bit more with the tool, experiment with the various features, think about how would you use that in an assessment. And when you're finished, then I will see you in the next lecture. Bye. Hello there. In this lecture, we are going to talk about the server-side attacks and server-side injection mitigations. When you're accepting data from the user, you have to be aware that the user might be malicious. So first and foremost, you have to know your inputs. You have to know exactly at what input field, what kind of data you're expecting. And make sure that you don't accept anything else, just what you wanted. So if it's an input field for a name, then just accept names. If it's an input field for full email addresses, then make sure that it's just an email address and nothing else. When you're using data in the application, you have to always think about where this data comes from. Because sometimes you just load the data from a database, and for you, it's just some random data of the application, but maybe at some point it was created by a user, so it can be still potentially malicious. For instance, I've seen once a cross-site scripting attack where the web application was just showing the system logs on the website, but you could make a cross-site scripting by loading a URL with a malicious string in it. And even if this URL didn't exist, it was logged by Apache in the system log. And when this log file was loaded in the application, then the cross-site scripting was triggered. So the programmer thought that the log files are secure because they are just files on the server, and didn't think about that the data inside the log files can still come from the users, even from malicious users. So think about where the data comes from, and if you think that it can be malicious, then do the appropriate checks. Actually, it's even better if you always do checks without thinking about whether it can be malicious or not. Most of the programming languages and frameworks offer some kind of features or functions to escape strings before using them, for instance, in SQL queries. Also, regarding to SQL injections, you can create prepared statements, which means that instead of concatenating the query together, the parts of the static parts of the query with the user input, you can create a query object and then fill out the blank spots by adding values to the query object. In this case, the original query string and the inserted values are kind of kept separate, which usually stops SQL injections, although there are always some kind of bypass attacks, but the risk is much lower. You can also use various frameworks which wrap the whole SQL communications. So for instance, what we've seen in Django, that's something like that. Because in Django, you're not dealing with the SQL server directly. So you're not writing SQL statements, you're creating a Django model, and you do all the communication with the database through this Django model. So basically Django takes over the database management for you. And in this way, Django itself can implement security mechanisms against SQL injection and various attacks. So using such a framework can decrease the risk of a single programming failure, and you also enjoy the constant support of the community. With this, you are finished with the server-side attacks section. As always, I recommend you to stop a little bit, recap what we've done together, and as always, experiment a bit more. But otherwise, congrats for finishing this section, and you're almost at the end of this course. So I will see you in the next section. Bye. Hello. So in this lecture, I wanted to talk about reporting. I know this is nobody's favorite subject, but the thing is, if you really want to work professionally, then you're not just selling security bugs, you're selling security bugs dressed up in nice reports. So because of that, I wanted to give you a few tips. First of all, the report is the only outcome of your assessment. So this is the only thing what makes your customer come back with a new project. So basically, if your report is bad, then your work was bad. That's it. With that said, let's see a few things which you might want to put in your report. So first, data about the customer and you. like contact data, responsibilities, who is the document owner, etc. Then an executive summary. This is basically summarizing the results of the project for people who are not going to read the whole report. There will be quite a few of them. This should give a general idea of the overall security and mention the most critical problems and their impact. Then the third is the scope of the assessment. The scope had to be laid down at the very beginning of the planning phase. So here you just write down what you decided then. So what you were going to test and what you were not going to test. That's very important because that's how a user knows what was out of scope and what was in the scope of this project. Then you will probably have disclaimer. So probably you want to cover yourself legally in your report. So security is always a really sensitive topic. So you have to make sure that you are always cover yourself. And the disclaimer is exactly for that. Here you can tell anything what you want to the customer, which will protect you. Then there could be various other chapters like methodology, means how you were going to do the test or what's your testing process, etc. About cleanup, etc. And the sixth is the most important, the findings. So in this chapter, you describe all the findings which you found during your assessment. So let's talk about the findings. There are a few stuff that every finding should have. For instance, obviously a name. This is just to differentiate between the various findings. Then a risk. This can be critical, high, medium, low, and maybe information. The risk is basically a combination of the exploitability of the finding and the severity of the finding. The next one is a summary. As I said, there will be many people who are not going to read the whole report. They're just going to read the executive summary and maybe the summaries of each findings. The summary should summarize this finding in a few sentences, and it should tell what is the root cause of the problem and what's the impact of the vulnerability. And then come the finding description. This is basically where you give every information about the vulnerability, what you can. So this should tell why the problem happens, what is really the vulnerability, a proof of concept attack with screenshots, a clear guide how to reproduce the problem so that the developers can test it themselves, and basically anything what you find important to describe this exact vulnerability. Then you can have an exploitability, which basically explains in a few sentences how difficult it is to exploit this vulnerability and what the attacker would need regarding to skill set or technology or access rights or whatever to exploit the problem. And the last one is severity. This basically explains the impact of the problem. So what can an attacker do when he exploits this problem? Can he just read data, or can he also write data or change the application? Whatever. So here, this is the scenario what an attacker would do when he exploits this problem. So some companies have different fields or even more, but I think these are the most important. Also, your readers might be technically skilled people, but probably not security-wise skilled. So you might not have to explain what an HTTP request is, but when it comes to security stuff, then you have to clarify everything and you have to be really clear in your descriptions. All right, I think you might have already fallen asleep, so I will just finish up here and I will see you in the next lecture. Bye. Hello. In this lecture, we are going to talk about the web application assessment checklist. So I like to use some kind of checklist when I do an assessment. It's it's rather a guide than really rules what to do. It's why I like it is because it reminds me to the things which I have to do. So when you start assessing an application, there could be some interesting part, which is where you go down really deep and you play a lot, you spend a lot of time with that. And then later on you are like, oh, I should do something else. And then the checklist will make sure that you are not leaving out necessary parts of the testing. So it's basically a guideline for you, which tells you what kind of things you should be looking at. And if you're doing an assessment and you have this checklist next to you, then you can just take all the points and go through everything. You don't have to spend a lot of time on some parts because sometimes it's not really relevant for the application. The point is to think about whether that kind of attack or those kind of vulnerabilities make sense in case of that application. If they make sense, then you should look into them. And the checklist makes sure that you don't forget these. So I made this checklist for you. I use a similar one for myself at work, but I made this for you so you can use it in your project. Well, I recommend that when you start a project, just take a new empty checklist and use it for that project. You can save it with your project as well, so that when the customer sometimes asks whether you tested this and that, then you can look into your checklist and say, yeah, I did. You see, it's in my checklist. But let's quickly look into it. So this is the checklist. As you can see, it basically covers most of the things we talked about, actually more. So it starts with information gathering, manual, automated. Then you go into the session management vulnerabilities, all these things we talked about. And then authentication, authorization. And then comes this client-side attacks with cross-site scripting, whatever. Server-side attack, business logic attacks. We didn't talk too much about business logic attacks, but it's an interesting thing as well, but I didn't consider it as important as the rest of the things. And then information disclosure. So what I recommend you is you don't have to follow exactly this order. Just make sure that when you're doing an assessment, you actually covering all these things. You can, when you say that the application looks really vulnerable to client-side attacks, then you're welcome to start with client-side attacks. The point is to, at some point, get back to session management. What I really recommend is whatever happens, start with information gathering, because that's going to tell you what is really your attack surface. Also, as I said, there are a few things here which we didn't talk about. Now, in the next lecture, we'll talk about what you should do next, but a really good starting point is the things on this checklist which we didn't talk about. Because basically, those things are attacks or vulnerabilities or topics which I didn't see necessary to put into this course, but I still see them necessary to be on your checklist. So I recommend you to look through this checklist, and when you see something which you don't know what it is, then start Googling it, start researching it. It's an interesting topic anyways, but it's not that critical that it should be in this course. If you have any questions to this checklist, then let me know, put it in a comment or in a discussion, or write me, or however you like. So that's all I wanted to say. To summarize it, when you do an assessment, just take this checklist. You can either print it out and do it manually, or just click it in this checklist and then save it. And it's going to be a good record for your assessment, what you can also show to your customer when they are asking for something like this. All right, that's all for this lecture. So take care and see you on the next one. Bye. Hello. First of all, congrats for finishing this course. You are awesome. If you tried everything yourself and followed along the whole course, then I'm really confident you could do a web assessment alone. And that's what you should do. You will be never really ready. In this profession, there is always something new to learn. There's always something new to try. So the important thing is that you keep learning and keep practicing and just doing it. Many people ask me what they should do after this course. what I think is the most important to actually start testing. Of course, never without permission. The thing is that if you really do this professionally, you can earn a decent money, and there's just no reason to go black hat and do anything illegal. So I'm really recommending you to become an ethical hacker and do this to make the internet a better place and a safer place. But even if you don't care about the internet being secure, you can earn a decent salary with this, and you will be happy with that if that's important for you. But until you get a job, you can still do a lot of things to practice. First of all, you can take any open source applications. For instance, the applications which we tested during this course, they are all open source software which I modified to be insecure. And you can just download any open source application, install it in your own environment, and start testing it. When you discover vulnerabilities, then you can also report it to the developers, and that way making that application more secure. But please, when you're telling somebody that their software has a vulnerability, please don't be a jerk. Just be objective, clear, and honest. Sometimes they are going to be a jerk because they will feel offended that you tested their applications, and then you tell them that their software is not good enough. At that point, you will have to be just patient and prove that you're right. But if it doesn't work for you, you can just let it go. And you told them it doesn't make sense to fight forever. But the point is that sometimes there are going to be discussions because people doesn't like when other people telling them that what they did is wrong. Just be prepared. Also, to practice, you can do bug bounties. Bug bounties are basically offered by many companies who say that if you find a security hole in their software, they will either just thank you for it, or there's a hall of fame, or some companies may even pay for it. Lots of companies offer bug bounty programs like Facebook or Google and many others. You can just Google for bug bounties, or you can come to this URL, and here is a whole list of available bug bounties, even Apple. Here you can see that whether it offers a reward. Swag is basically you get a t-shirt or something. And Hall of Fame is that you will be shown on their website that you are contributing to their security. A very important thing with bug bounties that you actually read their rules, how you're allowed to do bug bounties, and follow them. First, because that's also a way how they can make sure that your testing is not affecting their users. And it's also for you to make sure that if you find a problem, then you don't lose your reward just because you didn't follow the rules. There are also a couple of websites which allows you to test applications also for bounties. For instance, Bugcrowd is one of them. I don't have any affiliation with Bugcrowd, I just think it's a good idea. So you can go there and you can check it out and see what you can do there. And of course, Capture the Flag is the well-known way of learning security, or more practicing security. For that, a good website is the ctftime.org. That's basically a website where all the Capture the Flags happening around the world are collected, and the Capture the Flag teams are tracked and rated. Of course, in Capture the Flags, it's not only about web. There are also lots of different topics, but it's a really great way to learn new topics. So if you're interested in other areas of security, not just web applications, then you can do Capture the Flags and start discovering those areas like that. Also, there are lots of write-ups you can read, which tells you the solutions for that specific challenge. Of course, I have to warn you that some of these challenges are pretty difficult. So if you happen to not be able to solve any challenges, just don't be disappointed. They are supposed to be difficult, so just keep trying and keep learning. And also regarding to finding a job, I recommend you that whatever you do, whether you do Capture the Flags or whether you do bug bounties or you just test open source software, I really recommend you to write about it or share it somehow on the internet, like writing a blog or doing videos or anything like that. Because the thing is that when you are applying for a job, nobody really cares about whether you have a master's degree if you can actually prove that you are doing this already. So that you're hacking and you're finding vulnerabilities already. If you're on the Hall of Fame of a famous company, like on Facebook, and you're applying for a job and you just send them the URL for the Facebook Hall of Fame, or you just send them the URL to your blog where you write about vulnerabilities and attacks and just technologically interesting topics, then the people will actually see what you do. And I think these are much better credentials than having certificates or having degrees or whatever. So to summarize it, just learn and practice and write about what you learn. So thank you very much for doing this course with me. It was an honor. And if you would like to keep up with my work, with my future research or courses or articles I write, then the best way to do that is to sign up on my mailing list. You can find it here. And I hope I will see you somehow in the future. And before I forget, I would be really, really grateful if you wrote a review about this course. Just tell me what you liked, what you didn't like. And of course, I will be available for you in the future. So if you have any questions or anything, just write me. So for the last time, thanks for watching and keep hacking. Gary out.
Yep. 只要个把分个我。